In this video, we will solve UGC NET Computer Science and Applications December 2023 Paper 2 question paper. Let's start with Unit 1 Discrete Structures and Optimization. What is the probability that a positive integer selected at random from the set of positive integer not exceeding 100 is divisible by either 2 or 5? When you consider integers, you have negative numbers, you have 0, and then you have positive numbers. When we say it's a set of positive numbers, it means it starts from 1, and they say not exceeding 100. It means the limit will be 100. You should not go above 100. They are asking it should either be divisible by 2 or by 5. So let's see the numbers that are divisible by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98, 100. In this, we can also understand that 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, they are also divisible by 5. So 2 and 5 combo is also available in this list. Now let's see what are the numbers divisible by 5. This list has 5, 15, 25, 35, 45, 55, 65, 75, 85 and 95. In fact, 10, 20 should also accompany in the list of divisibility by 5. But since I have included in divisibility by 2, I have not included in 5. So altogether there are 60 numbers. So there are 50 numbers in divisibility by 2 and 10 numbers in divisibility by 5. So altogether we have 60 numbers that are either divisible by 2 or divisible by 5. So what are the total count of numbers for which we have to take the probability is 100. So the probability will be 60 divided by 100. So when we cancel the zeros, then 2 3s are 6 and 2 5s are 10. So we have a probability of 3 by 5 for a positive integer to be selected at random from the set of positive integers not exceeding 100, which will be divisible either by 2 or 5. Option number 2, 3 by 5 will be the right answer. This is the direct way of solving. If you get into the formula method, we have a formula called probability of A union B, which is equal to probability of A plus probability of B minus probability of A intersection B. This probability of A will include numbers which are just divisible by 2. This probability of B will include numbers that are divisible only by 5, and probability of A intersection B will be that are divisible by both 2 and 5. And this probability of A union B will give you the probability that the number is divisible by either 2 or 5. Probability of A will be 50 actually. So we have to take it as 50 by 100. So 50 numbers are divisible by 2 alone. This list that I have given here does not include 10, 20, 30 because since it was already available in divisible by 2, I did not include this. But to take the probability that has the numbers that are divisible only by 5, I have to include this list. So this will give me altogether 20 numbers. So 10 from this column and 10 from this column. Now the intersection part is actually this set of 10 numbers. They are actually divisible by 2 as well as by 5. So I have to write here as 10 divided by 100. So altogether 50 plus 20 will give me 70. 70 minus 10 will give 60 divided by 100. Even if you go by formula method, you get the same answer, 3 divided by 5. Next question, if universe of disclosure, actually it is universe of discourse, are all real numbers, then which of the following are true? Not only in this question, even in the upcoming questions you can find the word disclosure. Many mathematical statements assert means they declare that a property is true for all values of a variable in a particular domain. called the domain of discourse or the universe of discourse. It means when they say it's a universe of discourse of all real numbers, it means a particular proposition or a particular expression that is given in the option is true for all the real numbers. We have natural numbers, we have whole numbers, and if we take integers, we also have negative numbers included. Then for real numbers, we also include the fractional parts like 1 by 2 or 3 by 5, something like that. So real number will include even decimal related numbers. It means floating point numbers, as in programming context we used to say. So which of the following are true? Actually, this question is available in Kenneth Rosen's Discrete Mathematics 7th edition book as a exercise question. And regarding this question, what was the actual question that was asked in the book was, translate these expressions into English statements. This was the actual question that was available in the book, but here they are asking which of the following are true. So in order to understand what these expressions mean, first we will translate them into normal English words. Then we will find out whichever is true. First statement. So when we say there exists, it means there is a number or there exists a number or for a particular value or number. So this symbol means there exists, and this symbol means for all, for every. Inclusion of everything is this symbol, and telling that something is existing is this symbol. So now we will translate this. There is a real number x such that for every real number y, the sum of x and y will be equal to y. So here we can consider x is a real number. So let's take x is equal to 0. So 0 is also a real number. And let's take y is equal to any number. I mean, it should be applicable for all real numbers. You have to include all real numbers. You take y is equal to 1 for example. Anything that you add with 0 will give you the same number y. So when I say 1, it is 1. When I say it is minus 1, then you have 0 minus 1 is equal to minus 1. When I say it is 3 by 2, 0 plus 3 by 2 will give you 3 by 2 again. So whatever number you add with 0, you will get the same number. Now just apply this to the expression. There is a real number x. It means x can have at least one value. X has a value of 0 in this particular statement. So this there exists a real number is true. When I am applying this x value 0 to any number that is available in the real number set, it will give the value of the same number. So this statement is true. Whenever I add any number to 0, I will get the same number. So I can say that this statement is true. So A is true. Now we will translate the next statement. This statement states that for every real number x, it means for every x value, and for every real number y, they have given a condition. When they have given some condition, you have to take this as, if these two conditions are true, then this implies operator will tell you then this condition is also true. So now we will translate. If x is greater than or equal to 0 and y is less than 0. So let's take x is equal to 1 and y is less than 0. We will take it as y is equal to minus 1. That is, this statement says that for real numbers x and y, if x is positive and y is negative. So x is positive and y is negative. When they say x is greater than or equal to 0, this states that particular number is going to be positive. When they say y is less than 0, it means it is a negative number. Then they say x minus y is positive, which they have marked as greater than 0. So we will just subtract this. 1 minus of minus 1, this is x minus y, which is equal to 1 plus 1, it will give 2. This states that it is greater than 0. So whenever I use subtraction with a negative number, any negative numbers, even if you have minus 10, when you have minus of minus 10, it automatically converts into plus 10 or plus any number. So when you have positive number this side and when you use subtraction with a negative number, this will be positive number plus this particular positive number. So positive and positive will always yield a positive value, which states that statement B is also true. Now we'll get into the C statement. There is a real number X and there is a real number Y. It means you can have even a single value. X is less than or equal to 0 and Y is less than or equal to 0 such that X minus Y is greater than 0. They say that X minus Y is positive when X is negative and Y is negative. Let me take a number minus 5 for X, and for Y let me take something like minus 10. Now when I subtract X minus Y, this will give me minus 5 minus of minus 10, which is equal to minus 5 plus 10, and this will give me 5, which is ultimately greater than 0. So this statement is true only. Now they are saying there is a real number X and real number Y. It means it is not applicable for all X. Not for all X and not for all Y. It is for any number. So here I can say X has a value of minus 5 and Y has a value of minus 10. At least one value is there. Now let's apply this for 0 and see. X is equal to 0 and Y is equal to 0. And they say X minus Y is greater than 0. This fails for this particular value. But here the statement is there exists. When they say there is some value, it means there can be at least one value available. And we have a combo like minus 5 and minus 10 to make this statement true. This is more than enough. In case if the statement is for all X and for all Y, we can mark this particular expression to be false. But when it is there is a number and there is a number, this turns out to be true for at least one pair of values. So C is also true. Now let's translate the D expression for all X and for all Y. So here for every real number X and for every real number Y, if X is not equal to 0 and Y is not equal to 0, it can be of any number but not 0. If and only if, so by implies operator will be translated as if and only if their product is not equal to 0. So when I say X is not equal to 0, it means just take X is equal to 1. And when they say Y is not equal to 0, it is also equal to 1. If and only if X into Y not equal to 0. This will give X into Y as 1. When will we get a product to be 0? If a product is equal to 0, it means one of the operands should be 0. Either X or Y should be 0. Only then you will get a product of 0. When they say the product is not equal to 0, it means neither of the values are 0. It means X is also not 0 and Y is also not 0, which makes this statement also to be true. So D is also true. In this case, we are marking option number 4, A, B, C and D only as the right answer. So the book content will be like they will start with converting English statements to mathematical expression and then mathematical expression back to English statement, so that you will learn to write any statement in the form of quantifiers. So we will call these symbols as quantifiers. You are saying how much of the values are true or how much of the values are applicable for this. This will come under predicate logic and under the topic quantifiers. So in quantifiers, they will say how to convert normal English statement to quantifiers and expressions carrying quantifiers to normal English statements. So since that was the exercise, they have just altered the question as just mark which of the following are true. Now we'll move on to the next question. If the universe of discourse is a set of integers, now integers means you have to include negative numbers, 0 and positive numbers, then which of the following are true? This was the exact question that was found in the same exercise part of Kenneth Rosen's Discrete Mathematics book. Now we'll start with A. This statement is saying for every value of n, there is an integer m that is bigger than n square. Let's take 10 square, which is equal to 100. Now m is also an integer. What if m is going to be 999? Here m is only greater. It means for every n value, we can have a different m value. So this statement can be taken as no matter how large n might be, we can always find an integer m bigger than n square. This is certainly true. For example, we could always take m is equal to n square plus 1. When we have n square is equal to m, it means both the values are equal. When they say n square is greater, it means at least it is having plus 1 value extra than m. Here you cannot go with points because they are talking about integers. We can just increment it by 1 or decrement it by 1. In case n square is less than m, it means m is having at least one value greater than n square. So in this case, I can translate this as m is equal to n square plus 1. So now just apply this. N square is less than n square plus 1. So instead of m, I am just substituting this expression here. So this is true, right? So that's why they have given this expression. So A is true. The only option that has included option A will be option number 1. Option 1 will be the right answer. A, B, C are true. Now we will just check. So this statement says there is a number n that is smaller than the square of every integer. Note that n is not allowed to depend on m since the exponential quantifier comes first. So which quantifier comes first matters a lot. This statement is true. Since we could take for example n is equal to minus 3, then we will have m is equal to 1. N is less than m square. Minus 3 is less than 1 will be true. Since squares are always greater than or equal to 0, m square is greater than n. This is just a reverse of A statement. Here instead of all n and n square, where they say it is less than for a particular m, here they are reversing like for a particular n, every square will be greater. So this makes sense and of course this turns out to be true. Now if I want to say n is equal to 0 and m is equal to 1, even now we can say 0 is less than 1. 1 square which is equal to 1. So this statement is also true. B is also included. Now there exists a value n. For all m, n into m is equal to m. Which number has to be multiplied by every number so that we get the same number? Here n is equal to 1. For any number m, you will get m into 1 is equal to m. If it is 10, you will get 10. If it is minus 3, you will get minus 3. If it is 0, you will get 0. In the previous question, we saw if x is equal to 0, anything that is added to this 0 will give you the same number. The same case is here. Anything that you multiply with 1, you will get the same number. So C is also true. So here the there exists is applicable for n, for which I can say n is equal to 1. Now we will get into D. They have given a particular equation. There exists a number n and there exists a number m. It means they can take a particular value also. N square plus m square is equal to 6. So if I take 1 and 1, it will give me 2. Then if we take 1 square and 2 square as 4, it will give 5. Then if we take 2 square 4 plus 2 square 4, it will give 8. There is no possibility that we will get 6. Which numbers, when they are squared and added together, they will give 6. There is no such number available for a particular value of n or particular value of m. There is no way that you can get 6. That's why D is out of the choice. So D is actually false. Next we will check E. There exists a number n and there exists a number m. So n and m can take a particular value where n plus m is equal to 4 and n minus m is equal to 1. Now we have to randomly check if some number is going to give you 4 and their difference is going to give you 1. For which number it will get satisfied is they have given some values. So this was available in the solution book. I just used the same thing. When n is equal to 2.5 and m is equal to 1.5, we can get the value of the sum to be 4 and the value of the difference to be 1. This is right. But what is n and m? They have given the universe of discourse as set of integers, which means no fractions have to be included. Only negative numbers, 0 and positive numbers should be included. In that case, 2.5 is not an integer, 1.5 is not an integer. If this is a discourse of set of real numbers, this statement could have been marked true because I at least have one n value and I have one m value. If this was a part of real number, this is going to be true. But since the question is this is a part of integer, we will mark this as false. So statement E is also false. If n is equal to 2.5 and m is equal to 1.5, this will satisfy n plus m is equal to 4 and n minus 1 is equal to 1. By algebra, we see that this is a unique solution to the particular equation. Since they do not exist integers that makes the equations true, the statement is false. So D and E are alone false here. So we are marking option number 1, A, B and C to be true. Here I would like to tell you one more information. As per the official answer key, option 2 was declared as the right answer. So only B and C were declared as the right answer in the official answer key, but the actual answer will be A, B and C. This is actually taken from the respective discrete mathematics book solution. Next question, if n square is equal to n into n, where n is the set of natural numbers in the sense 1, 2, 3 and it goes on. So natural numbers will be 1, 2, 3, whole numbers will be from 0 and integers will be negative numbers, 0 and positive numbers. Minus 2, minus 1, 0, 1, 2 and it goes on this side too. And R is a relation on n square. Show that R belongs to n square into n square. That is, variable x, it's a natural number. Variable y, it's a natural number. Again, variable u, it's a natural number. And variable v is a natural number. Now just represent this as a relation. X comma y relation u comma v states that x into v equal to y into u. X is also a natural number, v is also a natural number, which is actually n square here, n into n. And similarly, y is a natural number and u is a natural number, so this is also n square. Now they are asking which of the following are true. They are asking us to check for reflexive, symmetric, transitive and asymmetric. Let's see what is reflexive. A relation is said to be reflexive if for every element A that belongs to a set A, we have A comma A that belongs to the particular relation. Let's check for reflexive. Now this is X, this is Y, this is U and this is V. So XV is equal to YU. So in place of X I have X, in place of V I have Y, which is equal to, in place of Y I have Y, in place of U I have X. This is also equal to X into Y. So XY is equal to XY, which states that reflexive property is true. So A is true. Now I can rule out second option because A is not present. Now we have to check for symmetric property. So when we have to check for symmetric property, we will also see about asymmetric and antisymmetric. So a relation is symmetric if for all x comma y that belongs to R states that y comma x also belongs to R. So this is the condition of symmetric. When it is asymmetric, it means that y comma x will not belong to R. So the exact opposite of symmetric will be asymmetric. So if I take 1 comma 2, then 2 comma 1 must also be a part of R. But in asymmetric, if I say 1 comma 2 belongs to R, then 2 comma 1 will not belong to R. This is asymmetric. Then what is antisymmetric? Here the cases x and y are not equal. In case they say x comma y and y comma x both belong to R, It means the antisymmetric property states that x must be equal to y. So what happens if x is not equal to y? Then the asymmetric property will be true. So if x is equal to y, symmetric property will be true. If x is not equal to y, the asymmetric property will be true. But how have they rephrased it is, if x comma y belongs to R and x is not equal to y, we can state that y comma x does not belong to R. So they have rephrased in this way. I thought that these statements would give you a clarity on symmetric, asymmetric and antisymmetric. That's why I've included them. Now we will check for symmetric. So let's take x comma y relation u comma v, which is equal to xv is equal to yu. Now we can write this as yu equal to xv, and I can interchange this as, make this as ordered pair. So instead of x I have u, instead of y I have v, relation instead of v I have y, instead of u I have x. So this particular x comma y as of now is equal to y comma x, which says that symmetric property is also true. So we can mark B to be true. So A, B are included. We have to check for C to find whether it is option number 1 or option number 4. So option 3 can also be ruled out. So let's check for transitivity. Say for example, if x comma y relation u comma v and u comma v relation a comma b, which implies that x comma y relation a comma b. So this is like if a comma b and b comma c, then it is a comma c. Now we have to prove this. So let's go with the first part, x comma y relation u comma v, which states that xv is equal to yu. Then we have u comma v relation a comma b, which states ub equal to va. Now we'll just equate both the things. So left hand together in one side, xv, then we have ub, then right hand side together, yu and va. X UVB or VUB, which is equal to YUVA. So UV and UV can get cancelled here. So ultimately we will have XB and YA. Now change this as relation. You will have X comma Y relation A comma B. When you equated these two as right hand side and left hand side, you get this. So transitivity property is also true. So from this we can say asymmetric property is not there. We can rule out even option 1 here. So we'll go with option 4. A, B and C only will be the right answer. Asymmetric is stating that there is no y comma x, but here since it's a product, we are just making it as y into u as u into y, and since this is also a product, we are making it as v into x. So we have an option to change this because it's just a product. Since this symmetric property is possible, we can never say that y comma x does not belong to R when it comes to multiplication, because 1 into 2 will give 2, 2 into 1 will also give 2, 3 into 2 will give you 6, 2 into 3 will also give you 6. So in case of this particular x into v and y into u, which comes with multiplication, asymmetric property cannot be true. That's why we are ruling out D, asymmetric option from the list. So let's see the transitive property. If A comma B belongs to R and B comma C belongs to R, then A comma C also belongs to R. So this is what I have mentioned as A, B, B, C and AC. Next question, which of the following are tautology? Tautology means when you take a truth table, the final column, the result column should have 1 everywhere. So to check for tautology, we have only one option. You have to draw truth table. On the whole, you can even simplify the expression. But at last, when you apply this in truth table, it should end up with 1 in the final result column. Tautology is always true for every value of its propositional variables. Now we will just see the truth table of certain operations. If we take P and Q alone, you have 4 set of values. So 0, 0, 0, 1, 1, 0 and 1, 1. When you take P and Q, whenever both P and Q are 1, you will have 1. Then we have P or Q. Whenever P and Q are 0, we will have 0. The rest of the case it is 1. Then we have P implies Q. It means if P then Q. P implies Q will have a truth table like when P is equal to 1 and Q is equal to 0, only in that case we will have 0. Rest of the case it is 1. At least you should know this basic set of truth table, only then you will be able to work for this question. So let's get into the A option. P implies P and Q. The result implies P implies Q. First we will find this P implies Q. So we have 1, 1, 0, 1 from this particular column. Then we have P and Q we will solve. So P and Q will be 0, 0, 0, 1. So 0 into 0 is 0, 0 into 1 is 0 again, 1 into 0 is also 0, 1 into 1 is 1. Now we will find for P implies P and Q. So what is P here? 0, 0, 1, 1. What is P and Q? 0, 0, 0, 1. Now what is P implies P and Q? So 0, 0 I will have 1, 0, 0 I will have 1. When it has a combo of 1 and 0, as in this case, I have to mark this to be 0, and 1 and 1 will also give me 1 only. So only in this case I have 0, consider only this. Now result of P implies P and Q. This will have the values 1, 1, 0, 1. What is P implies Q? 1, 1, 0, 1. So here we will have it as 1, 1, 0, 1. Now we have to find implies operation here. Just check the first value should have 1 and the second value should have 0. Only then you will have 0. So you have 1 and 1. Here it is 1. Then you have 1 and 1. Here it is 1. Then you have 0 and 0. It is 1. 1 and 1. It has 1. So did you get 1 in the final result here? This is the final result column. So is everything 1? It means A is a tautology. So whichever options did not include A will be ruled out. Now we have to check if B is tautology or not. That will be more than enough for this question. So let's check B. So the B expression will be P implies Q implies Q implies P or Q. So first we will go with P or Q. P or Q will give you 0 or 0 is 0, rest will be 1. Then P implies Q will have 1, 1, 0, 1. So let's go with P implies Q. We'll just place the values here. Then we have Q here. So only the Q column. 0, 1, 0, 1. Implies operator between 1 and 0 will alone give you 0 as per this table. So this alone will be 0. The rest of the places it will have 1. So this is the final value of this column. So let me place this instead of this particular expression 0, 1, 1. Then we have P or Q. So place 0, 1, 1, 1. The value from this column. Now we have to use implies operator again. So which value will have 0, 1 and 0. So such case is not existing. So we will have 1 everywhere. Which means the final column, the result column is having 1 everywhere. Which means that B is also a tautology. So B is also right. From this we can say 1 and 2 are ruled out. Option number 3, A and B only will be the right answer. So for this question they have made it very simple that C and D are not tautology. So this is going to be false only. But in case if you want to check C or D, how should your truth table look like is, you have to use 8 set of values. So basically, when it is only one variable p, it is just 0 and 1. When it is p and q, it becomes 0, 0, 0, 1, 1, 0, 1, 1. 2 power 2 which is equal to 4. So this is 2 power 1 which is equal to 2. This is 2 power 2 equal to 4. When it is 3 variable p, q, r, this is 2 power 3 which is equal to 8. When it is 4 variable p, q, r, s, 2 power 4 is equal to 16 set of values. So here you will have 4 zeros, then you will have 0, 0, 0, 1, 1, 0, 1, 1. Then for 4 set of 1 values, you will have 0, 0, 0, 1, 1, 0 and 1, 1. So if you have to check, then you have to find not p, then p or not p, then implies with q, then p or not p, that implies with r value. So you will need r value definitely. Similarly, this is also having r. So for practicing purpose, please do make truth tables for C and D in your notebook and learn to calculate this in a fast way. It's just my suggestion and also a kind of consideration to tell you that please practice 3 variable and 4 variable truth tables as much as you can, so that at times when you need, you can make use of truth table to easily solve some problem instead of going for simplification. So sometimes they will give you an expression in the question and ask you which expression is equivalent in the option. Sometimes we will not be able to simplify the expression due to stress or anxiety in the examination. At that time, you can use truth table method to easily find out which final columns are equal and say which is the answer. Next question. The statement P of x is equal to x square. If the universe of discourse consists of integers, which of the following will have truth values? So let's take P of 0. So here instead of x they have given 0, which means P of 0 states that 0 is equal to 0 square. So 0 is equal to 0. This is true. A has truth value. Then we will go for x is equal to 1, P of 1, which is equal to 1 is equal to 1 square. So this is x and this is x square, which says that 1 is equal to 1 and it is again true. This is also fine. Now we will check for P of 2. X is equal to 2. P of 2 states that 2 is equal to 2 square. No. 2 is not equal to 4, which means P of 2 is false. So this is false. Now there exists an integer x for which P of x is true. There is a x for which P of x is true. This is the English statement for this. Of course, we have x is equal to 0, then x is equal to 1, for which P of x is equal to true. This says that P of 0 is true and P of 1 is true. Is D right? Yes, it is perfectly right. Existential quantifier states that x should have at least one value. Here x has two values. So in integer we will have negative numbers, 0 and positive numbers. So there exists a x means there is one value at least. So here there are two values which states that it's true. Now we will check E. For every x, P of x is true. This is the statement and it is absolutely false, because for every x means you have to include negative numbers, 0 and positive numbers. But when we checked P of 2, that itself is false. When P of 2 is false, we can say it is not applicable for all integer x. So this states that E is false. A, B and D. The option that includes these three will be option number 3 will be the right answer. When x is equal to 0 and x is equal to 1, P of 0, P of 1 is true. When x is equal to 2, P of 2 is false. This is what we calculated from A, B and C. So when they say there exists a x, this condition can be applied. But when they say for all x, you don't have truth value for everything, which makes this to be false. Just go with some negative number. Minus 1 is equal to minus 1 the whole square, which means that minus 1 not equal to plus 1. So not all x is going to give you the truth value. So in that case, we are marking E to be false. Next question. Which of the following statements are truth statements if universe of discourse is a set of integers? So this time you have 4 problems on universe of discourse. So 3 problems belong to integers and 1 belong to real number. All these 4 problems are from Kenneth Rosen's Discrete Mathematics book, exercises part A. For all n square is greater than or equal to 0. So n is equal to minus 1. Minus 1 the whole square is equal to 1. It is greater than or equal to 0. It works for negative number. For 0, 0 square is greater than or equal to 0. It works for 0. For positive number, let's take n is equal to 1. 1 square is equal to 1, which is greater than or equal to 0. So it works for positive. So all n when they are squared will be greater than or equal to 0 is true. So A is true. This is for all n. And for B, there is a n where n square is equal to 2. Only when n is equal to root 2, if we square root 2, we will get 2. The square root and square get cancelled and we will get 2. Square root is not an integer and they are asking from the universe of discourse, which is a set of integers. Since square root of 2 is not an integer, D is marked as false. We have to find at least one value of n which will make this equation true. N square is equal to 2. But n has only one value for which if you square you will get 2. That value will be square root of 2. Square root of 2 is not an integer. So we are marking it to be false. Next, for all n square is greater than or equal to n. This is actually absolutely true. So if you take n is equal to minus 1. Minus 1 the whole square is greater than or equal to minus 1. 1 is greater than or equal to minus 1 is true. Then check for 0. 0 square is greater than or equal to 0. It is true. Then for 1. 1 square is greater than or equal to 1. 1 equal to 1, we are marking it to be true. Then we will go for 2. 2 square is greater than or equal to 2, which states that 4 is greater than or equal to 2. It is true. So for negative, positive and 0 integers, this statement is true. So C is true. Now we will check for D. There exists a value n. N square is less than 0. Let's take minus 5 or something. When you square a number, it means you are multiplying the number twice. So minus 5 square is equal to minus 5 into minus 5, which will automatically make this plus 25. And when you take a positive number as 5 square, so 5 into 5 will give you 25, which is again positive. They are saying at least one n, but there is no n for which the square of n will be negative. This statement means n square is negative. It's not at all possible. Plus into plus is equal to plus. Product will also be plus. And minus into minus will also give you plus. So at which case you will have negative product is when you multiply a positive and negative integer, you will get negative product. When you multiply a negative and positive integer, you will get negative product. But here you are multiplying n with n, which says that if n is negative, then this n is also negative. If n is positive, this n is also positive, which states that anyhow the product is going to be positive only. This will not be the case for n into n. So from this we can say that n square can never be negative, and so D is wrong. So option number 4, A and C will be the right answer. Rest of the options are wrong. Next question. Which of the following graphs are trees? A connected graph with no cycles is called a tree. If an unexplored edge leads to a vertex visited before, then the graph contains a cycle. So let's start with option A. So we will start with vertex A. From A we have to go to C. From C we have 3 branches, B, D and F. D and F. So from F we have E. Is this a tree? Yes, this is a tree. So A is included, and A is included in all the options too. Now we will check for B. So we will start with A. A has 2 branches, C and F. So it is a intersecting edge, but you have to go to F. So we will have C and we'll have F here. From F we have D, and from F we have E. E and D. From E we have B. And B has no connection with A or D or something, so the tree can be drawn this way. So this is also a tree. B is also included. So whichever options have excluded B, we can rule out 3. Now we will go to C. Let's start with A. We have 3 branches, C, D and B. You can ask me why I am naming in this order. Whichever is coming left side, I am just marking it as left. Whichever is going right side, I am marking it as right. I am not following any other convention. I am just using the graph and just making it to be a tree. From C we have F. From D we have E. From E we have B. And from A we have B. So, if you take this particular part, this makes a cycle. So, they say a connected graph with no cycles. So, in this case, there is a cycle. So, C is not a tree. C option has to be excluded. So, this fourth option is also wrong. Now, we will check for D. A has an edge to F. This is over. Now, we have to check for B and D. B has for D and it has for E and he has for C. So if we take like this C, E, B, D. So this is one tree and this is one tree and both are disconnected. Though they are given in the form of intersecting edges, they are disconnected. A connected graph with no cycles, which says that this is disconnected. Since it is disconnected, we are excluding option D also. Options A and B are alone trees. So option number 1 will be the right answer. We will rule out even 2. I hope you understood how we excluded C and D. Just see the second point. If an unexplored edge leads to a vertex visited before. So when I get into D and E, the next edge is getting back to B again, which is already a visited vertex as per this context. So it makes a cycle here and that's why we are excluding C. Next question, match list 1 with list 2. Before getting into the solution, we'll just learn about 2 symbols. The first symbol is this and the second symbol will be this one. So what is it? On seeing this symbol, we can understand that it is an empty set. That is, the set contains no element. How do you represent an empty set? Is using the phi symbol. So this phi symbol is equal to this symbol. So whenever we say it's an empty set, it means the set does not contain any element inside it. Then what is this symbol? This is actually a set. Inside the set we have one element. It means it is not an empty set on the whole. But inside the set, you have this symbol here. What does this mean? So, inside there is a set that is an empty set. So, we can say this is a set with one element and that element is an empty set. So, the set with empty set will be represented this way. This is a set. So, we can keep the set symbol as it is. Now, instead of the empty set symbol, we will use this phi. So, instead of this, we will use phi. So, whenever they say it's a phi symbol, it means it's an empty set. And whenever they say a phi symbol inside a set, it means an empty set that is present inside the set. It means the set is with one element and that element is empty set. Empty set inside a set is a set of sets. It's a set containing a single element, as I said, and that element is the empty set. So what is an empty set? The empty set is a set that contains 0 elements. It means no elements are present. The set of an empty set is not an empty set. This is what they have mentioned in this symbol. It has an element even if that element is itself a set with no elements. We are not bothered about what is inside the set. We are only bothered that the set contains something. We have two operations here. One is the union operation and the other one is intersection operation. Let's take A to be a set and this phi symbol is empty set. What happens when a set has a union operation with an empty set? It means when you are joining a set with an empty set, you will get the set itself. So A union phi will give you A. Then what happens in case of intersection? When you want to find intersection between a set and an empty set, you will result in empty set only. So intersection of set and empty set will be empty set and union of set and empty set will be that set. So let's take option A. The first symbol is phi, which says it's an empty set. Empty set intersection, we have a set with empty set. This is almost similar to A intersection phi. So phi stands the same and instead of A, we have a set with empty set as described here. So what is the result of A intersection phi? It is phi only. Empty set intersection set with empty set will be empty set again. So A will be mapping to 1. We have two options of A mapping to 1. So we rule out 2 and 3. Now let's go for B. A set with empty set intersection a set with empty set. So both the sets are actually same. Let's take for example S1 is equal to the first set 1, 2 and S2 is equal to the second set that is also 1, 2. What is S1 intersection S2? It is 1, 2 again. What I am trying to tell you is when you have a set with empty set on both the sides, the intersection will also give you the same thing. This is also a set with an empty set. B is also mapping directly to option 2. Now let's take C. We have a set and inside the set we have two elements. One is empty set and another is set with empty set. So this is one set together. We have difference operation with empty set. What is the result? If I take two sets S1 and S2, let's take S1 is equal to 1, 2, 3, 4. So this is one example. Let's forget this. Now this is the other example. S2 is equal to 1, 2. So whatever is present in S1 but not in S2 will be considered as the result of difference operation. So S1 and S2, when they are under difference operation, S1 minus S2, the result will be 3, 4. How will you take intersection for S1 and S2? Whatever is common, you will take it out. Now you have to remove the intersecting elements in order to perform the difference operation. So I am removing the intersecting elements and finding the difference will be 3, 4 elements inside the set. So what is this? We literally translate this. This is a set with two elements and this is an empty set. So let's take an example for this again. Let S1 is equal to 3, 4, S2 is equal to 1, 2. Now what will be S1 minus S2? When you have two different sets here without any intersection elements, the result will be S1. This is equal to 3, 4. Consider this to be a set with two elements and consider this to be a set with 0 element. So since you don't have any intersection elements here, you automatically output the S1 set totally. So which means the set will be represented as it is. The result will be the S1 set completely. C will be mapping to 4. Option number 4 has C4 and so we will rule out 1 also. Option number 4 will be the right answer. Why is C mapping to fourth one here? It is because this first set has two elements and the second set has 0 elements. So consider the same case here. S1 is equal to 3, 4 and just take S2 is equal to empty. We are not worried about what is inside S1 when S2 is empty. We just bring the answer of S1 minus S2 as S1 itself. A difference and empty set will again give A. So this is for union, this is for intersection, and this is for difference. Now let's go for D. Empty set union, an empty set inside a set and inside a set. This is empty set. This is an empty set inside a set. Then what about this one? So there are 3 sets totally. So let's take this to be first set, this one as second set, and this one as third set. The outermost set, the first set has 1 element, the second set, the middle set has 1 element, and the third set, the innermost set, has 0 elements. It means a set of set with empty set. These two are not equal. In this case, this particular symbol, this is equivalent to this one. Now they are asking for union. We need not go and inspect what is inside this set. Since empty set is given here and there is a union operation, consider this complete set as a single set, namely A. What is A union empty set? It is A again. So just output A again, which means I have to output only the right hand side of union operation. So this will be the answer. We are mapping D to 3. Whenever you see an empty set, remember these 3 and just apply them. So empty set intersection sum set, consider this to be A. Empty intersection A will give you empty set again. A option is taking this. Coming to C, we apply this difference operation with empty set. For D, we use A union empty set. So using these 3 operations, we are just mapping A, C and D to the answer. Regarding B, it is just similar to this example. Let's take this to be S1 and let's take this to be S2. Since S1 and S2 have equal number of elements and the same element, we are just finding that element to be the intersecting element. Option number 4 will be the right answer. Next question. Match list 1 with list 2. Propositions have been given in list 1. The disjunctive normal form have been given in list 2. They are asking which is the DNF of which proposition. What is disjunctive normal form? It is obtained by operating or among variables connected with AND. If we take all the options here, you can find OR connecting the AND. Here it is OR, here it is OR, here it is OR, here it is OR. Fourth and the second option will give you the exact meaning. Inside the brackets you have AND operation and they are outwardly connected by OR operation in option number 2. And if you take the fourth option, there are 1, 2, 3, 4 AND operations connected by 3 ORs. Operating OR among variables connected with ANDs. So now let's get into the solving part. Let's start with C. P implies Q. What it is actually? Negation of P or Q. So here we can map C to 3 directly. So only 2 options are having C to 3. So we rule out 3 and 4. So here this negation is termed as one operation and OR is placed outside. So that's why they have given in brackets. We'll go with A. P and P implies Q. Let's have P and what is P implies Q? Negation of P or Q. Now we'll apply this AND inside the brackets. So this will be P and negation of P. The OR will be staying as it is P and Q. So AND connected by OR. This is a DNF. So A is mapping to 2. From this we can say that option 1 is also ruled out. Option number 2 will be the right answer. Now let's get into D. The answer for D is 4. So we'll start with 4 and see whether we are able to get D. P and P or P and Q or P and R or Q and R. P and P is actually P. We just have it as P or P and Q or P and R or Q and R. So by absorption law, this will become P. So P, this R stays here. Then we have P and R or Q and R. Again, this is a form of absorption law. Using the same law, we are reducing this to P or Q and R. This is actually equivalent to D. So we are starting with option 4, the answer of D, and then arriving at D. So D is mapping to 4, it is right. So let's take this side. So negation of P or Q implies P and Q. Now we can solve this in two ways. One way is you have to apply the negation inside this particular part and then apply implies operation. The other way is treat this as P and this as Q. So I am going with this. What is P implies Q? Negation of P or Q, right? So negation of P means negation of the complete part of P or this Q, P and Q. Now we will first apply the inner negation, then we will apply the outer negation. Now let's apply this negation inside. Negation P, when I bring negation to OR, this becomes and then negation of Q or P and Q. And now I have to bring this negation inside again. So negation of negation P, and when I apply negation to AND, this becomes OR again, and then negation of negation Q or P and Q. Negation of negation P is P, or negation and negation of Q will give you Q or P and Q. You can just reduce this to Q by using absorption law again. We are reducing this to Q. So this is P or Q. B is mapping to 1. If you find your answer with one or two options, make sure the other options are also yielding the correct result to make sure that you have answered it right. Option A, B and C, we started from left side and we arrived at the right side. Option D, we have just done the reverse process. So option 2 will be the right answer. Next question. Given below are two statements. Statement 1. If H is non-empty finite subset of a group G and A into B that belongs to H, this is A into B that belongs to H for all A comma B that belongs to H. It means for all A comma B that belongs to H, then H is also a group. So to support this, we have a part. Let H be a subset of a group G. So this says a non-empty finite subset. H is called a subgroup if H itself is a group under the operation of G. So they have given some simple criteria in that if you take a subset H of a group is a subgroup if identity element E that belongs to H, it means H is non-empty. It is closed under the operation, that is if A and B belong to H. As per this condition, then A into B belongs to H. This is what they have stated here. Using these 2 points, we can mark statement 1 to be true. They are saying if H is a subset of a group and it is closed under A into B operation, then H is also a group. This is what they say, a subset of a group is a subgroup. So subgroup in the sense it is itself a group under some operation. Then we will check the third point. H is closed under inverses. That is, if A belongs to H, then A inverse also belongs to H. Every group G has the subgroups, the identity element and G itself. Any other subgroup of G is called non-trivial subgroup. It was just a part of this explanation, so I took even this. It might be useful for you in some other question paper. So based on 1 and 2 points, we mark statement 1 to be true. Next, the second statement. There is no homomorphism that exists from Z plus to Q plus, where Z is a set of integers and Q is a set of rational number. Now you have to understand one concept. You have natural numbers starting from 1, the positive part, then the whole numbers that includes all natural number and 0. So 0, 1, 2, etc. Integers represented by Z, they have whole numbers as well as their negations. It means negative numbers are included, 0 is included, positive numbers are included. What are rational numbers? They are represented by the symbol Q They can be represented as a fraction. 1 by 4, root 9, 0, then we have 0.999, 3.57. So anything that is represented as a fraction will be under rational number. What are they saying here is there is no homomorphism. What is homomorphism? It's a mapping between two structures of the same type. If you take G and H to be a group, so it is under this operation and H is under this operation. Just see how they are applied. This mapping is called a homomorphism. We have already solved some working problems in certain question papers where they will be asking us to find the homomorphism. But for this question, every integer is also a rational number, which says that Z is a subset of Q. It means the rational number is including the integers. Integers are including the whole numbers are including the natural numbers. So in this case, they say there is no homomorphism. It means there is no mapping. They have given addition operation under integers to addition operation under rational numbers. When I say 1 plus 1 is equal to 2, is it a part of Q? Yes. So there is a mapping. When they say Z is a subset of Q, it automatically means there is a homomorphism. There is a mapping. In one question paper, there was a function and we had two groups. Here we had 1, 2, 3, minus 1, minus 2, minus 3. And here this side we had only minus 1 and 1. When they are applied in this particular function, they gave only 1 and minus 1 as the answer. So if we take 1 here, 1 divided by mod of 1 will give you 1. 2 divided by mod of 2 will give you 1. All the positive mapped to plus 1 here and all the negative minus 1 divided by 1, minus 2 divided by 2 and minus 3 divided by 3 gave you minus 1. All the negative mapped to minus 1. They say using this function there is a particular mapping. This was a previous year question. I just took it for an example. So here it is addition. They have placed Z here. So any number 0, 1, 2, 3, minus 1, minus 2, minus 3, anything can be taken and here it is a set of rational number. So you include 0, 1, 2, 3, you include minus 1, minus 2, minus 3, you include even 0 point something or 1.3, you have roots. When they say there is an addition operation, it automatically has a mapping in the rational numbers addition to. When I say 3 plus 3 is equal to 6 in rational numbers context, I can say it is 6.0. So there is definitely a homomorphism that is existing from integer addition to rational number addition. So statement 2 is marked as false. Option number 3. Statement 1 is correct but statement 2 is incorrect will be the right answer. From here, we are going to solve the next 5 questions. This is based on linear programming. All this time we were using x plus y plus z is equal to some 20 or 30. Then we had some constraints with inequalities. Then they say x comma y is greater than or equal to 0. They will give you the equation and they will ask you to find some solution. This was the case so far we have been seeing in UGC NET question paper. But in actual class of linear programming, this is how the class will be starting. They will give you a scenario and they will ask you to find the linear programming problem itself. And from the problem, you will be finding the solution. That will be the next stage. So usually they will give you in terms of x and y and they will ask you the solution alone. But this time they are asking you to frame the equations, frame the problem and then find the solution. We will do it now. Before answering the 5 questions, first let's understand what the question is about. Food X contains 6 units of vitamin D per gram and 7 units of vitamin E per gram. Cost is rupees 12 per gram. Food Y contains 8 units of vitamin D per gram and 12 units of vitamin E per gram and cost is rupees 20 per gram. The daily minimum requirements of vitamin D and E are 100 units and 120 units respectively. Suppose X is quantity in gram of food X and Y is quantity in gram of food Y. So they are representing small x as the quantity of food capital X and small y as the quantity of food capital Y. Answer the following question based on the above paragraph given. First, let's convert this into a tabular form so that using the table we will be able to form the linear programming problem or the necessary equations. So let's make a table now. I have created 4 columns. First column will be food. So there are 2 types of food. One is food X and another is food Y. Both the foods are having vitamin D and vitamin E. How much vitamin D is present in food X? It is 6 units. So we'll place 6 here. How many units of vitamin E are available in food X? It is 7 units. And what is the cost per gram? It is 12. So everything is given for per gram. Now let's go to food Y. How much vitamin D is present per gram? 8 units. And how much vitamin E is present per gram? 12 units. And what is the cost? It is rupees 20 per gram. So there are 2 foods, but we have a minimum requirement of this much vitamin D should be there and this much vitamin E should be there every day, and those vitamins will be taken by taking these 2 foods X and Y. So now the minimum requirements of vitamin D will be 100 and minimum requirements of vitamin E will be 120. We are representing the equation in terms of X and Y. So this X will represent the food X quantity and this Y will represent this food Y quantity. These are the details we can get from this question. Now we will start answering the question. The cost function of total food is. Where do you actually find the cost is in the 4th column. The cost is given as 12 for food X and 20 for food Y. And they have told that small x is used to represent the food capital X and small y is used to represent the food capital Y. Whenever you take a linear programming problem, it will be usually mentioned in the form of maximization function or minimization function. There will be variables like x, y and sometimes z that will be equating to some value. So this will be the form. What is the cost for food X? It is 12. So 12 into small x plus what is the cost for food Y? 20 per gram. So 20 into small y. And we usually assign capital Z for these kind of functions. Cost function will be 12x plus 20y. This is from food X cost and this is from food Y cost. This is how you will be framing the cost function from the above given data. Option number 3, Z is equal to 12x plus 20y will be the right answer. Next question, which of the following constraints when formulating the LPP? When you frame a LPP, you will first have Z is equal to some equation. After that, you will be given some constraints. There will be 2 or 3 constraints depending on the number of variables. These constraints will have inequalities. Inequalities in the sense they will either be represented as less than equal to or greater than equal to, and the variables will be represented as greater than or equal to 0. Now the question is about what are the constraints for this particular LPP. Based on this only we are going to frame the constraint. There are 2 foods, food X and food Y. While forming the constraints, you have to go column wise. We found the cost function from the cost column. Similarly, we have to pick the constraints from the vitamin D column and vitamin E column. Now the representation of food X will be small x and representation of food Y will be small y. Since there are 2 variables, there will be 2 constraints as for this question. Equation will be 6x plus 8y. The previous question we equated it to z because it's a cost function that we have to find since there is no value here. Now they have given a value called 100. So we will place this here. What kind of inequality will you place here? Whether it is less than or equal to or greater than or equal to. So now let's read the statement again. The daily minimum requirements of vitamin D and E are. If minimum requirements means, if they say 100 is minimum requirement, it means greater than or equal to 100. If they say 120 is the minimum requirement for vitamin E, it means it is greater than or equal to 120. So the values will be like 100, 101, 102 and it goes on. Here the minimum requirement is 120 for vitamin E. It means it starts from 120, 121 and it goes on. we will represent 100 and more as greater than or equal to 100. Why do we include equal to symbol here is the minimum is given as 100. So it will be greater than or equal to. Either it will be 100 or more than 100. Similarly, we will place greater than or equal to 120 because it is either 120 or more than 120. In that case, 6x plus 8y should be greater than or equal to 100. Now the vitamin E equation will be 7x plus 12y is greater than or equal to 120. Remember, this is for vitamin D and this is for vitamin E. Now they are asking the values of x and y. X is the quantity in gram for food X and Y is the quantity for food Y. Now they have some kind of minimal requirement of vitamin D and E and they have given only two foods. It means you have to take some quantity of food X and some quantity of food Y. Say in binary you have two values. 0 means it is a no, 1 means it is a yes. If I say 0 in binary, it means I am not taking that food. If we say 1, it means we are taking the food. But here in usual discrete form, if we say 0, it means it is of 0 quantity. If we say 1, it means a count of 1 and it goes until how many ever units it is available they can take. X is going to have some 10 value means the count will be 10. The value of x will be starting from 0 and it will be more than 0. If we say 0 means you are not going to take food x. If we say 1, you are going to take 1 unit of food x. So in that way, you can either take the food or leave the food. In the sense, sometimes you will have only food y. You will have the requirement of 100 and 120 means it's more than enough. So there can be a case where the values can be either 0 or more than 0. So in this case, x can be greater than or equal to 0 and y can also be greater than or equal to 0. This is actually represented as x comma y greater than or equal to 0. Now we will find which constraints are available in this option. So first option is saying it is less than or equal to. So whichever has less than or equal to, you can rule out the option because your minimum requirement gives a condition it is greater than or equal to. Third option says that 6x plus 7y. 6 belongs to food x and 7 also belongs to food x only. But y is representing the food y. When you are talking about the minimum requirement of D, you have to look at this column for x and y and not row wise. So this equation is also wrong. Similarly, you can check 8x plus 12y. They have just computed row wise, which is wrong again. Now let's see option 4. 6x plus 8y as we got here greater than or equal to 100. 7x plus 12y greater than or equal to 120. And x comma y greater than or equal to 0. So all these three are present. Option number 4 will be the right answer. In case the question is daily maximum requirement, then what will be the inequality is less than or equal to. Say for example, if maximum is 200, the equation will turn as less than or equal to 200. So when you represent equal to, it is equation. When it is less than or equal to or greater than or equal to, these are called inequalities. Next question. Which of the following are quantities? The value of x and y of food x and y respectively when the cost of food is minimum. Whenever you go for buying something, we always demand that we pay less. So when cost is involved in some problem, we will often end up with minimizing the cost. So in this way, when cost is available here, the problem will be taken to be minimization problem only. So in that aspect they have given when the cost of food is minimum. So we have to find the values of x and y. So there are two ways to find x and y. The first way is using the graphical method and the second way is using simplex method. Regarding graphical method, I will tell you now, and once we find the answer for this question, I will also explain you the same problem using simplex method because this simplex method will use a method called big M. In the previous session question papers, we have solved using graphical method, we have solved using simplex method, but so far we have not tried big M. So this question I will solve it in graphical as well as simplex method. So watch out. So what we'll do for graphical method is usually we will take the constraints. So what are the constraints available? 6x plus 8y greater than or equal to 100. Then we have 7x plus 12y greater than or equal to 120. These two constraints are there. Then we have x comma y greater than or equal to 0. Usually in graphical method, we will make one of the variables value as 0 and then find the other value. From one equation we will get two pairs of value. Then from another equation we will get two pairs of value. In a graph, we will plot all the four values and find some intersection point. That intersection point will give you a x value and a y value. So totally you will have 5 pairs of solution. From them we have to calculate this cost. So let's take the first equation, 6x plus 8y is equal to 100. So how did this inequality change to equality is, basically we will convert this into an equation and then only apply 0. See, if I apply 0 in x directly here, it is 0 plus 8y greater than or equal to 100. From this, I will not be able to calculate a value for y. So, this is the usual method we follow. Now, we will place x is equal to 0. This will make 8y is equal to 100 and y is equal to 100 divided by 8. This will give a value of y is equal to 12.5. From 6x plus 8y equal to 100, we get 0, 12.5. Now we will make y to be 0. So we will have 6x is equal to 100 and x is equal to 100 by 6. You will have 50 by 3. This will be around 16.67. So here the next coordinate here will be, it is 60.67 comma 0 or 50 by 3 comma 0. Even this coordinate can be, instead of having 12.5, we can say it is 12 into 1 by 2. Now from the next equation, 7x plus 12y equal to 120. So first we will make x to be 0. So 12y is equal to 120. From this we can have y is equal to 10. So 0, 10. Next we will make y is equal to 0. From this we will have 7x is equal to 120, x is equal to 120 divided by 7 and x is equal to 17.14. So here it is 17.14 comma 0 or 120 by 7 comma 0. So we have 4 coordinates totally. We will get into plotting now. Let's take the first equation, 6x plus 8y is equal to 100. So we have 2 points there. The first point will be 0, 12.5. The second point will be 16.67, 0. So when we want to calculate the cost function, at that time we will use 50 by 3, the fraction part. But in order to plot in the graph, we will need a decimal point. That's why I have mentioned both the forms here. So this will be 16.67, 0. In a coordinate x, y, when x is 0, the point lies on the y-axis, and when y is 0, the point lies on the x-axis. Make sure that you are plotting it properly. We will get into the second equation. 7x plus 12y is equal to 120. We have 2 points again. The first coordinate will be 0, 10 and the second one will be 17.14, 0. We have to draw a line for these 2 points. 0, 12.5 and 16.67, 0 are just connecting here. And now we have to draw a line for these 2 points. 0, 10 connecting to 17.14, 0. Now we have a intersection between these 2 points. Let's see what it is. So this intersection point is somewhere around 15 in the x-axis. So let's take x-axis value as 15 here, and this is somewhere between 1 and 2. So we can see the second option of this question as 15 and 5 by 4. As for now, let's take this 5 by 4 as approximately to 1.2. Y-axis value will be 5 by 4. So we have the intersection point here, namely 15, 5 by 4. We'll retain the fraction part because we will need it to calculate the cost function ultimately. Now, regarding the graphical method, there is something called feasible region that you will be able to visually see in the graph. How will the feasible region be for maximization problem and minimization problem? Let's take this to be a graph and this to be some intersecting point. For maximization problem, the feasible region will lie below the line. We have the values x greater than or equal to 0 and y greater than or equal to 0, which is this part. And when those equations are solved and we plot two lines, the intersecting part or that region will be marked above the 0th point in both x and y axis as well as below those lines. This is the case of maximization. What about minimization? In minimization, this becomes the minimum requirement as they mentioned in the question. Since it is minimum, this particular line will be the starting point of the feasible region. So this will be for minimization problem. So let me draw separately and show where the feasible region will occur. Now we will mark the feasible region's boundary in a different color. So I have used green here. So after this, everything will be the feasible region. So what points are involved in this feasible region? We have one point here, we have the other point here and the other point here. So 3 points are involved. Just take 0, 12.5 can also be written as 12 into 1 by 2. And then we have 15, 5 by 4. Then we have 17.14 is otherwise mentioned as 120 by 7, 0. So these 3 points are called critical points. We need not get into the details of graphical method. I am just trying to tell you how to solve it. So we have 3 points here. What is the cost function that has been given in some previous question? It is z is equal to 12x plus 20y. Now they are asking when the cost of food is minimum. So you have to find where it is minimum. Option number 1 is present here. Option number 2 is present here. Option number 3 is present here. Before calculating option number 4, we can find that it is not a part of the critical point. It is not falling in the feasible region part. So we can easily say fourth one will not be an option. So what happens if we calculate fourth one in case without drawing this graph? I'll just tell you what happens and why we have to rule it out earlier itself. So let's first calculate Z for the rest of the options. 12 into x, so 12 into 0 is 0 plus 20 into 12.5. This will give a value of 250. So let's mention 250 here. Then we have 15 as x value. So 12 into 15 plus 20 into the y value is 5 by 4. Here 12 into 15 it gives 180 plus I will cancel 4 and 20, 4 5s are 20. So 5 into 5 is 25. This gives a value of 205. Now we have 120 by 7. So since y value is 0, 12 into 120 by 7 will result in 1440 divided by 7, which is equal to 2.5.7 and it goes on. So for now we will take it only with regards to one decimal point. So in order to differentiate option 2 and 3 we have 0.7. Then for 0, 10, why did I rule it out in the beginning itself means it's because of this. 0 into 12 will give 0, 20 into the y value 10 will give 200. Now if you consider only these 4 options and calculate the cost using this particular objective function, what will happen is you will end up marking option 4 as the right answer because the cost of food is minimum only in option 4. But the reality is you should never consider this point because when you take feasible region, you have to take only the critical points into calculating the Z value. That's why I ruled it in the beginning itself. Now 250, 205, 205.7, which is lesser, option 2 is lesser. From this we can say option 2 will be the right answer. So x is equal to 15 and y is equal to 5 by 4. From here we get a cost of 205. Out of these three critical points, we find that this cost is minimum. So we have got the value of x and y through this graphical method as 15 and 5 by 4 respectively. This is how we will be doing graphical method. Now we will proceed with the simplex method to solve the same problem, and let's check how we are ending up with the x value and the y value along with the cost value. So z is equal to 12x plus 20y. Then we have constraints 6x plus 8y greater than or equal to 100. Then we have 7x plus 12y greater than or equal to 120. Then we have x comma y greater than or equal to 0. So we will start. The ultimate aim of this z is to find the cost of food whichever is minimum. So here this is a minimization problem. From the question we are deriving, it's a minimization problem. First we have to convert the inequalities to equalities. How will we do this? So 6x plus 8y. If the inequality is going to be less than or equal to some value, then we will usually add a surplus variable. Since the constraint is having greater than or equal to inequality, we are going to subtract the surplus variable from the equation. So 6x plus 8y is going to be greater. So I am subtracting a surplus variable and equating this to 100. Similarly, 7x plus 12y. So in order to have no confusion, I am taking the surplus variable as s1 and this to be s2, and this is equal to 120. So when you have 6x plus 8y less than or equal to 100, this will be 6x plus 8y plus s equal to 100. Okay. So what inequality is present here, based on that only you have to add or subtract the surplus variable. So this is not related to this question. So even then I am telling you for your information. And since we have used two surplus variables here, we will call them as negative slack variables also. We are including it in z. So z is equal to 12x plus 20y. We have to use the coefficient value as 0 because they are not a part of the original problem. We are only including it. So it is 0 into s1 plus 0 into s2. So minimize z is equal to, then we will say subject to these two constraints together. And from here we can say x and y is greater than or equal to 0, and s1 and s2 both should be greater than or equal to 0. Whenever we want to find a basic feasible solution from surplus variable placed equations, we will always make x and y to be 0, and then we will find the value of s1 and s2. In this case, making x and y to be 0, we can find s1 is equal to minus 100 and s2 is equal to minus 120. When you have negative variables for surplus variables, this will be an infeasible solution. Whenever you have an infeasible solution, you have to introduce artificial variables. I am not writing all the details about this problem in words, but I am talking. So please listen to what I talk. Whenever we want to find a basic feasible solution from the equation like this, we have converted inequality to equations. இந்த மாதிரி convert பண்ண equationsக்கு நம்ம basic feasible solution கண்டுபிடிக்கணும்னா x and y ஓட வேல்யூவை at a timeல 0ன்னு மாற்றணும். அப்படி மாற்றிட்டீங்கன்னா உங்களுக்கு s1 and s2 ஓட வேல்யூ என்னன்னு கிடைச்சிடும். யூஸ்வலி லெஸ் தென் ஆர் ஈக்குவல் டு போட்டு நீங்கள் s1 s2 யூஸ் பண்ணிங்கன்னா உங்களுக்கு பாசிட்டிவ் வேல்யூவாக தான் வரும். பட் இங்கே நீங்கள் மைனஸ் s1 மைனஸ் s2ன்னு போட்டிருக்கிறதுனால x and y நீங்கள் ஜீரோவாக மாற்றினதுக்கப்புறம் உங்களுக்கு s1ஓட வேல்யூ வந்து மைனஸ் 100னும் s2ஓட வேல்யூ மைனஸ் 120னும் வரும். If this is the case, we call them as infeasible solution. When we get negative values for surplus variables, we term the solution as infeasible solution. In this case, we are introducing artificial variables. For artificial variable, now I use a1 and a2. So why I am using two variables? There are two equations. So how will this equation be converted now? It is 6x plus 8y minus s1. In order to make this value positive, I am going to add the artificial variable as plus a1, which is equal to 100. Similarly, the second equation, 7x plus 12y minus s2 plus a2 equal to 120. This will be the case. Now when you try to find a basic feasible solution, so I'll mark it as basic fs, we have to make everything as 0, and from this we can get a1 is equal to 100 and a2 is equal to 120. Making everything 0, we are finding this. So when we have such positive number, it means this is a basic feasible solution. Since we have introduced two artificial variables, now we have to insert this in the objective function minimization function. Minimize z is equal to 12x plus 20y. Already we have 0s1 plus 0s2. Now we have introduced two artificial variables also. So we are placing a1 and a2. What are the coefficients of a1 and a2? This a1 and a2 will have large value like 10,000, 1 lakh. It will have large value. The large value will be represented as m. To represent them in coefficient form, we can have plus m and plus m. So this m can be something, a value like 10,000. So let me explain in Tamil for Tamil subscribers. Basic feasible solution la surplus variable ku negative value வந்துருச்சு. நம்ம artificial variables ன்னு சொல்லிட்டு ஒரு equationக்கு ஒரு artificial variable introduce பண்றோம். So first equationல place பண்ற artificial variable a1 னும் second equationல place பண்ற artificial variable a2 னும் சொல்றோம். இப்படி செய்யறப்ப நம்ம இதுக்கு basic feasible solution இப்ப கண்டுபிடிக்க போறோம். So இதுக்கு கண்டுபிடிக்கிறப்ப எல்லாத்தோட வேல்யூவும் 0வா மாத்துறப்ப நமக்கு a1 க்கு வந்து 100 னும் a2 க்கு 120 னு பாசிட்டிவா வந்துருது. a1 and a2 will be greater than or equal to 0. This becomes the basic feasible solution. எப்பவுமே நம்ம inequalitiesல என்ன வேரியபிள் ஆட் பண்ணாலும் அதை வந்து நம்ம objective functionல include பண்ணிக்கிட்டே இருக்கணும். So whenever we include any kind of variables in the constraint equations, we should always include them in the objective function too, the minimization function too. So for surplus variables, we introduce the coefficient called 0. But for artificial variables, we have to use m. இந்த m ஓட representation என்னன்னு பார்த்தீங்கன்னா, இப்போ நான் 10,000 இல்ல 1 lakh இந்த மாதிரி பெரிய நம்பரை தான் வந்து artificial variablesக்கு coefficient நம்ம வைக்கணும். So இதனால தான் நம்ம வந்து இதை big M methodனு சொல்றோம். So since we use capital M here, we call this method to be big M method. This is a minimization problem. The objective function should be in form of maximization problem. So in order to convert minimization to maximization, we have to multiply the objective function by minus 1. So z is equal to minus 12x minus 20y. Then for 0, there is no use of saying it is plus 0 or minus 0. So let it stay as plus 0 s1 plus 0 s2. And m is a very big number. So we will have minus m into artificial variable 1 and minus m into artificial variable 2. You can ask me whether I can place the same m again and again. This is just a coefficient. This is not going to have any big role here other than to solve the problem. So there is nothing wrong. நீங்கள் மினிமைசேஷனை மேக்ஸிமைசேஷனாக கன்வெர்ட் பண்ணோன்னா z ஃபங்க்ஷனை வந்து நீங்கள் -1ஆல் மல்டிப்ளை பண்ணிக்கோங்க. இது ரெண்டு இடத்துலையும் வந்து s1க்கும் s2க்கும் கோஎஃபிஷியன்ட் 0வாக இருக்கிறதுனால அதில் நீங்கள் வந்து மைனஸால் அப்ளை பண்ணுறதுனால ஒரு யூஸும் இருக்க போகிறதில்ல. அதனால் அந்த 0 is staying as it is. Now we will get into the solving part. So the basic variables x, y are here from the equation. Then we have s1 and s2, the surplus variables. Then capital A1 and capital A2, which are the artificial variables. The row that is top to the basic variable. So what is the x coefficient? Minus 12. It is placed here. Then y coefficient is minus 20. S1 and S2 are 0. Then for A1 and A2 it is minus m we have placed here. Now we have to start with artificial variables as the basic variables. The reason is we have got the basic feasible solution for these two values. Usually in the problems we will start with surplus variables, but in this case surplus variables have resulted in infeasible solution. So we introduced artificial variables. In the sense these two will be taken as the basic variables as of now. The coefficient of A1 and A2 will be in the left side column as minus m. Now we will get into the table. First constraint 6x plus 8y. So here the value is 6. Here the value is 8. S1 it is minus s. So in this case it is minus 1. Is there S2 variable in the first equation? There is no S2 variable. So we will place it as 0. A1's value will be plus 1 because it is plus A1. A2 is not present in the first equation. What is the right hand side? It is 100. Now we will place the second equation. 7x plus 12y. We don't have S1 here, so it is 0. We have minus S2, it is minus 1. A1 we don't have here. A2 the value is 1. The right hand side will be 120. We have to find the pivotal element. So we have to see which is entering, which is leaving. All these stories I have already explained in another video. So next we have to find Cj minus Zj or Zj minus Cj. So let me tell you how to do this. X into Cb plus y into Cb, the particular coefficient, minus the z value. This is what they meant as Cj minus Zj. So here it is 6m and here it is 7m. Of course it is minus 6m and minus 7m, and it is minus 12 here. They have usually given in the form of Zj minus Cj. So Zj minus 12 will stay like this, and minus 6 and minus 7 will give you minus 13m. So minus of minus 13m will give plus 13m minus 12. So let's not take it this way. So let's take it as Zj minus Cj. Okay. So the value here is 13m minus 12. Now we will calculate for the next column. It is minus 8m and minus 12m, giving a value of minus 20m, then minus 20. So minus 20 minus into minus 20m will give plus 20m. This is 20m minus 20. Now the next calculation, minus 1 into minus m. Minus 1 into minus m will give you capital M. Then you have to go Z minus C. So here it is 0. 0 minus the positive m will give you minus m here. The same value will be applicable here also. Here you have 1 into minus m. So 1 into minus m will give you a value of minus m. And here it is minus m minus of minus m. So minus m plus m will give you 0 ultimately. So here also you will have 0. So which is the largest value here? This is the largest value. Capital M has a value of 10,000 and more. Which has the largest value? It is this one. This will be the column that we are going to consider as of now. Now we have to find the ratio here. 100 divided by the particular value 8, and here it is 120 divided by 12. 100 divided by 8 is 12.5 and 120 by 12, this will give 10. So which is minimum here? Of course 10 is minimum, so this will be the leaving variable and this will be the entering variable. The intersection will be the pivot element 12. Y enters and A2 leaves. Y enters because it has the highest value and A2 leaves because it has the lowest value. When you take Cj minus Zj, the smaller value should be considered. When you take Zj minus Cj, the higher value or the larger value should be considered. Here we have taken Zj minus Cj, so we are going with the higher value. இப்போ நம்ம Cj minus Zj வச்சு calculate பண்ணியிருந்தோம்னா எது இந்த particular ரோல வந்து லீஸ்டா இருக்கோ அதை நம்ம சூஸ் பண்ணியிருக்கணும். பட் நம்ம Zj மைனஸ் Cjன்னு போனதுனால எது ஹையஸ்டா இருக்கோ அதை சூஸ் பண்றோம். ஆக்சுவல் ஈக்குவேஷன் வந்து Cj மைனஸ் Zj தான். ஸோ த என்ட்ரிங் எலிமெண்ட் இன்ஸ்டெட் ஆஃப் A2 who should enter here? Y is entering and A2 is leaving. Then we will have A1 here as it is. The coefficient of A1 will be minus m as per the objective function. The coefficient of y will be minus 20 in the objective function. I have to make this particular place as 1. இங்க என்ன பண்ணா எனக்கு 1 கிடைக்கும்? I can divide the particular row by 12 in order to get 1 here. This is the old A2 row I have taken. 7, 12, 0, minus 1, 0, 1, 120. Now I have to divide this particular y by 12. This is the new row that I am going to place. So I will get 7 by 12 and 12 by 12 which is equal to 1. 0 by 12 is 0. Minus 1 by 12, then 0, again 1 by 12, 120 by 12 will give me a value of 10. Now I will place this here, 7 by 12, 1, then 0, then I have minus 1 by 12, then I have 0, then I have 1 by 12, then here 10. I have got this. The element that is in the same column should be 0. It means I have to make this particular value 0 in the next iteration. So this is the next iteration we are working. Maybe the first iteration or the next iteration. So in this I have to make this value as 0. Old row of A1. I have placed 6, 8, minus 1, 0, 1, 0 and 100 here. Now I have to make this 8 as 0. So what I will do is minus 8 into the new y value. Minus 8 into the new y value is 7 by 12. So 4 2s are and 4 3s. So minus 14 by 3. So this is minus 14 by 3. Minus 8 into 1 will give me minus 8. Then I have 0 here. Minus 8 into 0 will give me 0. So this is the new y. I have to multiply this by minus 8. That computation only I am doing here. Then I have minus 8 into minus 1 by 12. So minus 8 into minus 1 by 12. 2 4s are and 3 4s are. So it is plus 2 by 3. Then 0 into anything is 0. Then I have minus 2 by 3. Because it is same 1 by 12 only, I have to just include the minus. Here we have 10. So 10 into minus 8 will be minus 80. Now if you add this old A1 plus minus 8 into new y, if you add these two rows, we will get 0 here. So this is the ultimate aim of doing all such calculations. Minus 1 plus 0 is minus 1. 0 plus 2 by 3 is 2 by 3. 1 plus 0 is 1. 0 minus 2 by 3 is minus 2 by 3. 100 minus 80 will be 20. I am not subtracting. I am using here minus 8 and I am just adding this. So 6 minus 14 by 3. So 6 into 3 it is 18. 18 minus 14 by 3 will give 4 by 3. So this is my new A1 row. So it is 4 by 3. I am placing here. It is 0. Then I have minus 1. Then it is 2 by 3. Then it is 1. Then it is minus 2 by 3. Then we have 20 here. Now again we have to find Zj minus Cj and find whichever is higher. Remember Cj minus Zj it is smaller value. Zj minus Cj it is higher value. So let's calculate Zj minus Cj. Let me make the computation here. It is minus 4m by 3. Then minus 20 into 7 by 12. 4 3s are and 4 5s are. It is minus 4m by 3 minus 35 by 3. If both are going to be minus, I have to convert this as plus because this is C. So Zj is minus 12. So minus 12 plus 4m plus 35 by 3, and if I take LCM it is minus 36 plus 4m plus 35 by 3. 35 minus 36 is 4m minus 1 by 3. It is 4m minus 1 by 3. I can write this as 4m by 3 minus 1 by 3. After the iteration, I will remove the calculation because I have to further calculate in the same space. 0 into minus m is being given, so it is 0. Then 1 into minus 20 is minus 20. Then we have minus 20 here in Z. So Z minus of minus 20 will give plus 20, which is equal to 0 here. Minus 1 into minus m is m. Then we have 0 here. Then we have 0 here. This will ultimately give minus m. Then we have 0 again. So whatever value you get, you have to put it in negation only. So it is minus 2m by 3 plus 20 by 12. So 4 5s are and 4 3s are. It is 5 by 3. So you have to just reverse the symbol here because you are going to put it in negation. I will get 2m by 3 minus 5 by 3. Then it is 1 and 0. So this is going to be minus m. And this is going to be another minus m. So minus m plus m will give you 0 here. Then the same fraction with the exchange of symbol. It is minus 2 by 3 into minus m will give you 2m by 3. Then 1 by 12 into minus 20 will give minus 5 by 3. So we have to change the symbol. So let me write it in the top. It is minus 2m by 3 plus 5 by 3, then this minus m will stay. Now when you find LCM, this will be minus 3m minus 2m divided by 3, and this is plus 5 by 3. So minus 3 and minus 2 will give minus 5m by 3. So in this we will get 5 by 3 minus 5m by 3. For RHS we need not calculate. We have to find which is higher here. This is in minus, so A2 will not have any modification here. 2m by 3 is present and 4m by 3 is present. Which is higher? So this is 1 point something and this is 0 point something. In this case, this particular value enters. So we are going to consider only this. So X is entering. Now we should see which is leaving. Obviously A1 should leave. Let's check. So 20 divided by 4 by 3, which will be 20 into 3 by 4. So 4 into 5, this will give a value of 15. This will be 10 divided by 7 by 12, which is 10 into 12 divided by 7. This is equal to 120 by 7. So we have already calculated 120 divided by 7 will be something in 17.14 or like that. So which is lesser here? 15 is lesser. So A1 is leaving. So we can say X enters and A1 leaves. So which is the pivotal element here? It is 4 by 3. We will have X here and Y will be here. We have to make this part to be 1. 4 by 3 can be made 1 only when we multiply it by 3 by 4. We will get into the next calculation. So this is 4 by 3, 0, minus 1, 2 by 3, 1, minus 2 by 3, 20. The row A1, old A1. 4 by 3 into 3 by 4 will give me 1. See, 4 by 3 into 3 by 4 will give me 1. Then 0 into 3 by 4 will give me 0. Minus 1 into 3 by 4 will give me minus 3 by 4. 2 by 3 into 3 by 4 will give me 3 get cancelled. 2 2s are 4. So it is 1 by 2. Then 1 into 3 by 4 will give me 3 by 4 minus 2 by 3 into 3 by 4. Just a minus for this answer. So it is minus 1 by 2. Then we have 20 into 3 by 4. This will give a value of 15. We will have 1, 0, minus 3 by 4, 1 by 2, 3 by 4, minus 1 by 2, then 15. What is the coefficient of x in the objective function? It is minus 12 and y it has minus 20. Now as usual you have to find the new y. So now the old y is 7 by 12, 1, 0, minus 1 by 12, 0, plus 1 by 12 and 10. The only way to make this particular value 0, what we should do is we have to bring minus 7 by 12 here and then do a addition. Only then we can make it to be 0. So what we will do is we have to multiply minus 7 by 12 to the new x value. 1 into minus 7 by 12 will give you minus 7 by 12. When you add this, you will have 0 here. Y plus minus 7 by 12 x. 0 into something will give you 0. So there is no change. Then we have minus 3 by 4 into minus 7 by 12. So you have to cancel this. 1s are and 4s are. It is plus 7 by 16. Then we have 1 by 2. 1 by 2 into minus 7 by 12 will give minus 7 by 24. Then we have 3 by 4. So 3 by 4 into minus 7 by 12 will result in minus of 7 by 16. So here this is minus and this is minus. So we are inserting a plus. But here it is plus and this is minus but the same value. So we are giving a minus here. This time you have to negate the sign again. So 7 by 24 in positive. So plus 7 by 24. Then we have a value 15 here. So 15 into 7 by 12. And we have a minus of course. 3 5s are 15. 3 4s are 12. So it is minus 35 by 4. Now you have to add this. So adding this we have already resulted in 0. 1 plus 0 is 1. 0 plus 7 by 16 is 7 by 16. Minus 1 by 12 minus 7 by 24. If we take LCM this becomes 2 and it is minus 9 by 24 and minus 3 by 8. Then we have minus 7 by 16 and here it is 1 by 12 plus 7 by 24. It is 2 times to bring it to 24. So 9 by 24 is again 3 by 8. Now what is 10 minus 35 by 4? So 4 tens are 40. 40 minus 35 divided by 4 will give you 5 by 4. We have got the new y. So it is 0, 1, 7 by 16, minus 3 by 8, minus 7 by 16, 3 by 8 and 5 by 4. X is equal to 15 and y is equal to 5 by 4. We will complete the problem. Minus 12 plus 12 will give you 0 here. And minus 20 plus 20 will give you 0 here. We have minus 12 into minus 3 by 4. Then minus 20 into 7 by 16. 4 3s are 12. This is 9 minus 4 4s are 16 and 4 5s are 20. 9 minus 35 by 4. 9 4s are 36. 36 minus 35 by 4 will give 1 by 4. But you have to put it in negation form because it is 0 minus the value. So we will write it as minus 1 by 4. Then we have 1 by 2 into minus 12. So 1 by 2 into minus 12 will give you minus 6. Then we have minus 3 by 8 into minus 20. So 4 2s are, 4 5s are. So it is 15 by 2 and it is in positive. When we calculate this, it is minus 12 plus 15. It is 3 by 2. Since you have to negate it, it is minus 3 by 2. And here you have minus 9, because it is plus 9 here. Here it is only one symbol, so minus 9. And here it is plus 35 by 4. And it is minus 1 by 4 minus m 1 by 4. Here it is plus 6 minus 15 by 2. It is minus 3 by 2, and you have to make it positive. So it is already in minus, so I have to make this as plus. Now here it is in negation form, so it is plus 3 by 2 and minus m will stay. This is more important now. 15 into minus 12, you have nothing on top. All you have to calculate is this, plus 5 by 4 into minus 20. Now just multiply this. This is minus 180 and this is 4 5s are 20. So it is minus 25, which will give a value of minus 205. For negative function, you have got minus 205 as the answer. This is actually like minus z only. So z will have a value of plus 205. Why we have come to minus 205 is because it's a minimization problem. We have converted into maximization by multiplying it with minus 1. So basically this minus indicates that it is a minimization problem and z value is 205. So from this, x is equal to 15 and y is equal to 5 by 4 and z value is 205. This is the cost of food. Let me give you a recap of everything. We are having a minimization objective function. We have constraints with greater than or equal to inequalities. Now to convert the inequalities to equation, we are introducing surplus variables. Since it is greater than or equal to, we are using negation of the surplus variables, minus s1 and minus s2 in the equations respectively. From this, we are trying to find the basic feasible solution and we are ending up with negative values, which makes this to be infeasible solution. If we have infeasible solution in this case, we have to introduce artificial variables. So we are adding the artificial variables and then equating the equation to 100 and 120 respectively. Again finding the basic feasible solutions, we are ending up with A1 is equal to 100 and A2 is equal to 120 as the basic feasible solution. Regarding the objective function, since we have introduced two kinds of variables in the constraint equations, namely the surplus variables and artificial variables, we are bringing it to the objective function too. And in the objective function, we are placing 0 as the coefficient for the surplus variables and big M as the coefficient for artificial variables. The value of big M will be very large. That's why this method holds the name big M method. Since it's a minimization problem, we are converting it into maximization by just negating the objective function. Since there is no use negating 0, we are just placing 0 as it is. Rest of the coefficients 12, 20 and the big M all are converted to minus value. So minus 12, minus 20, minus M and minus M again for A2 here. So we are starting with a negated objective function and in the final iterations we are ending up with 0, 0 here. Since we need only x and y values, we have got it here. And moreover, there are no positive values here. Everything is negative. See, this is negative, this is negative. 1 by 4 is going to be 0.25 only. Minus 10,000 plus something will give you minus only. So this is also negative and this is also negative. We are calculating for Zj minus Cj. We have to go for the higher value and since all are negative, we are ending the sum with this iteration and ultimately we have got the values of x and y also. From this x and y, we are calculating the objective function value to be minus 205. Since it's in a minus form, it is minus 205. From this, we take the value of z is equal to 205. Since it's a minimization problem, we are ending up with a minus value. And since we have negated the objective function, we are ending up with a minus value. Let me once again repeat this in Tamil. நம்மகிட்ட வந்து ஒரு minimization problem இருக்கு. ரெண்டு greater than or equal to constraints ஓட இருக்கு. இப்போ நம்ம அந்த இன்இக்வாலிட்டிஸ் ஈக்குவாலிட்டிஸாக மாற்றணும்னா நம்ம சர்ப்ளஸ் வேரியபிளை இங்கே மைனஸ்னு போட்டு மாற்றிருக்கோம். ஏன் மைனஸ் போட்டிருக்கோம்னா இங்கே கிரேட்டர் தென் ஆர் ஈக்குவல் டு சிம்பிள் இருக்குது. அதுலேருந்து நம்ம பேசிக் ஃபீஸபிள் சொல்யூஷன் எடுக்கிறப்ப நமக்கு S1 அண்ட் S2க்கு நெகட்டிவ் வேல்யூ கிடைக்கிறதுனால அது இன்ஃபீஸபிள் சொல்யூஷன் ஆகிடுது. அந்த இன்ஃபீஸபிள் சொல்யூஷன் இருக்கிறதுனால நம்ம ஆர்டிஃபிஷியல் வேரியபிள்ஸ் இன்ட்ரடியூஸ் பண்ணுறோம். அதை இன்ட்ரடியூஸ் பண்ணி அதுக்கு ஒரு feasible சொல்யூஷன் கண்டுபிடிக்கிறப்ப அது பாசிட்டிவாக வந்துடுது. அதனால நம்ம வந்து இட்ரேஷனுக்குள்ள போறோம். பட் நம்ம எப்போ சர்ப்ளஸ் வேரியபிள் ஆர்டிஃபிஷியல் வேரியபிள் ஆட் பண்ணாலும் அதை வந்து நம்ம அப்ஜெக்டிவ் ஃபங்க்ஷன்லையும் ஆட் பண்ணணும். அப்ஜெக்டிவ் ஃபங்க்ஷனில் சர்ப்ளஸ் வேரியபிளை நம்ம 0 கோஎஃபிஷியன்ஸோட ஆட் பண்ணுறோம், ஏன்னா இது நார்மலாக ஆட் பண்ணுதுன்னு சொல்லி. ஆனால் ஆர்டிஃபிஷியல் வேரியபிள்ஸை நம்ம ஆட் பண்ணுறப்ப நம்ம ஒரு பெரிய வேல்யூவோட ஆட் பண்ணோம். அந்த பெரிய வேல்யூவை நம்ம கேபிட்டல் M அதாவது பிக் எம்னு சொல்லி டினோட் பண்ணுறோம். இப்போ நம்ம மினிமைசேஷன் ப்ராப்ளம் இதில் அப்ளை பண்ணுறப்ப அப்படியே அப்ளை பண்ண முடியாதுன்றதுனால அதை மேக்ஸிமைசேஷனாக கன்வெர்ட் பண்ணுறதுக்கு எல்லா கோஎஃபிஷியன்ஸையும் நம்ம நிகேட் பண்ணுறோம். நிகேட் பண்ணிட்டு தான் நம்ம இந்த இட்ரேஷனுக்குள்ளே வரோம். இந்த இட்ரேஷன்ஸ் எல்லாம் உங்களுக்கு புரிஞ்சிருக்கும்னு நினைக்கிறேன். நம்ம CJ மைனஸ் ZJன்னு கால்குலேட் பண்ணுறப்ப இருக்கிறதுல எது சின்ன வேல்யூவோ அது உள்ளே என்ட்ரு ஆகணும். ZJ மைனஸ் CJன்னு கால்குலேட் பண்ணுறப்ப எது ஹை வேல்யூவோ எது லார்ஜ் வேல்யூவோ அது என்ட்ரு ஆகணும். பட் இப்போ இந்த இட்ரேஷன் முடிகிறப்ப பார்த்தீங்கன்னா எல்லாமே வந்து உங்களுக்கு நெகட்டிவ் வேல்யூஸில் இருக்கிறதுனால இதோட நம்ம இட்ரேஷன் ஸ்டாப் பண்ணுறோம். அட் த சேம் டைம் நமக்கு X வேல்யூவும் கிடச்சிடுது, Y வேல்யூவும் கிடச்சிடுது. அதுலேருந்து நமக்கு -205 இசட்டோட வேல்யூவும் கிடைச்சிடுது. இது ஏன் மைனஸில் இருக்குன்னா இது ஒரு மினிமைசேஷன் ப்ராப்ளம், நம்ம வந்து அப்ஜெக்டிவ் ஃபங்க்ஷனை நிகேட் பண்ணியிருக்கிறதுனால. ஸோ இதுலேருந்து நம்ம இசட்டோட வேல்யூ வந்து 205 கன்க்ளூட் பண்ணுறோம். Xக்கு 15 Yக்கு 5/4 எந்த வேல்யூஸ் இங்கே வந்து எண்டப் ஆயிருக்குமோ இதுன்னு கன்க்ளூட் பண்ணுறோம். இந்த சொல்யூஷன் தான் உங்களுக்கு இந்த ப்ராப்ளம்ல ஆப்ஷன்ல கொடுத்துருக்காங்க. ஸோ 15 is the X value, 5/4 is the Y value, and we have got the solution as 205 in the simplex method also. Now we'll move to the next question. The dual of the formulated LPP is. How do we find the dual is if the primal is given in form of maximization, the dual will be in the form of minimization. And if the primal is in the form of minimization, the dual will be in the form of maximization, just vice versa. So let's take the objective function z is equal to 12x plus 20y subject to the constraints 6x plus 8y greater than or equal to 100. Then we have 7x plus 12y greater than or equal to 120, where x comma y are greater than or equal to 0. We have to find the dual of the problem. In dual, whatever you have mentioned in inequalities, they will become the objective function variable coefficients. Here you can see C is brought to the constraint part and B is brought to the objective part. So this is actually a minimization problem. So this is the primal of this problem. The dual will have maximization. So maximize Z is equal to 100 plus 120. Now they have given U and V as the variables in the dual form in the options. So we will use the same variables 100U and 120V. Now subject to the constraints. For the primal we went column wise. For the dual you have to go row wise and then equate it to the objective function variable 6U plus 7V, and then we will have 12 here. Then we have 8U plus 12V, then we have 20. What will be the inequality here? See, maximization, if it is in less than or equal to, in minimization it becomes greater than or equal to. They say this is A and this is A transpose. It means while taking minimization, if we go column wise, then the transpose will be, we have to go row wise. We took column wise for primal. It means for dual, we have to go row wise. This is the meaning of transpose here. We have understood that in the primal, if we have inequality as less than, in dual it is changing to greater than. So here it is greater than or equal to in the primal problem, which means here the inequality will be less than or equal to 12. And here the inequality will change to less than or equal to 20. Now just get the meaning alone. The cost should be less than or equal to 12, which says you are minimizing the cost, and the cost is less than or equal to 20, which says you are minimizing the cost. The meaning is not getting changed anywhere. Here minimizing the cost is an objective function. Here minimizing the cost is in the constraint part. Maximizing the daily requirement is in the constraint part, and maximizing the daily requirement is in the objective part. What are X and Y? X and Y are greater than or equal to 0. Since both are positive numbers, here U and V will also be greater than or equal to 0. Now we will see which of the option is matching. So objective function is right in 1, 3 and 4. We will rule out option 2. Now we will check for the condition 6U plus 7V 8u plus 12v. Here they have given 12 and 20. It is perfectly fine. And u comma v is greater than or equal to 0. Everything is fine for option 1. We will check the other options. Maybe a printing mistake. But here they have given u and v are unrestricted. We need not go for this. And here you can see the inequality to be greater than or equal to. So this is also wrong. And here you can also see it is 7v. Actually it should be 12v. And here it is 7v. More than unrestricted. These two equations are actually wrong. So we can mark option 1 to be the right answer. This is the perfect dual of the primal LPP. Next question. The minimum cost of food is as per graphical method, as per simplex method. We have x is equal to 15, y is equal to 5 by 4 and z is equal to 205. So option number 1 will be the right answer. Just substitute the values 15 and 5 by 4 in. Z is equal to 12x plus 20y. 12 into 15 plus 5 by 4 into 20. This will give 180 plus 25 which is equal to 205, the value of Z. So this is the minimum cost of food, 205. With this, we are completing Unit 1 questions. Let's discuss Unit 2 Computer System Architecture Solution. Which of the following circuit is used to store 1 bit of data? A decoder is a combinational circuit that converts binary information from n coded inputs to a maximum of 2 power n unique outputs. So it is n inputs to 2 power n outputs. An encoder is a digital circuit that performs the inverse operation of a decoder. So here the input will be 2 power n and output will be n. So here it is not about 1 bit of data. The number is in n and 2 power n. So we will go for the next option. A flip-flop is a binary cell capable of storing 1 bit of information. So what is 1 bit? Either a 0 or a 1 will be stored. Circuit that can maintain a binary state. So it is a 0 or a 1. Here the storing 1 bit of information is what they are asking as 1 bit of data. It has two outputs, one for the normal value and one for the complement value of the bit stored in it. In case the value is actually 1, the complement 0 will also be given as output. And if the stored value is 0, the complement 1 will also be given. So that's what they say, one for the normal value and one for the complement. In that case, they are going to store only 1 bit of data, either a 0 or a 1. The next option, a register is a group of flip-flops with each flip-flop capable of storing 1 bit of information. So here they say every flip-flop will store 1 bit of information and register will be a group of flip-flops. So more than 1 bit of data can be stored. An n-bit register has a group of n flip-flops and is capable of storing any binary information of n bits. So n flip-flops and n bits, which says one flip-flop will store 1 bit. Option number 3, flip-flop will be the right answer. Flip-flop is used to store 1 bit of data. Next question, identify the code sequence. They have given 4 options, BCD, binary coded decimal, XS3, XS3 gray and gray code. Out of these 4 options, you can find one thing, 1010, 1 bit is changed, 1011, now this bit is changed, 1001, now this bit is changed, 1000. So only 1 bit is getting changed here. We will have a look at all the codes. So we have the decimal format here. For BCD and gray, we are having from 0 to 15 and XS3 is actually base 10 code. That's why we are stopping it with 9, 0 to 9. And XS3 gray also we are stopping with 0 to 9. So what is BCD? You have 2 power 0, 2 power 1, 2 power 2 and 2 power 3. So 1, 2, 4, 8, 8421 code. And what is XS3? It is the BCD code plus 3. So this is actually 3 in decimal. So when you have 84210011 will give you 3. So you have to add 3 to it. If it starts from 0, this will start from 3. So 0 plus 3, then 1 plus 3, then 2 plus 3, it goes on. So it is 3, it is 4, it is 5, it is 6, it is 7, it goes on like this. Whatever I write is decimal value. Next is XS3 gray code. Here XS3 gray code is again gray code plus 3. So from 3, it will be starting. So 0010, 0110, 0111 and everything will go from here. XS3 BCD starts from here and XS3 gray starts from here. With gray code, only one bit changes state from one position to another. This is what is happening with the code sequence here. And where do you find this code sequences? From this part to this part. This is what is given in the question. 1010, 1011, 1001 and 1000. And so we can say that option 3 gray code will be the right answer. So we know how to calculate BCD, how to calculate XS3, and we also know how to get XS3 gray from gray. But what is actually gray? It is one bit changing from one position to another. Just we will see. Here 0 is getting changed to 1 and this 0 is changing to 1 and again this 1 is converting to 0. Then this 0 is changing to 1 and this 0 is changing to 1. Then this 1 is changing to 0. So at a time only one bit is getting changed. So this is happening only with gray code. Next question. The micro operation which divides a signed binary number by 2 is. Shift micro operations are used for serial transfer of data and all the operations given here are shift micro operations. In that first we'll look about logical shift. It is the one that transfers 0 through the serial input. This is the actual definition of logical shift. Unfortunately, this answer is marked as the official key, but it is not the right answer. The next one is circular shift. It is also known as rotate operation. This circulates the bits of the register around the two ends without loss of information. We have arithmetic shift. This is a micro operation that shifts a signed binary number to the left or right. Now we look about what is shifting left and what is shifting right. An arithmetic shift left multiplies a signed number by 2. So left shift is for multiplication. An arithmetic shift right divides the number by 2. Which number? They are talking about the signed number. The micro operation that divides a signed binary number by 2 is arithmetic shift right. Option 3 will be the right answer. Next question. A program that is used by other routines to accomplish a particular task is called. What is a micro operation? It's an elementary operation or a basic operation performed on the information stored in one or more registers. Then what is a micro instruction? A micro instruction specifies one or more micro operations for the system. Micro operation, it's a basic operation, and when you have many micro operations, it is a micro instruction. A sequence of micro instructions constitute a micro program. When you have many micro instructions, this becomes a micro program. So there are two terms, micro operation and micro program in the option. Nothing tells about routines here. So we are ruling out. Micro instructions are stored in control memory in groups, with each group specifying a routine. Each computer instruction has its own microprogram routine in control memory to generate the micro operations that execute the instruction. Subroutines are programs that are used by other routines to accomplish a particular task. Even routine has to be ruled out here. Option number 4, subroutine will be the right answer. So here is the exact statement that matches the question. A subroutine can be called from any point within the main body of the microprogram. Next question. An address in main memory is called. An address used by a programmer will be called a virtual address. And the set of such virtual addresses is the address space. An address in main memory is called a location or physical address. This is what the question is about. The set of such location is called the memory space. So address space is about virtual address and memory space is about physical address. So option number 4, physical address, will be the right answer. The address generated by a segmented program is called a logical address. The memory address tells the control where to find an operand in memory. Next question. A system bus in which each data item is transferred during a time slice known in advance to both units, source and destination, is called. Data transfers over the system bus may be synchronous or asynchronous. So this is about the data transfer over the system bus. In a synchronous bus, each data item is transferred during a time slice known in advance to both source and destination units. So the statement that is asked in the question is about the synchronous bus. Option 4 will be the right answer. Then what about asynchronous bus? Each data item being transferred is accompanied by handshaking control signals to indicate when the data are transferred from the source and received by the destination. So data transfer to and from peripherals may be handled in one of the 3 possible modes. So under this context you have 3 modes. One is programmed input output, another is interrupt initiated input output, and the third one is direct memory access, which is DMA. So this is about the data transfer to and from peripherals. In direct memory access, the interface transfers data into the memory and out of the memory unit through the memory bus. Then what about MIMD? Flint's classification divides computers into 4 major groups. Single instruction stream, single data stream, called as SIST. Then single instruction stream, multiple data stream, called as SIMD. Multiple instruction stream, single data stream, called as MIST. And multiple instruction stream, multiple data stream, called as MIMD, which is given in the option. What is MIMD then? This organization refers to a computer system capable of processing several programs at the same time. So this is about processing and not about data transfer. Most multiprocessor and multi-computer systems can be classified in this category. So this is about processing and this is about data transfers. So under data transfer, this is over the system bus and this is to and from peripherals. Next question. The interface that provides I/O transfer, input output transfer of data directly to and from the memory unit peripheral is or are termed as. Just now we saw the explanation of DMA. So definitely option A is included. Whichever option has excluded A can be ruled out. Data transfer to and from peripherals may be handled in one of the 3 possible modes. So one is programmed I/O, another is interrupt initiated I/O, and the third one is DMA, the interface that transfers data into and out of the memory unit through the memory bus. What is IOP? Input output processor. The purpose of IOP is to provide an independent pathway for the transfer of information between external devices and internal memory. In that way, we can also mark IOP to be one of the interface. A and B only is included in option 3. So option number 3 will be the right answer. Option 1 is also ruled out. So what about the serial and parallel interface? Let me show you a diagram here. You can see the parallel interface as well as the serial interface. Serial interface supports various serial input output schemes and parallel I/O ports configurable for a variety of parallel I/O schemes. Next question. Which of the following are main memory? You can look at this memory hierarchy diagram. Actually, you have secondary memory as auxiliary memory here. Magnetic tapes and disks are a part of it. Then you have I/O processor. Then it is actually connected to the main memory, and the processor, the central processing unit CPU, is connected to main memory and cache memory. Portions of a program or data are brought into the main memory as they are needed by the CPU. So from the secondary memory they are brought to the main memory. Virtual memory is a concept used in large computer systems that permit the user to construct programs as though a large memory space were available equal to the totality of auxiliary memory. So it gives a view that more memory space is available. It is not directly main memory, but it's a concept. The cache contains a copy of portions of main memory, which says cache memory is also a part of main memory. Then we have random access memory. Actually, RAM is the main memory in a computer. We say 4 GB RAM, 8 GB RAM, 16 GB RAM, 32 GB RAM. Everything is about main memory. So it's a direct reference. Since RAM is volatile, its contents are destroyed when power is turned off. So once we switch off the computer, whatever is in RAM will be destroyed. It's volatile means it is not permanent. Then we'll learn about SSD. SSD is solid state drive. It's a memory device made with solid state components that can be used as a replacement to a hard disk drive. Actually, it's a secondary device that is used as a replacement to hard disk drive. So HDD is not a part of main memory. Something that is used as a replacement to HDD, that is hard disk drive, will also not be a part of main memory. So this is also excluded, and virtual memory is actually a concept, so that is also excluded. Option number 2, B and C will be the right answer. So only cache memory and RAM are considered to be main memory. So RAM is directly the main memory and cache contains parts of main memory in order to speed up the works. Next question, match list 1 with list 2. So list 1 has some instructions and the explanation is given in list 2. So basic computer instructions. The symbol is given in the left side and the description is given on the right side. The first symbol, SZA. The description is skip next instruction if AC 0. That is, if accumulator is 0, skip next instruction. Skip if AC is 0. A is mapping to 4. We will rule out 1 and 4 here. Then we will go to SKI. It is here. Skip on input flag is the description. Skip on input flag means whenever the input flag is on, we have to skip. So B is mapping to 3. So option 3 is also ruled out. SNA. Skip next instruction if AC negative. Skip if AC is negative will be C. C is mapping to 2. ISZ. Increment and skip if 0. Increment M and skip it 0. So it is skip if 0. D is mapping to 1. Option number 2 will be the right answer. You can also have a look about all other symbols and their descriptions once so that it might be useful for you in some other question paper. Next question. In most general case, the computer needs to process each instruction with the following sequence of steps. In the basic computer, each instruction cycle consists of the following phases. Generally, we will say fetch, decode and execute. But what happens is, we will fetch an instruction from the memory. Then we will decode the particular instruction. We will try to read the effective address from memory if the instruction has an indirect address. It means we have to calculate the effective address and then read it from the memory. After reading it from the memory, we will get the operand from the memory and then execute the instruction. So this is what will happen in the instruction cycle phases. So we will start with fetch an instruction from memory. It is directly given. So C will be the first one. We will rule out 1 and 2. Then we go with decode. Decode the instruction is in E. After decoding, we have to check if the particular instruction has any indirect address. When there is indirect address, you have to calculate the effective address. The next option will be A. After calculating the address, I have to read the address from memory. So what will be available in the memory? Operand will be available in the memory. Fetch the operand from the memory. We have D here. Then we go for execute the instruction, which is in option B. So this is fetch, this is decode and this is execute. CEB is given in both the options. AD, option number 3 will be the right answer. We will rule out option 4. So this is about calculating the effective address. After calculating, we are fetching the operand from the memory. If your instruction has a direct address, you can go and fetch it from the memory. But if it has an indirect address, you have to calculate the effective address, and using that address only, you can fetch the operand from the memory. With this, we are completing Unit 2 questions. Let's discuss Unit 3, Programming Languages and Computer Graphics Solutions. Consider a triangle PQR with coordinates as P0, 0, Q2, 2 and R10, 4. If this triangle is to be magnified to 4 times its size while keeping R10, 4 fixed, then the coordinates of the magnified triangle are. Since they said R is going to be fixed, there will be no change in R coordinates. It is about magnification to 4 times, which means here we are talking about scaling transformation. Now let's take x and y axis here and we'll plot the points now. 0, 0 will be here. So this is point P. Then we have 2, 2, the point Q. Then we have 10, 4, the point R. So we'll form a triangle here. They are asking us to find the coordinates of P and Q, keeping R as fixed. We can control the location of a scaled object by choosing a position called the fixed point. In this case, it is R, that is to remain unchanged after the scaling transformation. Coordinates for the fixed point are taken to be xf and yf, that is x fixed and y fixed. As of this problem, we can take xf to be 10 and yf to be 4 because R has the coordinates 10, 4. This belongs to x-axis and this belongs to y-axis. For a coordinate position x, y, the scaled coordinates x dash, y dash are given by the following formula. So here the value of Sx will be 4 because it is magnified to 4 times. Similarly, this will be the value for Sy also. So x is also magnified to 4 times and y is also magnified to 4 times because they are given it is magnified to 4 times its size. It means the change will be applicable to x-axis as well as y-axis. Let's start with the coordinate P. So P has 0, 0 as its coordinate. So from this we can take x is equal to 0 and y is equal to 0. Now we have to find x dash. X dash is equal to x into Sx. The value is 4 plus xf. We have found xf to be 10 and yf to be 4 from R coordinate. So it is 10 into 1 minus Sx is 4. If we calculate 0 into 4 will give you 0 plus 10 into 1 minus 4 is minus 3. So 0 minus 30 which is equal to minus 30. This will be x dash. If you calculate y dash, so y into sy, again it is 0 into 4 plus the yf value is 4. 4 into 1 minus 4 which is equal to 0 plus 4 into minus 3. So this is equal to minus 12. So what is p dash from this? The new coordinates will be minus 30, minus 12. Then we will find for Q which has the coordinates 2, 2. So from this we can take x is equal to 2 and y is equal to 2. Just substitute x dash is equal to 2 into 4 plus the same thing 10 into 1 minus 4 which is equal to 8 plus 10 into minus 3 will give minus 30. This will give a value of minus 22. Y dash is equal to same thing 2 into 4 plus 4 into 1 minus 4. So 8 plus minus 12 here and you will have minus 4 here. Now from this Q dash the value will be minus 22 minus 4. So option number 2 you have minus 30 minus 12 and Q you have minus 22 and minus 4 and R remains fixed. Option number 2 will be the right answer. If you take option 1 you have wrong coordinates here. So we can rule out. If we take third one, you have wrong coordinates here and even a minus is missing here. In the fourth option, a minus is missing in both the cases. So 1, 3 and 4 are wrong. Next question. Which of the following statements is true? In polymorphism, we use pointer to base class to refer to all derived objects. Even when the base pointer contains the address of the derived object, it still executes the base class function. Runtime polymorphism is achieved by virtual function. In general compile time polymorphism, this will be the case. So in order to override this and make the derived class function execute, we make use of virtual functions. When we use the same function name in both the base class and the derived class, the function in the base class is declared as virtual using the keyword virtual preceding the normal declaration. So if we say there is a method like public function, the word virtual will be placed here in the base class. This determines which function to use at runtime based on the type of object pointed to by the base pointer. So here they have told even when the base pointer contains the address of the derived object, it still executes the base class function. To override this only, we are using virtual functions in runtime polymorphism by declaring the keyword virtual in front of the function declaration or the method declaration. We must access virtual functions through the use of a pointer declared as the pointer to the base class. So virtual functions do not implement polymorphism is wrong. They are a part of runtime polymorphism. Next, virtual functions do not permit calling of derived class functions using a base class pointer. Use of virtual function is to use the pointer to the base class for calling derived class function. So it will decide which function to use at runtime based on the type of object pointed to by what? By the base pointer. So this is also wrong. Virtual function is for this purpose only. They have given do not permit. So next two options we have to know about pure virtual function. A pure virtual function is a function declared in the base class that has no definition relative to the base class. So here pure virtual functions can never have a body. It means they don't have a definition. Is that so? No. Actually they have a definition but it is not related to the base class. That is the case. So this is also wrong. Now the question is which is true? So obviously option number 3 will be the right answer. What is the statement? We can never build an object from a class containing a pure virtual function. So classes containing pure virtual functions cannot be used to declare any objects of its own. This is the statement that justifies the option 3. We can never build an object means no object can be declared. Such classes are abstract base classes because you are declaring this pure virtual function in the base class. A virtual function equated to 0 is called a pure virtual function. So we can say there is no object from abstract base classes. Next question. What is the output of the following program? Inside the main function, they have initialized I is equal to 3. Then there goes a while loop. The while loop is from here to here. Then we have a print statement after the while loop. So this is the beginning of the while loop. This is the ending of the while loop. We have three statements inside the while loop. One is initializing I is equal to 10. Then we have I decrement, that is I is equal to I minus 1. Then we are printing I. So let's get into the main program. I is equal to 3. We are initializing this. And here I is equal to I minus 1, which says the value of I is 2. Inside the loop what happens is we have I is equal to 10. I minus minus will make I is equal to 9 and I am printing percentage %d. So only 9 will be printed here. In the output you will have 9 here. We will go to the while loop now. I is equal to I minus 1 will make the value of I to be 1. Again we get into I is equal to 10. Then I is equal to I minus 1 will make I is equal to 9. We are printing another 9. So along with the previous output 9, we have another 9. again we are getting into the loop. I is equal to I minus 1, which is equal to 0. This I is equal to 10 because we are initializing it again here. This will be treated as a local variable that is bound to the while loop alone. And I is equal to I minus 1 will make it 9. Another 9 is printed. So along with the 2 9s, the third 9 is also printed. Now I is equal to I minus 1, which will make the value minus 1. When the user types in a negative number inside the while loop, the condition of your while loop will not evaluate to true. It will be true when it is greater than or equal to 0. While loop will be true for values that are greater than or equal to 0. While loop will be evaluating to false when the value is less than 0. Here, once it gets to the value of minus 1, it becomes less than 0. So here it will exit the while loop. It will not go inside the loop here. So once it exits, you have another printf here. What does it print? The I value. What is the I value now? It is minus 1. So 999 along with that minus 1 is printed. Inside the loop is local to the loop. Inside the condition part of while loop is global I. It is available for the whole program, but inside the loop only this I will be available. Whenever you get inside the loop, I will be initialized to 10 every time because they have given int I is equal to 10. So what is the final output you got here? 999 minus 1. Option number 3 will be the right answer. You can use any online C compiler, type the complete program and give print statements everywhere wherever you get doubts and try to understand how it executes. Next question. The hue of a color is related to. Of course, this is computer graphics question. A light source such as sun or a standard household light bulb emits all frequencies within the visible range to produce white light. When white light is incident upon an opaque object, some frequencies are reflected and some are observed. The combination of frequencies present in the reflected light determines what we perceive as the color of the object. If low frequencies are predominant in the reflected light, the object is described as red. In this case, we say that the perceived light has a dominant frequency or dominant wavelength at the red end of the spectrum. The dominant frequency, the dominant wavelength is also called the hue or simply color of the light. So in this case, the dominant frequency is called the hue. What is the dominant frequency otherwise called? It is called the dominant wavelength. So frequency, wavelength and hue all are same here. So we can mark option 4 to be the right answer. So we will also learn about the other 3 options. When we view a source of light, our eyes respond to the color, the dominant frequency and 2 other basic sensations. What are the 2 other sensations? One of these we call the brightness, which corresponds to the total light energy and can be quantified as the luminance of the light. So luminance is talking about the brightness and brightness is about the total light energy. So first is luminance and the second one is the hue and the third one is what we are going to see next. The third perceived characteristic is called the purity or saturation of the light. So purity is saturation. Purity describes how close a light appears to be to a pure spectral color such as red. So saturation is about purity. So they say one of these and they have given the third. It means luminance, then we have hue, then we have saturation. Chromaticity is used to refer collectively to the 2 properties describing color characteristics, that is purity and hue. We call them together as chromaticity. Radiation emitted by a white light source has an energy distribution that can be represented over the visible frequencies. So such kind of radiation is what we call as incandescence. Next question. What is the output of the following program? Hash include stdio.h. Then we have something called hash define. The hash define directive tells the compiler to substitute the function macro whenever it sees the function name. So what is inside the function macro? You have to multiply x with itself. So SQR of x is x into x. Now we'll get inside the main program. Int a comma b is equal to 3. So b is initialized to 3. A is equal to square function. Inside we have the argument, namely b plus 2. What is the value of b? It is 3. Whatever is inside the brackets will be taken to be x. So what is the definition of square function? It is x into x. Now what is in the place of x? X is equal to b plus 2. So in the place of x into x, we will be using b plus 2 into b plus 2. Now what is the value of b? It is 3. So when I substitute b is equal to 3, this x into x will be 3 plus 2 into 3 plus 2. Now what will be the usual precedence of computation? Multiplication will take the first precedence and then addition will be taking place. So the first precedence will be given to multiplication. 2 into 3 will give you 6. And then you have to add the other two sides. 3 plus 6 is 9. 9 plus 2 is 11. So A will have the value of 11. We are printing A in the next statement and return 0 is given since we have used int main. So what is the value that will be printed? It is 11. Option number 2 will be the right answer. If you want to have good clarity of how this is working, you have to use it in an online C compiler and just try changing the values and then work it out manually in a paper, and then you will be able to understand how this precedence operation is working. So let's take two examples. The first example, let b stay as 3. A is equal to square of b plus 3. Now how this will be interpreted is x into x will be b plus 3 into b plus 3. So 3 plus 3 into 3 plus 3. So 3 into 3 is 9. So 3 plus 9 plus 3, which will give a value of 15. The second example, when you pass the value like b plus 2, now this brackets will take the highest precedence. So what will happen is, first b will be substituted by 3 and this operation will take place first. So this becomes SQR of 5. SQR of 5 will give 5 into 5 as per the function definition, which is equal to 25. This is the value that has been given in option number 1. So usually we do this mistake. Only when it is included in the bracket, you can first sum it up and then go with the function definition. But when it is used without brackets, when it is just plainly given as b plus 2, you have to go for this kind of computation. Next question. Consider the 3 points P1, P2, P3 and a viewpoint C. Choose the correct options. In 3D scene, the identification and removal of surfaces that are blocked or hidden from view is called hidden surface problem. So from this part only they have asked this question. Any hidden surface algorithm must determine which edges and surfaces are visible either from the center of projection for perspective projections or along the direction of projection for parallel projection. Center of projection is for perspective projection. Along the direction of projection is for parallel projection. So here you have a term called obscure. Obscure means not able to see properly or clearly. They are given 3 points P1, P2 and P3 and a viewpoint C. The equations of a line determined by 2 points P0 and P1 are given by x is equal to, then y is equal to and z is equal to. These are the equations of a line. So they are asking which point is actually visible and which is hidden. To know that, we have to find the equations of a line determined by 2 points. So let's do it for point C. 0, 0, minus 10 and point P1. This is 1, 2, 0. As per this equation, Now we'll take this to be x0, y0, z0 and this to be x1, y1 and z1. X is equal to x0, 0 plus x1 minus x0. x1 is 1 minus 0 into t. So we can say x is equal to t. Then we have y. y0 is 0 plus y1 is 2. 2 minus 0 into t. Y is equal to 2 into t. Then we have z. Minus 10 plus 0 minus of minus 10 into t. This will be minus 10 plus 10t. So z is equal to minus 10 plus 10 into t. This is between C and P1. So let's take a viewpoint here as C and let's take P1 here somewhere. So this is from C point to P1 point. We have found these lines of equation. Now we will determine whether P2 is lying on this line. Either A is possible or B is possible. So they say P1 is obscuring P2. In B they are saying P2 is obscuring P1. Only one of the statement can be true. If any of the option is giving both A and B, rule it out. To tell in Tamil, ஒன்னு P1 P2 மறைக்குதுன்னு எடுத்துக்கணும், இல்ல P2 P1 மறைக்குதுன்னு எடுத்துக்கணும். ஏதாவது ஒன்னு தான் இதுல உண்மையா இருக்கணும். Either P1 is giving an obstruction to P2 or P2 is giving an obstruction to P1. So take this to be P1 and take this to be P2. So seeing from C, either this should be the case or C P2 P1. This should be the case. Both cannot happen. So this is about A and B. You have to find which is true from A and B. From this we can understand C and D are perfectly right. So these two are correct. Now let's go for point 2 to determine P2 3, 6, 20 lies on this line. Which line? From C to P1. We see x is equal to 3 here. X, y, z is given. From this we can find t. So t is equal to 3. In this equation we have found that x is equal to t. So from this coordinate using x is equal to 3 we can take t is equal to 3. X is equal to 3. Y is equal to 2 into 3 which is equal to 6. Then z is equal to minus 10 plus 10 into 3 which is equal to minus 10 plus 30 which is equal to 20. 3, 6, 20. When t is equal to 3, you get the P2 points exactly. From this we can say P2 lies on the projection line through C and P1. Projection in the sense you have to consider this in three-dimensional form. We can say C occurs when t is equal to 0. Just substitute the points. X is equal to 0, y is equal to 0 and z is equal to minus 10. We are getting the coordinates of C here. P1 occurs when t is equal to 1. So x is equal to 1, y is equal to 2 and z is equal to minus 10 plus 10 into t is 10 which will give you 0. This is exactly the coordinates of P1. And P2 occurs when t is equal to 3. So this is x is equal to 3, y is equal to 6 and z is equal to 20. Now we will leave this and get a clear image. So this is C and this is P1. This occurs at t is equal to 0. This occurs at t is equal to 1. And now when t is equal to 3, you will obviously have P2 in the projection line of C and P1. So P2 is actually available here where t is equal to 3. We determine which point is in front with respect to C. From this, comparing the t values, we can understand P1 is in front of P2 with respect to C. So I can say P1 is obscuring P2. P1 வந்து P2 மறைக்கிறதா நம்ம எடுத்துக்கலாம். So in that case, if viewed from C, P1 is obscuring P2 and so we mark A to be true which will make B to be false. So we have to choose only the correct options. In that case, we are marking option number 2 to be the right answer. Now we have to check if P3 is on this line or not. So P3 is 2 comma 4 comma 6. So from this we can check for T is equal to 2. So let's take P3 2 comma 4 comma 6. So here T is equal to 2. We have to check whether it is obscuring P1 or P3. We know C and D are true, even then we'll check. So x is equal to T. So we have x is equal to 2. Y is equal to 2 into T. 2 into 2 will give 4. So x is 2, y is 4. So far right. What is Z? Z is equal to minus 10 plus 10 into T. 10 into 2 will give 20. 20 minus 10 will give 10. And Z is equal to 10. So if P3 has to lie on the same projection line, it should have coordinates 2, 4, 10. But here it has 2, 4, 6, which makes it evident that P3 is not on this projection line. 2, 4, 6 can occur somewhere here, but not on this line. So it neither obscures nor is obscured by P1 and P2. P1 will not hide P3, P2 will not hide P3 at the same time. P3 will not hide P2 and P3 will not hide P1. P1 P2 P3 மறைக்காது, P3 P1 P2 மறைக்காது. P3 does not obscure P1. If viewed from C, it is true because it is not lying on the projection line. P2 does not obscure P3. It is also not going to disturb P3. So this is also true. So we are just trying to find how C and D are true. Next question. Which statements are correct? So we have a set of statements on constructors. Constructor is invoked at the time of object creation. Whenever the object is created, constructors are invoked automatically. It is perfectly true. A is correct, so we can exclude 3 because it does not have A. If you have a class named A, inside the class definition you will have a method called A that is with the same class name, and you will have a definition inside. So whenever you create an object for A, if I say A, then it will automatically invoke this particular method. In fact, other methods are usually called using their name, but constructors you need not call them. Next statement is about return type. Constructor cannot have a return type, not even a void return type. So constructors do not have return types, not even void, and therefore they cannot return values. It is true. In this case, 4 is also ruled out. Next, they are saying constructors are not inherited by subclasses. Subclass means derived classes, but the constructor of the superclass, the base class, can be invoked from the subclass. There is a base class and we have derived 1 and derived 2 class. The constructors are not inherited here, but the constructor of the base class can be invoked from the subclass. It means inside the subclass or inside the derived class, I can invoke the base class constructor. So constructors cannot be inherited. It is right. Though a derived class can call the base class constructor is what this statement said. So C is also right. So if I mark A, B, C as true, obviously we know D is false and option 1 is also ruled out. Option number 2, A, B and C will be the right answer. But what is false with D? A constructor cannot be virtual because at the time when the constructor is invoked, the virtual table would not be available in the memory. This is the reason behind why it cannot be declared as virtual. Cannot be declared as virtual will be the right statement. Can be declared is the wrong one here. Next question, match list 1 with list 2. If you have gone through the previous year question papers so far, you could at least map 2 or 3 algorithms here. So whenever we say Bressenum, it always ends up with Bressenum's line algorithm. So Bressenum's line drawing algorithm will be like this. So we will plot points little by little and then draw a line through the points. So A is mapping to 2. Except the first one, everything is having 2. Then we have Cohen-Sutherland's algorithm. Cohen-Sutherland line clipping algorithm. So B is mapping to 3. A2, B3. Again we have two options. Let's rule out 4. Next one is Sutherland-Hodgman algorithm. Question in the previous year question paper was which polygons are clipped using Sutherland-Hodgman algorithm? Whether it's convex or concave they have asked. So C is mapping to 4. C4, and so option 2 is also ruled out. Option number 3 will be the right answer. So it is polygon clipping here. And then the final one, Z buffer. This is a hidden surface removal algorithm and D will be mapping to 1. A commonly used image space approach for detecting visible surfaces is the depth buffer method. This approach is also frequently referred as the Z buffer method because object depth is usually measured along the Z axis of a viewing system. Since the depth is represented by Z axis, we call this as depth buffer method or Z buffer method. So can you see the view plane and 3 points? Now we'll just use another question's explanation here. Consider this to be C, this to be P1, this to be P2 and this to be P3. Just before 2 or 3 questions we saw about obscuring images. This is the actual case. So I am trying to map that question's explanation with this diagram since it will be easy for you to map it. Next question, consider the following code segment. They have initialized an array. Whenever we have array values and we have a pointer here, if I say pointer is equal to ARR, the array, which indirectly means it is array of 0. And now the values of the array are 0, 1, 2, 3, 4. And this is the index position. These are the values. The pointer is given ARR plus 2, which means the pointer is here. Arrange the following printf statements in the increasing order of their output. The value of I is initialized to 1. What is PTR of 1 here? Since the pointer is here, this will be taken as the 0th index. When I say it is PTR of 1, it means it is referring to this position. This is PTR of 1. So I have the value 3 here. Next one is I plus 1. I plus 1 means it is PTR of 2. So this is PTR of 2. This is the general case I have told when it is ARR. But here it is ARR plus 2. So for the pointer this is the base index. This is the 0th index. Next we have minus I. Minus I means just minus 1. So from 0 I have to move to minus 1. This is minus 1 and I have the value 1 here. Next is minus I plus 1. That is minus 1 plus 1 which is equal to 0. What is PTR of 0? It is 2. Usually when they point a pointer to an array, it refers to the base index 0. But here they have initialized the pointer to array index plus 2. It means array of 2 is assigned to pointer of 0. Array of 3 is initialized to pointer of the next element 1. Array of 4 is referred by pointer of 2. What is before 0? So it is pointer of minus 1, which means it is referring to array of 1. What is an array of 1? It is 1. What is an array of 2? It is 2. What is an array of 3? It is 3. What is an array of 4? It is 4. So what is the order? It is minus 1, 0, 1 and 2. Which gives minus 1 here? C gives minus 1 here. So C comes first. Then which gives 0? D gives 0 index. So D comes next. Then we have 1. A gives 1. So A comes next. I plus 1 gives 2. And so B comes next. They have used only these 4 elements. They have not used this element. The first element is not used. So C, D, A, B. Option number 2 will be the right answer. If you still have doubt, please use online C compiler and print all the statements. Next question. Given below are 2 statements. The friend function and the member functions of a friend class directly access the private and protected data. The next statement, the friend function can access the private data through the member functions of the base class. A friend class can access private and protected members of other classes in which it is declared as a friend. It says that statement 1 is true. In C++, friendship is not inherited. That means if a base class has a friend function, then the function doesn't become a friend of the derived class. In principle, a publicly derived class inherits access to every member of a base class except its constructors and destructor, its assignment operator members, its friends, its private members. It means a publicly derived class can inherit every member of a base class, and these are the 4 exceptions. Derived class will not inherit all those things. The friend function can access the private data through the member function of the base class is true. Derived classes alone they have mentioned here, they have not mentioned about the base class. So if I declare something in the base class, I can obviously access the private data. Usually friend function and friend class member functions can access private data, which means if I have a friend function in the base class, I can access the private data. These statements are with respect to derived class. This particular friend concept is not inherited. That's what they have given. Friendship is not inherited. The explanation is for derived class, but the statement is about the base class. From this we can conclude option 1. Both statement 1 and statement 2 are correct as the right answer. With this we are completing unit 3 questions. Let's discuss unit 4 database management system solutions. Create table T in SQL is an example of. So this is actually a statement, a kind of command that is asking to create a table. So definitely normalization and primary key will not be the option. Knowing the basics of SQL, we all must know create command belongs to DDL. So we'll just see what are the commands. DDL is data definition language. Most commonly used commands are create, alter, drop. Create is to create a table. Alter is to modify the table fields and the constraints. Drop is to delete the table completely. Next we have DML, data manipulation language. This is to work with the data inside the table. We have 4 commands: insert, select, update and delete. Insert is to insert values, select is to retrieve values, update is to modify the values of the fields, and delete is to remove the complete row or remove the complete record. So create table T belongs to DDL. Option number 3 will be the right answer. Next question, which one of the following statements are correct? Granularity is the size of data item in a database. The size of a data item is called its granularity, and it can be a field of some record in the database, or it may be a larger unit such as a record or even a whole disk block. The statement says it is the size of the data item and granularity is the right term, so A is correct. From this we can rule out option 4. They are saying the size is granularity, but the data item can be anything. It can be a field, or it can be a record, or even a whole disk block. So this it refers to the data item. Next statement, 2 operations in a schedule are said to be in conflict if they belong to the same transaction. 2 operations in a schedule are said to be in conflict if they satisfy all 3 of the following conditions. What are the conditions? They have to belong to different transactions. They have to access the same item X, and at least one of the operations is a write operation. B says it is said to be in conflict if they belong to same transaction, which is totally wrong. The official answer has been marked as option number 2, which includes B. In fact, all the options include B, but it is false. The next statement, 2 schedulers are said to be conflict equivalent if the order of any two conflicting operations is the same in both schedules. When transactions are executing concurrently in an interleaved fashion, then the order of execution of operations from the various transactions is known as a schedule or history. So now comes the statement. Two schedules are said to be conflict equivalent if the order of any two conflicting operations is the same in both schedules. If the order is going to be same in both the schedules, then definitely it will be conflict equivalent only. When we have change in the order of execution, it need not be in conflict. In that case, we can mark C to be true. So the next statement, write operations which are performed without performing the right operation are known as blind writes. A blind write is a write operation in a transaction T on an item X that is not dependent on the old value of X. So, it is not preceded by a read of X in the transaction. Write operation is performed without performing read operation. Say we have a data item called X. Before writing the value of X, we have to read X and then only we have to write X. In case you have read the value of X at time t0 and this is at time t5 and this is time t6. If I use the value of X at time t0 here and then make a write operation, it is said to be blind write. Write operations which are performed without performing the read operation is known as blind write. That is what is given inside the brackets here. Write performed without read operation. So they say it is not preceded by a read. It is not dependent on the old value of X, that is the read of X. Instead it is blindly writing it. So whenever you want to update, you have to first go with the read operation is what they say. When the read is missing, it becomes a blind write. So D is also wrong here. A and C only will be the right options here. So none of the options are matching this, but this is the official key. So A and C only are right, B is not right. Next question. Which of the following are not correct statement? Seeing the statements, you can ask, this might belong to data structures. Of course, this is a data structure statement too. But the thing is, here the statement, the first record in each block of data file. And when they say it is about dense index for index entries and searching is harder in B plus and B tree, and when they talk about extendable hashing, all these are part of file organization in DBMS. The first record in each block of data file is known as actor record. So we have something called primary index. The first record in each block of data file is called the anchor record of the block or the block anchor and not actor record. So A is false. Next, dense index has index entries for every search key value in the data file. This is true. So whichever options include B has to be ruled out now. Option number 2 will be the right answer. Searching is harder in the B plus tree than B tree as all the external nodes link to each other. What is the right statement? The search is faster in B plus tree than the B tree as the keys are present at leaf nodes. So this statement is totally wrong and we will mark it as false. So in the context of B plus tree, they say the search is faster. And where this content comes about anchor record is in primary index. That's why I have given the context of the statement as primary indexes. Next statement. In extendable hashing, the size of the directory is just an array of 2 power d minus 1 where d is global depth. Extendable hashing is a dynamically updatable disk-based index structure which implements a hashing scheme utilizing a directory. The index is used to support exact match queries, that is, find the record with a given key. This directory has the form of an array with 2 power d entries, each entry storing a bucket address, and d is the global depth of the directory. An array of 2 power d minus 1 is wrong, so d is also false. So option 2 will be the right answer. Next question. Match list 1 with list 2. We are given the normal forms in list 1 and their explanation in list 2. What is the first normal form? We have to have atomic values. What does atomic mean? We have to have single value for fields. The other term for this is, we can say, scalar values. 1NF, if and only if all underlying domains contain scalar values only. Domains in the sense the fields or the columns. So C will be mapping to 2. The only option where we have C mapping to 2 is option number 2. So option number 2 will be the right answer. This is joint and MVD is multi-valued dependency. FD is functional dependencies. So you have the order of 1NF, then 2NF, then 3NF, then we have BCNF, then we have 4NF, then we have 5NF. This is about atomic values. This is about partial dependency should not exist. So fully functionally dependency should be there. Then transitive dependencies should not be there. So this is partial should not be there. Then 4NF is about multi-value dependencies and 5NF is about joint dependencies. When the functional dependencies is implied by the candidate keys, we can say it belongs to BCNF, Boy's Code normal form. So A will be mapping to 4. So this is FT on candidate key. Then we have 4NF, if and only if every multi-valued dependency is implemented by the candidate keys. So here D will be mapping to 3. Then 5NF, if and only if every joint dependency is implied by the candidate keys. So generally they will say multi-valued should not be there. Joint dependency should not be there. But except for the candidate key, there should be no multi-valued dependency. Except for the candidate key, there should be no joint dependencies. This is what the statement says about 4NF and 5NF respectively. So they have given JD implied by the candidate key, MVD implied by the candidate key. Similarly, FD is implied by the candidate key. So option 2 will be the right answer. Next question. We will be having consecutive 5 questions based on these two relations. So we have two relations X and Y. In X we have 3 fields S, Si and C. In Y we have 3 fields S, P and D. From this we can say these two fields are same. Now we have a set of operations and their particular symbols. Cartesian product is represented like this. Join is represented through this symbol. Left outer joint is where the left side will have a symbol like this. Right outer join is where right side will have the symbol. When it is full outer join, that symbol is present in both the sides, and when it is semi-join, one side will be open. Only with the help of these symbols, we are going to work with the next 5 questions. The first question, find the number of tuples by applying the operation. The operation is given as X left join, where the condition is X dot S field is equal to Y dot S field in the Y relation. So this symbol is left join. So what is left join? In left join, operation allows keeping all tuple in the left relation. Everything will be present from X. If there is no matching tuple in the right relation, then the attributes of the right relation are filled with null values. Now the result of this left join will be like this. So I have J, B, R, T, 1, 2, 3, 4, M, N, H, E from X. Till here it is X. So these two are from Y relation. So we have J. So the corresponding S1 and CA are entered. Then we have B in both the relation. So P1 and AB are entered. Then we have R. So D1 and DC are given here. We have T in this particular relation and A here. So this tuple will not be taken into consideration. Instead, the equivalent values will be filled with null if there is no matching tuple. So what is the matching condition here? X dot S and Y dot S. This is Y dot S and this is X dot S. This is the matching condition. So J is equal to J, it is included. B is equal to B, it is included. R is equal to R is also included. Since we don't have any T, the attributes of the right relation of the joint result are filled with null values as specified here. So how many tuples are there by applying the operation? There are 4 tuples. Option number 3 will be the right answer. And tuples are nothing but the records. Next question. The result of X right join. This is the symbol of right join on the attribute X dot S is equal to Y dot S condition from the relation Y. So what is right join? Operation allows keeping all the tuple in the right relation. It means J, B, R, A will be present and T should not be present. So whichever options included T will be ruled out immediately. If there is no matching tuple found in the left relation, then the attributes of the left relation in the joint result are filled with null values. They have given none of these, so we have to check if option 2 is having the answer. So yes, JBRA is there. Then the corresponding P and D values are present in all the 4 records. And we have only J, B, R in X and Y together. So 1, 2, 3 M and H are filled. But since we don't have T record, the corresponding SI and C field value are filled with null. Whatever we did with left join, the same thing we are doing with right join, but in that case left side tuples are included and right side whichever is not available we are filling with null values. Here right side tuples are filled, S1, P1, D1, H1 is filled, CA, AB, DC, MD are filled, and whichever values don't have a matching left side are filled with null values. That is SI and C fields are having null values. So option 2 will be the right answer and none of these is also ruled out. Next question. Which of the following join is used to get all the tuples of relation X and Y with null values of corresponding missing values? So in left we had tuples only from the left side and the missing values from the right relation are filled with null values. In right outer join, we took the tuples from the right relation and whichever values missed in the left side are filled with null values. So the definition of left outer and right outer is not matching here. We have to check for the other 2 joins. What is a natural join? It can be performed if there is a common attribute between the relations. The name and type of the attribute must be same. See, even when you make left or right, they said X dot S is equal to Y dot S. In natural join also we can say this. So both these value belong to the same type as well as the name is also same in both the relation. So this is the common attribute they are talking in natural join. But here only when the condition is matching the tuples will be taken out in natural join. But here they are saying all the tuples should be taken out. So we know it is not left outer, not right outer and not natural 2. Obviously option 4 will be the right answer. In full outer join, all tuples from both the relation are included in the result irrespective of the matching condition. And of course the corresponding missing values will be filled with null values. Now let's see the result of full outer join. So we have included S, Si and C from X and S, P and D from Y. So J, B, R, T, A. All the tuples are taken. For T we don't have corresponding values in P and D. So we are filling it with null. So these are the missing values that are filled with null. At the same time for A record we don't have X related fields. So we are filling this with null. In fact, we are combining left as well as right joins together to bring this full outer join. Next question. Number of tuples by applying right outer join on relation X and Y are. Question number 5087. They have applied right join operation. So let me bring that result from the option. We have marked option 2 right in question number 5087. ID the last 4 digits I am saying. So this was the answer. Now how many tuples are there? 1, 2, 3, 4. Option number 4. 4 will be the right answer. So this is the result from question ID 5087, we marked option 2 for right outer join. So the symbol was x dot s is equal to y dot x on y. So they have directly given the result in that question and they are asking for the number of tuples in this question. Next question, number of tuples obtained by applying Cartesian product over x and y are. So what is a Cartesian product operation? It's an operation used to merge columns from two relations. Here the relations are x and y. It is also called cross product or cross joint. So I will give you the result of the Cartesian product here. In this result, till here it is x relation and from here it is y relation. So how we have got this Cartesian product is every tuple from x have to be merged with every tuple of y. So let's take the first tuple from x, j1m. So here the entry jbra is available from y. This is for the first tuple of x. Now the second tuple of x will have all these four tuples merged here. Then the third tuple of x will have 4 tuples from y merged like this. Then the fourth tuple of x will have 4 tuples from y merged like this. You have 4 tuples here, 4 here, 4 here and 4 here, which gives a count of 16. 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16. So how can we in general without seeing the result find the number of tuples is, you just count the number of tuples in x, it is 4 and number of tuples in y is also 4. So when you multiply these two, you will get a value of 16. So the number of tuples in x into the number of tuples in y will give you the number of tuples of the Cartesian product over x and y. So option number 1, 16 will be the right answer. With this, we are completing Unit 4 questions. Let's solve Unit 5 System Software and Operating System questions. The head of a moving head disk with 200 tracks numbered 0 to 199 has just finished a request at track 125 and currently serving a request at track 143. The queue of request is given in FIFO order as 86, 147, 91, 177, 94, 150, 102, 175 and 130. What will be the total number of head movements required to satisfy these requests for scan algorithm? What is scan algorithm? The disk arm starts at one end of the disk and moves towards the other end, servicing request as it reaches each cylinder until it gets to the other end of the disk. So it will start from one end and move towards the other end. At the other end, the direction of head movement is reversed and servicing continues. Here they have given a clue like it has just completed a request at track 125 and now it is serving a request at track 143. What does this mean? It says the disk arm is moving in this direction. So you have to start satisfying the request in this direction. That is why they have given it has completed 125 and it is currently serving 143. Now the queue of request is given. We will arrange it in ascending order 86, 91, 94, 102, 130. These are before 143 and after 143 we have 147, 150, 175 and 177 and the end is 199. Now currently the head is serving a request at 143. The movement is towards this direction. So after 143 it will move to 147. After 147 it will move to 150. After 150 it will move to 175. And after 175 it will move to 177. Regarding scan algorithm, it will reach the other end, which means from 177 it will travel to 199. So we have to count this movement also. From 199 we have to take the second point. The direction of head movement is reversed and servicing continues. So where is the first request in the reverse direction? It is in 130. So from 199 it will start serving 130. After 130 we have 102. After 102 we have 94, then 91, then 86. So let's calculate the difference. 147 minus 143 is 4. Difference between 150 and 147 is 3. Then 175 and 150 is 25. Then 177 and 175, the difference is 2. 199 minus 177, the difference is 22. 130 and 199, the difference is 69. 102 and 130, it is 28. 94 to 102, it is 8. Then the difference is 3 here. Then it is 5 here. Now we have to add up all these. So 25 and 5 will give 30. 28 and 2 will give 30. 22 and 8 will give 30. 4, 3 and 3 will give 10. Then we have 69 here. So altogether 30 plus 30 plus 30 plus 10, it is 100. 100 plus 69 is 169. So totally there are 169 head movements. Option number 2, 169 cylinders will be the right answer. Next question. Given as 4 GB, approximately 4.3 into 10 power 9 bytes of virtual space and typical page size of 4 KB, and each page table entry is 5 bytes. How many virtual pages would this imply? And what is the size of the whole page table? So there are two questions. We have to find the virtual pages count as well as the page table size. Now regarding the official answer key, this question is declared as dropped. It means no key is declared. So let's take the detail from the question. Virtual space is equal to 4 GB. Page size is equal to 4 KB. Each page table entry is equal to 5 bytes. You have to convert this into bytes. 4 GB virtual space can be written as 4 into 1 GB. So 1 GB is equal to 2 power 30. 2 power 10 is 1 KB. 2 power 20 is 1 MB and 2 power 30 is 1 GB. So 4 into 2 power 30, 4 can be written as 2 power 2 into 2 power 30, which will give altogether 2 power 32 bytes. This is the 4 GB space. And next the page size, that is also in the form of KB. 4 KB can be written as 4 into 1 KB. 1 KB is 2 power 10. So 2 power 2 into 2 power 10, this will give 2 power 12. This is also in the form of bytes now. Number of pages will be equivalent to virtual space divided by the page size. We can just use 2 power 32 divided by 2 power 12, which makes 2 power 32 minus 12, which is equal to 2 power 20. So number of pages will be 2 power 20. So total page table size is equal to the number of pages into the bytes per each page table entry. So number of pages, it is 2 power 20 bytes into what is each page table entry? It is 5 bytes. So 2 power 20 into 5. The number of pages is 2 power 20. 2 power 20 can be written as 2 power 10 into 2 power 10, which is equal to 2 power 10 is actually 1 KB, which means it is 1024 bytes. So for this 2 power 10, I am writing 1024 into, for this 2 power 10, I am writing 1024. 1024 into 1024 will give 1048576 bytes. Then we will calculate for the page table size 2 power 20 into 5. So 2 power 20 we have 1048576 into 5. This will give a value of 5242880. This is approximately 5 MB actually, because here the 5 can be kept like this and 2 power 20 is actually 1 MB. So 5 into 1 MB is 5 MB. Now this is how we do the normal calculation, but there is an alternate way to do this using the details given in the question. So they have given virtual space 4 GB is equal to 4.3 into 10 power 9 bytes. So we have seen in 2 power form here. Now we will see in 10 power form here as given in the question. This is how you have to calculate the calculation for this question. So now the page size is given as 4 KB. So what is 1 KB is equal to, we have 10 to the power 3, 1 MB is equal to 10 to the power 6, 1 GB is equal to 10 to the power 9. This is why they have mentioned this to be 10 to the power 9 in 4 GB. 4 KB can be written as 4 into 10 to the power 3 bytes. So now how will you calculate the number of pages? The number of pages will be equal to the virtual space divided by the page size. This will be 4.3 into 10 to the power 9 divided by 4 into 10 to the power 3. So 4.3 divided by 4 will give you 1.075 into, when I take 10 to the power 3 to the numerator, it will be 10 to the power 9 minus 3, which is equal to 1.075 into 10 to the power 6. 10 to the power 6 means you will have 1 and 6 zeros together. This will be 1075. So 3 zeros will go for this decimal point, and additionally there will be 3 zeros. So this will be the answer. Actually 1075, and there should be 000 and not 00. This is the problem with the first option. As per this question, number of virtual pages will be 1075 and 000. Then regarding page table size, so we have the number of pages into each page table entry. The number of pages you can keep it as 1.075 into 10 to the power 6. Then the entry will be 5 bytes as per the question. Let's take this to be 5 only, because 5 point something it will give. 10 to the power 6 is actually 1 MB. So this will be approximately equivalent to 5 MB. For this question, you have to use this method because they have explicitly given in 10 parts. But usually we will solve the problem in this method using 2 parts. Sometimes they will stop the answer in the options with 2 parts or 10 parts. At that time you need not go with the complete number. But if they ask you in terms of bytes with a complete number, you have to calculate this way and bring it to this form. Since there is no key, I'll just mark the answer alone here. So page table size will be approximately equivalent to 5 MB. So this will be the answer to the question. If you multiply 5 into 1.075, you will get 5.375 into 10 to the power 6. So this will be like 5375000. Next question. In Linux, where is the user password stored? A simple example of signature-based detection is scanning network packets for the string in the path etc password targeted for a unique system. So usually signature-based detection is what they mean as password in Linux context. So for a Unix system, they usually store in etc password, spelled as PASSWD. This is the actual place where the user password is stored. So option number 3 will be the right answer. Next question. The average time required to search a storage location in memory and obtain its contents. So there are two processes here. One is to search the storage location in the memory, and the other is to obtain its contents. So there are 4 times given here. Reading time doesn't apply to the context of OS or computer system architecture. So we can easily rule out option number 4. And regarding this question, some will place it in unit 2 and I have placed it in unit 5. It is because of the relevancy of the options. Access time is the interval between the beginning of one storage device access and the beginning of the subsequent access. Subsequent means another access. So when will you go for the next access? Only when you have completed the access to the first item, you will go to the access of the second item. So this denotes the complete process of searching and obtaining the content. So access time is equal to latency plus transfer time. So what is latency? The cost of traveling to the appropriate location on the device and making preparations to access it. So this part. and obtaining its contents is transferring it to the place where you want to use it. So this is the transfer time. From this we can say the average time to search as well as to obtain content will be option number 1, access time. One half of the statement, searching the location will apply to latency time, and the next half is not there, so we are ruling out option number 2. And response time is not about searching something. Response time is the time from the submission of a request until the first response is produced. It is the time it takes to start responding, not the time it takes to output the response. This is not relevant to the statement given in the question, so we are ruling out even response time. Next question, which of the following statements are not correct about NUMA? So this question can also be placed in computer system architecture. So let's see about NUMA. Multiprocessing can cause a system to change its memory access model from uniform memory access UMA to non-uniform memory access called NUMA. So this is what we are calling it as NUMA. So NUMA machines have 3 characteristics. There is a single address space visible to all CPUs. Access to remote memory is via load and store instructions. Access to remote memory is slower than access to local memory. So take this to be a local memory for node 0 and this is a remote memory for node 0 alone. So access to the local memory will be fast. But when I have to access the memory of node 1, which is a remote memory for node 0, it will obviously take more time for it. So that's why they say access to remote memory is slower. When I want to access a memory that is not local to my machine, it will definitely be slower than accessing the memory of my machine. So from this, load and store instructions are used to access remote memory. From point 2, we can say A is true. So they are asking about not correct. Coming to B, there is a single address space visible to all CPU. This is also right. So A and B are true. Any option that includes A and B will be ruled out. So 3 options are ruled out. From this we can mark option 4 will be the right answer, which means both are wrong statements. So now the C statement. Access to local memory is slower than access to remote memory, which is contradicting this statement. So as per point number 3, it is faster than access to remote memory. So this is wrong. We can mark C to be false. Next D. When the access time to remote memory is hidden, the system is called NC NUMA. Let's see the relevant statements. When the access time to remote memory is not hidden because there is no caching, the system is called NC NUMA, that is non-cache coherent NUMA. So since there is no caching, they say when the access time is not hidden. But here the statement is they have given as is hidden. So whenever it is not hidden, we call it as NC NUMA. So D is false. The actual statement should be not hidden. So we are marking it wrong. In CC NUMA, cache coherence are present as per E statement. When the caches are coherent, the system is called CC NUMA, that is cache coherent NUMA. So NC is non-cache coherent, CC is cache coherent. E statement is true. So A, B, E are true, C and D are false. As per this question, option number 4 will be the right answer. Next question, indexed or grouped allocation is useful as. Indexed allocation supports direct access without suffering from external fragmentation because any free block on the disk can satisfy a request for more space, so it does suffer from wasted space. But it does not suffer from external fragmentation. I'll let you know what it is later. With indexed allocation, an entire index block must be allocated even if only 1 or 2 pointers will be non-null. If the index block is already in memory, then the access can be made directly. However, keeping the index block in memory requires considerable space. If this memory space is not available, then we may have to read the first index block and then the decide data block. So in continuous allocation, what happens is we continuously allocate the files. So it starts from 0 index and the length is 2. So 0 and 1 is for count file. Then if you take F file, it starts from 6 and the length is 2. So only 6 and 7 will be allocated for F. We have indexed allocation here. In indexed allocation, what happens is there is a file called Jeep and they say it starts in index block 19. So it starts here. Now in the index part, they will mention where are the other parts of the file present. So the other parts are index 9, index 16, index 1, index 10, index 25 and the remaining will be kept as null. So that is -1. So here if you take 9 is there, then you have 16, then you have 1, then you have 10. This is how index allocation will be there. So if the index block is already in memory, then the access can be made directly, and keeping the index block in memory will require considerable space. See, the starting index is alone given here. The index block 19 has all the details of the file. But here the starting index and the length of the file is given in this directory. But here only the index block number is given. If you get into the index block, the related index will be present here. So you need space to store this as well as this. That's what they say. It requires considerable space. Some systems combine continuous allocation with indexed allocation by using contiguous allocation for small files up to 3 or 4 blocks and automatically switching to an indexed allocation if the file grows large. So some system combine both these strategy. How do they do? When it is a small file, they go for contiguous allocation, and when it is for a large file, they automatically switch to indexed allocation. This is how it happens. So now let me tell you what is external fragmentation. External fragmentation exists when there is enough total memory space to satisfy a request, but the available spaces are not continuous. So the storage is fragmented into large number of small holes. So regarding index, there is no problem of external fragmentation because it is going to store only the index locations in the index block. Here they say external fragmentation is the storage will be fragmented into large number of small holes. Though there are spaces, the spaces will not be continuous. Say for example 8, 9, 10, 11 is available, then 17, 18 is available. So 6 spaces are available here. But when you want to store a file called A with length 6, where will you allocate here? Because at a stretch you have only 4. So what it will do is, it will store here for 2 and here for 4. So this 2 and 4 will make up together a length of 6. So this is external fragmentation, and in indexed allocation, we don't have the problem of external fragmentation because it is going to store only the index in the index block. So now we will see the options. It supports both sequential and direct access. Yes, it can access sequentially as well as it can access directly if the index block is already available in the memory. So both are possible. Option A is fine. Entire block is available for data. Yes, it is available. With index allocation, an entire block must be allocated here. So this is also fine. It does not require lots of space for keeping pointers. It requires space for pointers. This part has to be stored. Only then we can collectively know where the file contents are present. So in that case, it requires considerable space. So when they say it does not require, it is actually wrong. It actually requires lots of space is the right statement. Then there is no external fragmentation. This is true with regard to indexed allocation. They say it is not suffering from external fragmentation. So external fragmentation is when you don't have continuous storage, you have to fragment the path. So that will not happen in case of indexed allocation. So D is also right. Option A, B and D are correct. So here the question is, this allocation is useful as it supports both the access, as the entire block is available for data, as there is no external fragmentation. So everything is going to be a reason except C. Option number 4, A, B and D only will be the right answer. Next question. Which of the following statements are correct? Each process has a segment of code called a critical section, in which the process may be changing common variables, updating a table, writing a file, and so on. So every process has to request permission to enter the critical section. A process always checks state of currently executing process to enter critical schema. They say it must request permission to enter critical section, but here the story is about checking state. That too, it will always check state, which is actually contradicting the statement. So A will not be right. A mutex lock has a boolean variable available whose value indicates if the lock is available or not. Since it's a boolean variable, it should either be 0 or 1. The main disadvantage is that it requires busy waiting. This type of mutex lock is also called spin lock because the process spins while waiting for the lock to become available. So spin locks uses busy waiting is perfectly true. B is true. But we know A is not true, so 1 will be ruled out here. What is busy waiting? A process or a task waits and constantly checks for a condition to be satisfied before proceeding with its execution. Periodically testing a variable until some value appears is known as busy waiting. They say it constantly checks for a condition. Periodically means after some period of time it is checking. So C is also wrong in case of busy waiting. Constant means it continuously keeps on checking. It always checks. So in that case they say then critical region is a part of program where shared memory is kept. So what is the critical section? It may be changing common variables, updating a table, writing a file and so on. So when shared memory is kept, only then it has to ask permission to update or ask permission to change some variable value or ask permission to write a file. So if that memory is not shared, it will automatically update itself. Only when there is shared memory, it has to seek permission. So in that case, critical region is a part of program where shared memory is kept is perfectly true. So since C is also wrong, we can rule out option 2, and since D is right, we can go with option number 3, B and D only. Option 3 will be the right answer. So from this we can conclude E is definitely false. But why it is false? The printer daemon periodically checks to see if there are any files to be printed. But what has been given in E statement? The printer daemon continuously checks to see if there are any file to be printed. This is not the case for printer daemon. So this is continuous testing and this is periodical checking. So the words are exchanged in C and E, that's why they are wrong. So in this case we can mark option 4 also to be wrong. Next question, match list 1 with list 2. So we know least recently used. LRU is a page replacement algorithm. Least recently used means it has not been used recently. So a page that has not been referenced for longest time is replaced. This will be perfectly apt for LRU. Which option has A mapping to 2? The only option will be option number 2. Now what is B? Demand cleaning. Demand cleaning means a page is written to the secondary memory only when it has been selected for replacement. So B will be mapping to 1. What is long-term scheduling and what is medium-term scheduling? The decision to add to the pool of processes to be executed is given in 4. The decision to add to the number of processes that are partially or fully in main memory is given in 3. Regarding the words, medium is something that is going to happen in a short time. Long term is it will take a long time to happen. A process is partially or fully in memory and the decision to add to the number of processes can be medium term scheduling. So in that way, D is mapping to 3. And when it comes to long term scheduling, the decision to add to the pool of processes to be executed. You have a set of processes to be executed stating P1 and P2. And already some processes are in memory stating P3 and P4. So these are already in execution. These are waiting to get into execution. So here adding to the pool of resources, if I have a process P5, adding here will be long term because I have to get the memory, then I have to go for execution is this part. But adding to the number of processes is adding in this part that are partially or fully in the main memory. It means it is executing. So adding to this should be medium term scheduling. When I am adding something to what is already in the main memory, it is going to be executed very soon. When I am going to add something to the pool of resources, it has to get the chance to execute. So here the wait is long and here the wait is short. So C will be mapping to 4. So from this we can say option 2 will be the right answer. Next question. Arrange the following levels of interrupt protection within the Linux kernel in the order of increasing priority. So let's see a diagram. It's about the interrupt protection levels and the increasing priority is from bottom to top. So which is having the least priority user mode program. They are preemptible. Preempting is allowing another one to execute when something is getting executed. Non-preempting means until the process that is executing is going to be completed, it will never allow others to interfere. So user mode programs take the least priority. Next, kernel system service routines take the next priority. So here user mode programs A will be first, then we have kernel system service routines C, they are also preemptible. Then we have bottom of interrupt handlers B, then we have top of interrupt handlers D. A, C, B, D. Option number 2 will be the right answer. So when you find this is A as the starting one, you can rule out 4. When you find it is A and C, you can rule out 1. When you find it is A, C and B, you can rule out even 3. Next question. Given below are two statements. A thread is a dispatchable unit of work that does not execute sequentially and is non-interruptible. This word is more than enough to say that this statement is wrong. If you take a particular process, it will create many threads. Take a process like this. There are 3 threads. Let me mark it like this. When this is executing and when there is a need, this thread will get executed. It does not mean it won't be interrupted. We cannot say like that. So when you find that it is non-interruptible, you can easily say this statement is false. Now we'll see the exact statement. Thread is a dispatchable unit of work that executes sequentially. So this word is also wrong and is interruptible, and this is also wrong. Next statement. It is not possible to alter the behavior of a thread by altering its context when thread is suspended. The set of register values and other volatile data that defines the execution state of a thread, they make the thread context. Here they say it is not possible to alter the behavior by altering the context. The context is having some register values and the execution state of a thread. A thread can be prevented from executing for an indefinite period of time if it becomes suspended. Suspending the running thread will cause a context switch to another thread in ready state immediately. If one thread is suspended, the running thread is suspended means automatically there will be a context switch to another thread which is waiting in the ready state. So this will happen immediately once a thread becomes suspended. The suspended thread is not executed until explicitly resumed with the appropriate function. So here they say suspended thread will never execute, but it will cause a context switch to another thread. Switching the CPU from one thread to another involves suspending the current thread, saving its state, and then restoring the state of the thread being switched to. There are 3 things happening. One is the current thread will be suspended. The current thread's state will be saved in the appropriate registers, and then it will restore the state of the thread that it is being switched to. When there is an option to save the state, definitely there will be an option to restore the state later. They say the suspended thread can be explicitly resumed. At that time, it can restore the state. You can restore the state of a thread only when you save that particular state. So there is an option to alter the context when the thread is suspended. So we can save the state, which means it can alter the behavior of the thread. So take T1 and T2. T1 is suspended and it has a safe state, and T2 is now executing or running. In this case, it is possible to alter the behavior of the thread by altering its context when the thread is suspended. The behavior of T2 thread, ready to execute. So this is also changing the context. Altering means changing the context. So when they say it is not possible, this is definitely false. It is possible to do that. Since both the statements are wrong, option number 2, both statement 1 and statement 2 are incorrect, will be the right answer. With this, we are completing Unit 5 questions. Let's solve Unit 6 Software Engineering questions. Test suite consists of. In software development, a test suite is a collection of test cases that are intended to be used to test a software program to show that it has some specified set of behaviors. The suite is about the set of test cases. Option number 3 will be the right answer. Boundary cases are like boundary conditions and defect cases are like faulty conditions, and set of nest cases is not relevant here. In order to test a software program to show that it behaves in certain way, they develop many test cases. So that test cases together, the collection is called as test suite. Next question, level 0 DFD is also called as. The first data flow model, sometimes called as a level 0 DFD or context diagram, represents the system as a whole. So what does level 0 DFD mean? It's a context diagram. Option 3 will be the right answer. Subsequent data flow diagrams, there are level 1 and level 2. They refine the context diagram, providing increasing detail with each subsequent level. So let's also learn about the other 3 options here. A use case captures the interaction that occur between the producers and consumers of information and the system itself. So they used to say actors and use cases. So what does a particular entity or a particular system or a particular person is going to do? What are the functions associated with that actor will be taken. You will have matchstick called as actors, and there will be use cases. What are the activities that this actor will do will be given in the use cases. Sequence diagram indicates how events cause transitions from object to object. Even in some of the PYQs we have seen, here some object will be there, here one object will be there. From here there will be some interactions, and from here there will be some interactions. So they will be giving in this lane. So the interaction will occur from this object to that object. We have also solved certain problems in sequence diagram. Prototype is a model of the system. It serves as the first system. So it's a model of the system that we want. Level 0 DFD is associated with context diagram where the system is represented as a whole. Next question, the selection of spiral model based on characteristics of requirements. So let's see about the spiral model. So we start with communication, then we go for planning, modeling, construction and deployment. There is also another spiral model that is given in the old edition of the same software engineering book written by Roger Pressman. The spiral model is an evolutionary software process that couples the iterative nature of prototyping with controlled and systematic aspects of waterfall model. So here we have 4 steps. Determine objectives and identify alternate solution, identify and resolve risks, develop next level of product, review and plan for the next phase. This goes on in an iterative way. That's what they say, iterative nature. What requirements makes us to select that this project will need or this product will need a spiral model? So we can get into this diagram to evaluate these statements. Are requirements easily understandable and defined? So here we are determining the objectives and identifying the alternative solution, and here it is not about the understanding or the definition of requirements. So A is not relevant to this particular diagram. Next, do we change requirements quite often? When we have changing requirements, definitely we'll need a spiral model because it comes to the same stage again and again. It happens in an iterative way. So in that way, B can be included as a requirement part. Then, can we define requirements early in the cycle? Not so, because here it is in an iterative approach. We need not define requirements completely together. Once we review and plan for the next phase, again we have to go for identifying the alternate solutions for certain problems, or we'll determine the objectives for the next phase. So requirements keep changing and requirements will be needed for every phase. In that case, we cannot define everything early in the cycle. So that's why we are ruling out this. Requirements are indicating a complex system to be built. Yes. When you go phase by phase, first you will develop one part, then you will go for a review and then plan for the next phase, which says that the system is getting complicated. So here the requirements are indicating a complex system to be built is also right. So we'll go for a spiral model when the requirements keep changing for different phases of the same project. At the same time, as the requirements keep increasing or keep changing, we can understand that a complex system has to be built. Taking B and D into consideration, option number 3, B and D only will be the right answer. It provides the potential for rapid development of increasingly more complete versions of the software. The spiral model is a realistic approach to the development of large-scale systems and software. So this is the clue to indicating a complex one to be built. Because software evolves as the process progresses, the developer and customer better understand and react to risks at each evolutionary level. Evolutionary in the sense, each iteration. A prominent feature of the spiral model is handling unforeseen risks that can show up much after the project has started. That's why it is in the spiral form. As for phase 1, I can identify the risk and give some solution and solve it. So when I get into phase 2, I might get some risks from phase 1. So I have to solve 1 and 2 together in my second phase. This is what they say. It can handle unforeseen risks that show up much after the project has started. So this model is good at handling such risks. So that's why when the requirements keep changing, we may require this model. At the same time, it is suitable for developing large-scale systems and softwares. Next question, the steps for analysis and design of object-oriented system. First, let's look at all the diagrams together. Usually, we start with the user's view, which is at the center of the diagram here. So we have 4 kinds of views apart from the user's view, and whatever diagrams that are coming under those views are listed. So have a note of it. Now we'll get into solving the question. Use case diagram help you determine the functionality and features of the software from user's perspective. So when you solve, you start with the use case. Next, an activity diagram depicts the dynamic behavior of a system or a part of a system through the flow of control between actions that the system performs. So when I have use cases, definitely there will be an activity being followed because this will depict the dynamic behavior of the system. So imagine activity diagram as a flow chart. In plain terms, I can say. So that says the flow of control between actions. So it is similar to a flow chart. When I say there is a use case called login, then we go for an activity diagram which says I have to give my username, give my password. If it matches with the database, I will be let into the system. If it doesn't match, if either the username or the password is wrong, then I will be thrown out of the system stating it is invalid. So definitely after use case you have activity. So they have combined this together in option C. Option C comes first. The only option that has C first is option number 4. So option number 4 will be the right answer. The rest of the options can be ruled out. Each interaction diagram realizes the behavior of a single use case. So after you have a use case, you go for interaction diagrams. So there are two kinds of interaction diagrams. One is the sequence diagram, that is used to show the dynamic communication between objects during execution of a task. The other kind of interaction diagram is collaboration diagram, which shows both the structural as well as behavioral aspects explicitly. So next to use case we have interaction. So let me make it as use case and activity together, and from there we go for interaction, and this will be option A. So usually you will have a use case like this and take this to be an actor, has three functions to be done. So F1, F2 and F3. So regarding F1, there will be an interaction diagram. It can be a sequence or a collaboration diagram to show the dynamic communication between objects. So what are all the things involved in F1 will be described. So this is how the next order comes. Let's continue. A class diagram shows how a system is structured rather than how it behaves. So behavior is over with interaction diagram. Now we are getting into the static part. A class diagram models the static structure of a system. It comprises a large number of class diagrams and their dependencies. Dependencies in the sense how they are associated or how they are related to each other. So in this case we can mark class diagram as the next one. So E comes next. From class I will be able to get object. So with the clue here in B, we'll move on further. An object diagram models a group of objects and their links at a point of time, showing the instances of the things in a class diagram. So after I draw a class diagram, from the class diagram I will be able to make object diagrams. So objects are nothing but instance of a single class. Next, a state chart diagram is normally used to model how the state of an object changes in its lifetime. So if you want a state chart diagram to be drawn, definitely you will need an object diagram from the class diagram. So from E we are moving to B. A component diagram can be used to represent the physical structure of an implementation in terms of various components of the system. So if you get to see some books, they will tell you what are the components. It can be an interface, it can be a particular module. So component comes in with option D. The deployment diagram shows the environmental view of a system, how it is getting deployed in some environment. So use case can be taken as analysis. What you need from the system is what we analyze. Regarding design, it starts with the static structure of the system. You are modeling a class diagram, you are modeling an object diagram, state chart diagram, component diagram and a deployment diagram. I have given you how these two are related, how class and object are related. Why does state chart come with object? Because it needs to tell you how the state of an object changes. For that you need to know what are the objects involved in the system. So obviously you will need an object diagram. That's why they have grouped it together like this. Next question. The prototyping model has the sequence. So let's take this prototyping model. This is taken from an older edition of the same software engineering book. First we have requirements gathering. From that we enter a cycle here. In this cycle we have quick design, building prototype, customer evaluation of that particular prototype, and we refine requirements using the customer suggestions, and then we go on designing again and again. So when the customer accepted it, we go for a general design, general implementation, general testing and maintenance of the particular project. So they say the prototype development will be till here, and after that this goes as iterative development, because we keep on refining things after being accepted by the customer. So the customer acceptance is only in the prototype development stage and not in the iterative development stage. But let's just map. We have customer evaluation here. We have quick design here. Then C requirements is here. We have implement here and design here. Let me order this. Requirements is C, quick design is B, customer evaluation is A, design is E and implement is D. This is my order from the diagram. C, B, A, E and D. But there is no option similar to this sequence. But how people have interpreted this answer? They are fine with requirements. After requirements, they go with quick design, they are fine. After quick design, they get into implement stage. They say this implement is nothing but building the prototype. And so they bring D here. After D, they go with customer evaluation, which is A, and then they end up with design called E after the customer has accepted. So this question has been given option 3 as the right answer. CBDAE. This is what they have given. But regarding the diagram from which this question is taken, this is the correct sequence. If this implement is going to be building prototype, then why is an implement phase given here is my question. The next question. Given below are two statements. In reuse oriented model, modification of old system parts appropriate to the new requirements. The second statement, integration of the modified parts are not possible into the new system. So let's learn about reuse oriented development model. So reuse oriented development is based on systematic reuse where systems are integrated from existing components. So the name itself will tell you we are reusing it from existing things. They look for designs or code that are similar to what is required. They just modify them to their requirement and incorporate them into their system to identify components of old system that are most suitable for reuse. So I am going to identify the components that are needed. To understand all system components, I have to understand them. I have to modify old system components to achieve new requirements. So since I am going to reuse, I have to modify accordingly to the current project that I am working. And then to integrate all of the modified parts into the new system. So integration is a part of reuse oriented model, and the second statement is telling it is not possible to integrate, which is absolutely false. And in the first statement, modification of old system appropriate to the new requirements is what this point states. Old system components are modified to achieve new requirements. So this statement is true. From this we can mark option number 3. Statement 1 is correct, but statement 2 is incorrect as the right answer. With this we are completing unit 6 questions. Let's solve unit 7 data structures and algorithms questions. Which of the following is not a palindromic subsequence of the string AB, ABC, DA, BBA? So there is a difference between substring and subsequence. Substring means a part of the string from the long string. That substring will be continuous. The sequence of character will be the same. ABA is a substring. Then I can say DAB is a substring. ABBA is a substring. But subsequence means they are also part of the original string, but their order will not be continuous. Say for example, AB from here and ABBA from here can be a subsequence. You may not have the continuous order like substring. So that is the difference between substring and subsequence. A string is said to be palindrome if the reverse of the string is same as the actual string. This long string is not a palindrome. A subsequence is a sequence that maintains the same relative order, but it may not be contiguous. A naive approach to this problem has exponential time complexity. Actually, we have a problem. Find the longest subsequence from the string. Find as many as possible subsequences from the string as programming questions. A much better solution is to use dynamic programming. So what is dynamic programming? It's an optimization technique where complex programs are broken down into subproblems with each subproblem solved only once. This is the reason why I have placed this question in data structures. Now let's solve the question. So a string is given here. They are asking which is not a palindromic subsequence. So we can just see the options and find it. So let's take A, B, C, B, A. So write it in reverse, A, B, C, B, A. So is this a palindrome? Yes, it's a palindrome. Next, A, B, B, A. Write it in reverse, A, B, B, A. Yes, it's a palindrome. Then we have A, double B, A, and writing it in reverse also we have the same thing. So this is also a palindrome. If you take A, D, B, A, just write the reverse A, B, T, A. So this is A, D, B, A and this is A, B, D, A, which says that this is not a palindrome. Now you can also check. Can you find A, B, C, D, A? Yes, I can find A, B, C here and B, A here. Then A, B, B, A. So A, B and B, A. Then A, double B, A. Yes, this is A, B. Then from here I can have B. Then together I can have B, B, A. It is possible. A, D, B, A. I can take A here, D here and then BA from here. It may not be contiguous, so I can pick up all the subsequences. But the question is to find which is not a palindromic subsequence. So you need not go and think whether this is a subsequence or not. Just analyze the options and say option number 4. ADBA is not a palindromic subsequence. Next question. Which of the following is true? So the cost of searching AVL tree is given in all the statements and they are comparing it with searching a binary tree. So let's see the relevant statements. The cost of searching an AVL tree is log n, but that of a binary search tree is big O of n if the binary search tree is unbalanced. If the binary search tree is balanced, the cost of searching will be log n here. AVL trees are always balanced so that the cost of searching is guaranteed to be logarithmic. Every complete binary tree is balanced. So when they say complete binary tree, it's about the balanced trees. Now the cost of searching AVL tree is log n. So we have log n here, we have log n here, but not in these two places. So we'll rule out 3 and 4. The binary search is given as big O of n. This is correct. Then complete binary tree. So complete binary tree is balanced. In case if it is a balanced tree, the cost will be log n again. But here it is n log n, which is wrong. This should be only log n and not n log n because it's a complete binary tree. So every complete binary tree is balanced and every balanced tree has a cost of searching log n. So in that case, 2 is also wrong. Option number 1 will be the right answer. So understand, AVL trees search cost will be log n. Binary search tree for unbalanced case will be big O of n. The cost of searching a binary tree is given as log n. Actually only in case of balanced we can say that it is log n. And similarly this is actually correct only, but this is wrong and this is wrong here. So they say AVL trees are always balanced. What about the binary tree that is balanced? It has big O of log n again. And they say AVL trees are always balanced, which says that it has log n complexity. And every complete binary tree is balanced means here we can also say complete binary tree will have O of log n complexity. Next question. What is the result of evaluating the postfix expression? They have given as drop question. It means no key is declared. Why is no key declared? Because during evaluation I cannot evaluate B. So what will we do in postfix expression? We will read the expression from left to right, initialize a stack with the same length as the expression. So let's initialize the stack here. If the element encountered is an operand, push into the stack. So first we have 4, then we have 3, we are pushing it into the stack. If the element encountered is an operator, pop 2 operands A and B from the stack, apply the operator and push the result back into the stack. So we have to pop A and B and we have to apply the operator as B operator A. So this is A and this is B. First we have to pop A and then B, and the operation will be B operator A. 4, the operator is into and A operand is 3, which is equal to 12. After calculating, I have to push the result back into the stack. So let me have 12 here. Now we have an operand 2. So I am pushing it here. Then I have an operand 5. I am pushing it here. Now I have an operation multiplication. So now what we have to do? We have to pop A and B and then apply the operation as B operator A. So here it is 2 into 5, which is equal to 10. Now I have to push the result back into the stack. So we will have 12 here and 10 here. Now we have an operator called plus. So if it is an operator, I have to pop A and B and apply B operator A. So 12 plus 10. This will give a value of 22, and now we will push the result back into the stack. After 22, we have an operand called B. So let's take it to be B. Now we have an operator called subtraction. So this is A and this is B. So it is 22 minus B. Since we cannot evaluate B, this question has been dropped and no key has been given for this. We will just write the expression as 4 into 3 plus 2 into 5 minus B. This is the actual expression that we have got from the postfix expression. In case if the number is going to be 6, 22 minus 6 means the answer will be 16. 22 minus 8 means the answer will be 14. So we don't know what number has to be in the place of B. So this is how we will be solving the evaluation of a postfix expression. Next question. Which data structure is typically used to implement hash table? So whenever we answer hash table questions, we go with drawing an array, fixing an index and placing the elements appropriately in the slots. A hash table is a data structure that stores some information, and information has basically two main components. One is the key, usually called as the slot number or the index value, and the other one is the value that is being inserted in the particular slot. So let's see the diagrams of all these four data structures. First one is linked list. Linked list will be in this format. We will have a data node and the pointer to the next node. Then the head will be pointing to the first node and null will be in the last node place. So can you store a hash table like this? You cannot. Next one is array. This is how we will be storing a hash table, and in fact we will put it in vertical form as 0, 1, 2, 3 and 4. This is how we will solve hash function problems. This is the binary tree representation. We will not be able to implement hash table using this, and this is how we will use stack. Just the previous question we used stack. So in stack there are only two operations. You can push and pop. But regarding hash functions, you have to put the element in a particular key or in a particular slot. But that is not possible with the help of stack. So obviously hash table is implemented using arrays. And what kind of arrays? Associative arrays. Why do they say associative arrays? Is you have named slots or indexed slots. So option number 2 will be the right answer. Next question. Which collision resolution technique involves maintaining a linked list of collided keys? Collision is a condition where two records are stored in the same location. The process of finding an alternate location is called collision resolution, and the options are those resolution techniques. Under dynamic chaining, we have an array of linked list application. We have separate chaining to be the technique here. This is how it happens. Sometimes if there is an element already stored here and another element is also being hashed to the same index slot, then what we will do is we will create a linked list and place the element here. So how many ever elements are going to get the same index, they will be just placed similar way. And the last element will have null. So this is how we have chaining. Now just read the question. Which technique involves maintaining a linked list of collided keys? This is actually the linked list. And the method that used linked list is direct chaining. So here the term chaining is direct chaining or separate chaining. Option number 3 will be the right answer. Then what are the other 3 options? They come under open addressing technique. In chaining we have linked list, but here it's just array based implementation. They are not going to use any linked list and all. Inside the same array, they are going to use other technique for placing the elements. So first we have linear probing. It is linear search. So in case if you have an element mapping to the same location, it will be placed in the next location. Then we have quadratic probing, where it is called non-linear search. And we have double hashing. Here we use 2 hash functions to find a particular slot. Next question. Consider the following functions. They have given 3 functions, f of n, g of n and h of n. Which of the following is true? First we will understand about this asymptotic function. F of n is equal to big O of g of n. This means f of n is asymptotically less than or equal to g of n. We can equate this particular equation as f of n less than or equal to g of n. So this is taken from one of the data structures reference book. Here they have given decreasing rate of growth. It means the least complexity is given in the bottom, big O of 1. And the highest complexity is given in the top, that is big O of 2 power n. Now we have to equate these functions to any of these complexities. F of n is equal to 3 into n to the power of 1 value. When you consider the complexity related problems, we will always go with the upper bound in case of big O. We will only consider this part here. Regarding g of n, as per this question here, it is 2 power root of n into log n to the base 2. So this is similar to n power something and this is 2 power something. From this rate of growth, it is difficult for us to conclude which is greater. So we will see another growth rate which is in the increasing order. N power k is actually a polynomial time solvable problem, and a power n, that is the exponential time solvable problem. It is given in increasing rate of growth. So this comes as the highest. So comparing f of n and g of n, we have f of n is less than or equal to g of n, because this is in exponential format and this is in polynomial format from this particular growth rate. H of n is equal to n factorial. If you see here, 2 power n is something where we can say it's exponential, and n square is something where we can say it is a polynomial part. I am plainly telling you, I am not getting into the detail as of now. So if this is going to be f of n and this is going to be g of n, for example, then h of n can be placed here. From this, what you can understand is h of n takes the highest complexity, followed by g of n and then followed by f of n. If h of n is big O of f of n, how can we write this as h of n equal to big O of f of n. When we say big O of something, it means it is less than or equal to. So this can be taken as h of n is less than or equal to f of n. And the next option, h of n is equal to big O of g of n. Now what is this? H of n is less than or equal to g of n. Then third one, g of n is not equal to big O of f of n. It means g of n and f of n are here. We have the less than or equal to because of the big O notation, and when they say not, it is not. So let's consider an example for this. If I say 8 and 9 here, I can place a symbol like less than or equal to. If it is 9, I can again place less than or equal to 9. So both these expressions are true because you either have less than 9 or equal to 9 in the left hand side when we compare it with the right hand side 9. In case if I place a value called 10 and the same inequality holds here, we say it is not. In this case, we can say that g of n is greater than f of n. When it is 8 less than or equal to 9 and 9 less than or equal to 9, when I say we have 10 in the left hand side, this becomes 10 greater than 9. When we have not of less than or equal to, this will be equating to greater than symbol. So if I say not less than or equal to f of n, it means it is greater than f of n. So this is the exact meaning that we can infer here. Now the fourth one can be taken as f of n is equal to big O of g of n. And here f of n is less than or equal to g of n. Now we will check every option. Is h of n less than or equal to f of n as per this order? No. So option 1 is wrong. Next, h of n less than or equal to g of n? Again wrong. H of n has the highest complexity as of these functions given in this question. Now the third one, is g of n greater than f of n? Yes, it is greater than. And is f of n less than or equal to g of n? Yes, it is true again. Both these options are turning out to be true. Now I will tell you about a printing mistake in this question paper that has happened. G of n is equal to 2 power root n into log n to the base 2 is the actual function of g of n. F of n is right and h of n is right. This is the actual function of g of n. And the options given below are for this particular function. You can ask me, how can I be so sure that this is g of n? It has been a repeated question in GATE exams. Now we will interpret every function. So let's take f of n is equal to 3 into n to the power of root n. Now we will take g of n. This is equal to 2 power root n log n to the base 2. I hope we can remember a formula. Log x to the power y is equal to y log x. Now this is in the form of y log x. Root n log n. Now we have to convert this as x to the power of y, which means log n to the power of root n. Now g of n will be 2 power log to the base 2 and n to the power of root n. We again have a formula. A log x to the base b is equal to x log a to the base b. So just equate this. 2 log 2 and x is n to the power of root n, which is equal to, now we will change this as n to the power of root n, the x value. So here x is equal to n power root n. N power root n into log a is 2 and the base is 2. What is log 2 to the base 2? It is 1. Log 2 to the base 2 is equal to 1. How did we get 1? So whenever we have such functions, we will equate this to some value called z. So 2 power z is equal to 2. So I will place small z. 2 power 1 is equal to 2. From this z is equal to 1. So this is how we arrived at log 2 to the base 2 is equal to 1. Any number to the same base will give you 1 only. This is just a small explanation. So this will ultimately give n power root n into 1. So what is g of n here? It is n to the power of root n. Now we have f of n is equal to 3 into n to the power of root n and g of n is equal to n to the power of root n. Here we can say f of n is equal to g of n in terms of asymptotic function. This is something like constant into n to the power of root n. So we can say asymptotically g of n is equal to f of n or f of n is equal to g of n. Consider the third option. What is g of n is not big O of f of n. It is g of n greater than f of n. When we found that f of n is equal to g of n, they are asymptotically equal. It means this particular expression is false. So in this case, we can mark option 3 as the wrong answer. Only when you take everything to the power of 2, you can find that asymptotically f of n is equal to g of n. Now we will evaluate the fourth option. F of n is less than or equal to g of n. So this is 3 into n to the power of root n less than or equal to n to the power of root n. And here you can find a symbol called equal to. It can either be less or equal. So in this case we can take this to be equal because this is something like constant into only. So this constant doesn't matter when we come to complexities. So n power root of n is equal to n power root of n. So we can mark option 4 to be true because asymptotically f of n is equal to g of n. Option 4 will be the right answer if g of n is equal to 2 to the power of root n log n to the base 2. Now you can ask me, if g of n is going to change like this, then what about h of n? So we will see that h of n is equal to n factorial. Just take log of n factorial. So this has a value of n log n. We already have a value for g of n, namely n to the power of root n. Now take log of g of n. This is equal to log of n to the power root of n. The same formula we have to apply in the reverse side. Now it is in the form of x power y. So you have to make it as y log x. So this will be root n log n. Now let's equate h of n and g of n. So h of n equal to g of n in this case. It is n log n, and here we will just equate this as root n log n. Log n and log n will get cancelled here. Now we have n and root n here. From this we can obviously say n is greater than root n. Now this is going to be a part of h of n and this is going to be a part of g of n. Now you can say that h of n is greater than g of n. So this equation will completely change as h of n is greater than g of n and g of n is asymptotically equal to f of n, which means that h of n is greater than f of n also. Since we find less than or equal to in the options 1 and 2, we mark them wrong. But in order to get into these details, we need to know the actual g of n. So in my opinion, if you practice lot of question papers, you can easily identify these kinds of problems. So this stresses that you have to practice a lot of previous year question papers, not only from UGC NET Computer Science but also from GATE CSE question papers. So option number 4 is the right answer. Next question. 2, 3, 4 trees are B trees of order 4. They are isometric of what trees? First we learn about red-black tree. A red-black tree is a binary search tree with the following properties. Edges are colored red or black. No two consecutive red edges on any root leaf path and same number of black edges on any root leaf path. That is equal to black height of the tree. Edges connecting leaves are black. These are the properties of red-black tree. Now we will learn about 2, 3, 4 trees. They will have 2, 3 or 4 children per node. That's why they are named as 2, 3, 4 trees. Now let me give you the representation of a 2-node tree. So let's take a value called A. I will have 2 branches here. That's why it is called 2-node. In this left side, the values less than A will be placed, and in the right side branch, the values greater than A will be placed. This is the case of 2-node tree. Now let's take 3-node tree. Here we will have 2 keys. So instead of value, we can tell them to be keys. We will take A and B. So there are 2 keys. And we will have 3 branches. These branches are called as links. So we will start with less than A here. then greater than A will be placed here. Since we have another key, the less than condition will start here and the greater than condition will end here. Next we will have 4 node tree here. So in this we will have 3 keys A, B, C. If there are 3 keys, there should be 4 links. 1, 2, 3 and 4. So we will start with less than A. Then here it is greater than A. Then we will start with B. Less than B, greater than B. Then for C. Less than C, greater than C. This is how we will be placing 2, 3, 4 trees. So these are the representation. And we will just learn about the complexity. Search and insert each take log n time. How are we relating 2, 3, 4 trees with red black trees? Red black trees are just a way of representing 2, 3, 4 trees. Here they are saying edges connecting the leaves are black and they are black everywhere. And if you take no 2 consecutive red edges on any root to leaf path, so if one is going to be red and the other will be black here. So no continuous red as per this 2, 3, 4 trees. You can find they are a way of representing 2, 3, 4 trees. So red black trees have a similar structure. This is actually a 2 node tree. So A less than A and greater than A. So similar representation. Similarly this is 3 node. This is actually A, B. So less than A, greater than A, less than B, then greater than B. So this is how they are representing in red black form. Similarly here you will have 3 keys and 4 links. So 2, 3, 4 trees are isometric of option number 4 red black trees. Option number 4 will be the right answer. Next question. Arrange the following in ascending order. This can be placed in unit 1. This can be placed in unit 9 also. But I have placed it in unit 7 so that we will learn solving this. It's a part of number theoretic algorithms. Let's solve this. They have asked the remainder of A, B and C and the last digit of D. Once you get a number, you have to arrange the number in ascending order. So let's learn about Fermat's little theorem. If P is prime and A is an integer not divisible by P, then A power P minus 1 will have a remainder of 1 when it is divided by P. So we will just equate this to the first one. 49 power 16 when divided by 17. So here A is 49, P is a prime number 17. A power P minus 1 will have a remainder 1 when it is divided by P. So 49 P minus 1 is 16. 49 power 16 when it is divided by 17 will have a remainder of 1. So the remainder of A is 1. If you know this theorem, you can do this. Let me tell you how to do this step by step. So let's take A. 49 power 16 divided by 17. We will start solving this. So when 49 is divided by 17, what is the remainder we get? So 49 and 17, we have 17 into 2 to be 34 and we have a remainder of 15. This is the remainder. When I want to find the remainder of 49 square, 49 into 49 divided by 17. I can write 49 square as 49 into 49. Now I know 49 divided by 17 will yield a remainder of 15. And 49 divided by 17 will yield a remainder of 15. Now what is 15 into 15? 225. When I divide 225 by 17. So ones are 17 and I have 55. 17 threes are 51. We are least bothered about the quotient here. Only the remainder matters. So the remainder of 49 square will be 4. Similar way we have to find for 49 power 16. How will we find this? So now we will combine 49 square into 49 square for 49 power 4. Mod 17. This is division giving you the quotient and this is the mod operation giving you the remainder. So this is divided by. So what is the remainder of 49 square? It is 4, and 49 square it is 4. 4 into 4 is 16 mod 17. So 16 is still less than 17. We have no issues. Next we will go with 49 power 4 into 49 power 4. This is actually for 49 power 8. Now 49 power 4 will have 16 as remainder, and 49 power 4 will have 16 as remainder, which will give you 256. So what is 256 mod 17? So 256 divided by 17. 17 5s are 85. So I have a remainder of 1. So 256 mod 17 will give me 1. It means 49 power 8 mod 17 will have a remainder of 1. So now it is easy to find for 49 power 16, which is nothing but 49 power 8 into 49 power 8 mod 17, which is equal to 1 into 1, which is equal to 1 mod 17. So what is the remainder of 49 power 16 when divided by 17? It is 1. So 49 power 16 mod 17 will give 1 as the remainder. This is how we have to solve this. So we have got 1 as the remainder. A is equal to 1. Now we will go to B. 2 power 446 when divided by 9. So we know 2 power 10 is 1024. We will find the remainder. So 1 9s are 9. This is 12. Then we have 9. Then we have 34. So this will give a remainder of 7. The remainder is 7 for 2 power 10. Now for 2 power 20. What we will do is 2 power 10 into 2 power 10. We are splitting it. So 7 into 7 is 49. 49 divided by 9. What is the remainder? So 9 5s are 45 and the remainder is 4. Then we have 2 power 40. 2 power 40 is equal to 2 power 20 into 2 power 20, which is equal to 4 into 4, it is 16. When I divide 16 by 9, the remainder will be 9 ones are 9. So 16 minus 9 will give me 7 again. So now 2 power 80 is equal to 2 power 40 into 2 power 40. So 7 into 7, 49 divided by 9 will have a remainder of 4 again. 2 power 80. From 80 can I get 400? Yes. If I apply power here, this will be equivalent to 2 power 400. Okay. So let's solve this. 2 power 80 power 5. So what is the remainder of 2 power 80? It is 4. So 4 power 5, which means 4 into 4 into 4 into 4 into 4. So this is 16, this is 16. 16 into 16, it is 256. 256 into 4. It is again 1024. So what is 1024 mod 9? It is 7. So we have already found this. So we know 2 power 400 when divided by 9 will leave a remainder of 7. Now we have to combine everything. So we have the value of 2 power 400. We have the value of 2 power 40. 400 plus 40 will give 440. Remaining we have 6. 2 power 400 will yield a remainder of 7 into 2 power 40 will yield a remainder of 7. What is 2 power 6? So 2 power 3 into 2 power 3. So it is 8 into 8, 64. So 64 divided by 9. 9 sevens are 63. The remainder is obviously 1. So 2 power 6 divided by 9 will yield a remainder 1. So now 2 power 6 mod 9 will give me 1. I am just dividing it by 9 and just giving you the remainder alone. So what is 7 into 7? 49. What is 49 into 1? It is again 49. So what is 49 mod 9? We already know it is 4. So the answer is 4. So the remainder of 2 power 446 when divided by 9, it will give a remainder of 4. B will have an answer of 4. Now let's solve C. Remainder of 155 power 17 when divided by 17. So let's start with 155. 155 mod 17 will give. So 155 divided by 17. 17 nines are will give 63 15. So it will have 2. This will give a value of 2. So what is 155 square? It is 2 into 2. That is 155 into 155 mod 17, which will give a value of 4. Now we will just double up again. 155 power 4 will have 4 into 4, which is equal to 16. 16 is less than 17. So 155 power 8 will have 16 into 16, which is equal to 256 mod 17. So 256 divided by 17. 1 17s are 17, 86, then 5s are 85. This will give a value of 1. So the remainder of 155 power 8 is 1. Now we will find it for power 16, which means 1 into 1, which is equal to 1 again. Now we have to find it for 17. So 155 power 17 is equal to 155 power 16 into 155, which is equal to 1 into 2 mod 17, which is equal to 2. So 2 is less than 17. So the answer of 155 power 17 mod 17 is equal to 2. So C will have 2. Let's get into D. They are asking the last digit of the number 7 power 45. So let's start from 7 power 1. 7 power 1 is equal to 7. 7 power 2 is equal to 49. 7 power 3 is equal to 49 into 7, which is equal to 343. 7 power 4 is equal to 343 into 7, which is equal to 1024. So 2401. Here the last digit is 7, here the last digit is 9, here it is 3 and here it is 1. Now it is easy to compute with 1. So let's write 7 power 45 as 7 power 44 into 7 power 1. What is the last digit of 7 power 1? It is 7. So let's retain the last digit here. Now 7 power 44 can be written as 7 power 4 the whole power 11. This will actually give 11 into 4 as 44. So we know the value of 7 power 4 now. So what is the last digit of 7 power 4? It is 1. So 1 power 11 into 7. 1 power 11 is 1. 1 into 7 is equal to 7. So the last digit of 7 power 45 will be 7. The answer here is 7. Now order this. 1, 2, 4, 7. Which one had the answer 1? Option A. Which had 2? Option C. Which had 4? Option B. Which had 7? Option D. A, C, B, D. Option number 3 will be the right answer. With this, we are completing Unit 7 questions. Let's solve Unit 8 Theory of Computation and Compilers questions. Let L is equal to AB, AA, BAA. Which of the following strings are not in L? If you find these three patterns in the strings given in the options, it means the strings are in L. But the question is, they are asking which string is not in L. It means we know from the 4 options only one string is not in L. L star is L closure. It's a combo of all the patterns inside the language that you can find in these options. So let's start with 1. A, B, A, A, B, triple A, B, A, A. So A, B is there. Then A, A is there. Then we have B, A, A. So it is there. Again we have A, B and A, A. All patterns are present in the string. So this is in L. Second one, we have 4 A's, single B and 4 A's. So let's take AA, then we have BAA, then AA. So second one is also present in L. Third one, we have single B, 5 numbers of A, single B, 4 numbers of A, and then another B. So BAA, then we have AA, then AB, again we have AA, then we have AA, and we have B left out here. So even if you want to take this to be AB, then this A will be left out. 3 is not in L. Let's check the fourth one. We have B, 5 numbers of A's and BAA. So we have BAA, then we have AA, then AB, then AA. So this is also in L. So the only option that is not present in L will be option number 3. Option 3 will be the right answer. Next question. Let A is equal to A comma B and L is equal to A star. Let X is equal to A parent, B parent, where N is greater than 0. The languages L union X and X are respectively. Basically, let's take X. X is equal to A power N, B power N. So if you take A power N, B power N format, generally they say this belongs to CFL. The reason is when you take a push down automata, just imagine a stack. The number of A's will be equal to number of B's as per this language. They say N is equal to a value greater than 0. So it can be N is equal to 1, N is equal to 2, N is equal to 3, etc. So if it is N is equal to 1, it is AB. If N is equal to 2, it is AABB. If N is equal to 3, it is AAA and triple B. Generally, if you take a stack, the number of A's will be pushed onto the stack, and whenever a B is encountered, A will be popped out. This will tell whether A's count is equal to B's count. So A power N, B power N is always a part of CFL. Now we have to check whether X is regular or not. Just take the pumping lemma. Let L be a regular language over some alphabet. There exists a positive integer, the pumping length of L, such that for every string of at least length P, there exist strings X, Y and Z that belongs to the alphabet such that S is equal to X, Y, Z. So they have given 3 conditions. Let's take N is equal to 3, AAA, triple B string as of now. Now we have to choose X, Y, Z from this string. So let's take A, B to be X and Y together. So what is X? X is this single A and let Y be AB. So here Y should not be equivalent to epsilon. It means Y should not be empty. Either you can make this to be X, this to be Y, or out of B, you can make this to be X and this to be Y. So we can try for both the cases. So we have the length of X and Y together, that is less than or equal to P. Here we will make a 3 length string, so it is less than or equal to 3. This condition is satisfied in both the cases. So this is case 1 and this is case 2. Next, Y is not equal to epsilon. Yes, Y is existing. Next, we have to check for X, Y power I, Z, where I is greater than or equal to 0. For I is equal to 0, here X is equal to A and Y is equal to AB. So if we have Y power 0, AB should not exist. Then what will happen to the first string? We will have AA, this AB will be absent, then we will have BB. If we have I is equal to 1, then we will have triple A and triple B, fine. When we go for I is equal to 2, AA will be present and AB together will be present as AB, then BB. Is this string present in the language X? This does not belong to it. So from this we can conclude that X is not regular. So now let's check this. We have X is equal to AA. When we say y power 0, it means we are removing 1b alone. This will result in AAA which is not a part of x again. So the count of A's should be equivalent to count of B's. You can choose any X and any Y with a maximum length of 3 because we have chosen that P to be 3. But the thing is, when you compute this for a set of iterations, the strings after the computation should be present in the language set. This x is not regular. So they are asking L union x and x respectively. So this x is the second part of the option. So whichever option is having not regular will stay. Whatever has regular in the second option will be ruled out. Now we have to find L. So L is equal to A star. What is A star? A star is, you can either have 0 or more occurrences. So we can have epsilon, we can have A, we can have B, we can have AB, we can have any combo. It is having the expression A star, definitely L is regular. So L is regular and X is not regular. So what about the union? L union X, what kind of strings it will have? It will have epsilon A, B, AB, then it will have double A, double B, triple A, triple B. When you have a union operation, all the strings of A power n, B power n will be sitting inside this L union X. Let's take L intersection X. This is not equivalent to 5 because L contains all the strings that X has. So this is not equivalent to null because A star has all strings of X. The intersection cannot be null. So let's check for pumping lemma of L union X. Whichever string we rejected in X, we'll just take. These strings were rejected by X. But just check for L union X. A star has all strings of X along with its own strings. This is a possible combination in A star. So this is right. This is a possible combination in A star. So it is there. When you apply the pumping lemma rule for L union X, all the strings are present in L union X. So this makes L union X to be regular. So not regular is rejected here. Option 3. L union X is regular but X is not regular will be the right answer. So generally if L is regular and X is regular, we need not even check this. We can say L union X is also regular. But in our case, one is regular and another is not regular. So in that case, all these strings given by X are acceptable in A star. Keeping that in mind, we mark the union of L and X to be regular. So we have an additional statement here. If a language L1 is regular and if language L2 is not regular, we have to check if language 1 intersection language 2 is equal to null. If the intersection gives a result of null, then L1 union L2 will be not regular. In case if L1 intersection L2 is not equal to null, then L1 union L2 will be regular. It means both have some common elements. Keeping this point in mind, we checked for L intersection X. Next question. Which of the following symbol table implementation is best suited if access time is to be minimum? So what is a symbol table? It's an important data structure created and maintained by the compiler in order to keep track of semantics of variables. It stores information about scope and binding information about names, information about instances of various entities such as variable, function names, classes, objects, etc. So this is a data structure and they are asking which implementation is best suited if the access, that is the search time, is to be minimum. So linear list takes O of n for both insertion as well as search. And next is search tree. You can take for binary search trees. Complexity will be O of log n. It's for both insertion as well as for search, because you're going to divide the content into two and then you're going to work with only one half. So it is log n. What about hash table? The elements are stored in an array with index numbers. So when you want to search, you will exactly locate it, and when you want to insert, you will calculate the slot based on a particular hash function and immediately insert it. This means that it takes O of 1 time for insertion as well as for searching. Now we have a term called self-organization list. What it is? It is a list that reorders its elements based on some self-organizing heuristic to improve average access time. This particular part states that the access time is actually more and the reordering is done to improve the average access time. It is O of 1 for insertion, but for search it takes O of n. So we have to consider the access time, though it takes only O of 1 for insertion, but it is O of n for search. So these two will get ruled out here, and because of search time here, fourth one will also get ruled out here. Option number 3, hash table, will be the right answer. Hash table implementation is best suited if access time has to be minimum. Next question. Consider a grammar E produces E plus N, E into N, then it has N. For a sentence, N plus N into N. The handles in the right sentential form of the reduction are: bottom-up parsing is the process of reducing a string to the start symbol of the grammar. In top-down parsing, what they will do is, from a start symbol, then this E will get expanded to E plus N, then into N, then this E will get converted to N, this plus N, and this into N. So this is top-down. What is bottom-up? Going from bottom to the top is bottom-up parsing. We are reducing a string. So this is a string to the start symbol of the grammar. At each reduction step, a specific substring matching the body of a production is replaced by the non-terminal at the head of that production. So here the body of the production will be this one or this one. It is replaced by the non-terminal at the head of the production. Here this is the non-terminal for the production. Let's take the string n plus n into n. So this n will be replaced by a non-terminal E and the rest will stay. Then E plus n will be replaced by the non-terminal and the rest will stay. Now the complete production is replaced by the non-terminal E. So this is how we start from the string and come to the start symbol of the grammar. So this is what they say, the production gets replaced by the non-terminal at the head of that production. So what is the question about is the handles in the right sentential form of the reduction. So what are handles? Handle is a substring that matches the body of a production. So which part you are going to replace, that part is called the handle, whose reduction represents one step along the reverse of a rightmost derivation. Then what is a right sentential form? A right sentential form is a sentential form that occurs in the rightmost derivation of some sentence. When you get through the working of this particular problem, you will understand it better. Let's have the right sentential form here, and the handle that is going to be matching the body of the production and the reducing production will be given in the third column. So let's start with the complete sentence given here. So this is what is given in the question, n plus n into n. The first handle that we are going to replace it with the production will be the first n. It is going to get replaced as E. So what is the production that helps us to do is E derives n or E produces n. This production is going to do that. Now after reducing the production, what happens in the right sentential form? This turns as E plus n into n. Whatever we did here, we are just placing it in 3 different columns along with the appropriate names. Only then you will be able to answer the question. What is the next handle we are going to work with? It is E plus n. So the handle that we work next is E plus N. And what is the reducing production? It is E derives E plus N. So what will the complete substring be replaced by? E. Now the remaining is into N. Now the handle will be E into N. What is the reducing production? E derives E into N. So which production is responsible for reducing this is given in this column. What is getting replaced is given in this column, and the right sentential form is the actual sentence that is given along with the replacement in the subsequent rows. So first we are changing N, that is the first handle. Then we are changing E plus N, that is the second handle. Then we are working with E into N, that is the third handle. So the handles in the right sentential form of the reduction are N, E plus N and E into N. Option number 4 will be the right answer. So you can ask me one thing. This is also right, but this is not the handle. All these are not handle. This is the exact sentence and this is wrong. This is a part of the right sentential form, but this is not a part of right sentential form. Option 1, 2, 3 are ruled out. Option 4 will be right. Next question. One of the purposes of using intermediate code in compilers is to. The analysis phase of a compiler breaks up a source program into constituent pieces and produces an internal representation for it called intermediate code. So you will have analysis phase here, then you will have intermediate code, then you will get into the synthesis phase. The synthesis phase translates the intermediate code into the target program. Front end of a compiler constructs an intermediate representation of the source program from which the backend generates the target program. So they have mentioned the front end and back end here and where the intermediate code is existing. The mission independent code optimization phase attempts to improve the intermediate code so that better target code will result. So from here what happens is what this point is telling. The code generator takes as input an intermediate representation of the source program and maps it to the target language. So let's check the options. Make parsing and semantic analysis simpler. So intermediate code comes after analysis phase, so this is wrong. Improve error recovery and error reporting, it has nothing to do with errors. Then the fourth one, improve the register allocation, it has nothing to do with it. The third one, increase the chances of reusing the mission independent code optimizer in other compilers. So here this term means it is attempting to improve the intermediate code so that better target code will result. Option number 3 will be the right answer. We'll say lexical analysis, syntax analysis, then semantic analysis, then we get into intermediate code. All these 3 steps together is what we call as analysis phase. So that's why parsing is a part of syntax analysis, and semantic analysis, they don't have work with the intermediate code. Only after the analysis phase, intermediate code is produced. Next question. The sum of minimum and maximum number of final states for a deterministic finite automata DFA having P state is equal to. So let's take the tuple of DFA. Q is the set of states. The count is given as P here. Then we have the input symbols, then we have the transition function, then we have Q naught as its start state, and F is a set of accepting states. They say F is a subset of Q. It means all the states can turn as accepting states, or at least one state will be taken as the accept state. So from this we can say the start state or the initial state, this will be only 1. The minimum as well as the maximum will be 1. What about the final state? Only when there is a finite state, the string will be accepted in a DFA. So minimum or at least one final state must be present. So at least in the sense it can be 1 or more than 1. What about the maximum? I can use all the states to be the final states. So this all means the total number of states that is available in the DFA. Here they are saying there are P number of states. So the maximum will be P states. They are asking for the sum of minimum and maximum. What is the sum of minimum and maximum? Minimum is 1, maximum is P. So it should be either 1 plus P or P plus 1. Both are same. Option number 3 will be the right answer. Next question. 3 address codes can be represented in special structures known as. So from which part is this question taken? It is taken from the intermediate code. 3 address code takes its name from instructions of the form x is equal to y operator z with at most one operator per instruction. So operator is represented here. These are operands. Now let's see the various representations of 3 address codes. The first one is quadruples. So this is the 3 address code available and they have converted this into quadruples. Quadruples in the sense there will be 2 operand or arguments and 1 operator and the result. So quadruple means 4 things are involved. What is the next representation? It is the triples. So the representation of this expression is given in the form of triples. What are the things involved in triples? It is 2 arguments and an operator. The next one will be indirect triples representation of the 3 address code. So from this we can say there are 3 representations. One is quadruples, another is triples, and the third one is indirect triples. So C alone is not there. Patterns is not a part of 3 address code structure. Any option that involves C will be ruled out and the one that includes A, B and D will be option 2. Option 2 will be the right answer. Next question. Which of the statements are correct? Murray and Mealy missions. They are a part of finite state missions in theory of computation. Let's learn about them. Finite state transducers are associated with a read once only input file that contains a string from an input alphabet and an output mechanism that produces a string from an output alphabet in response to a given input. So this is the official definition. So usually in finite automata what happens is we have an input and we'll say whether it is accepted in a language or not. But in finite state transducers, there will be an input and there will be an output too. These Murray and Mealy missions come under finite state transducers. In a Mealy mission, the output produced by each transition depends on the internal state prior to the transition and the input symbol used in the transition. So we can think of the output produced during the transition. What does Murray mission do? In a Murray mission, every state is associated with an element of the output alphabet. Whenever the state is entered, this output symbol is printed. The output is produced only when a transition occurs. Thus, the symbol associated with the initial state is not printed at the start but may be produced if the state is entered at a later stage. Murray and Mealy missions are finite state missions. Of course, they are finite state missions with output capabilities. It is absolutely right. So, A is included. We'll go to the fourth point. Murray mission is not a finite state mission. This is actually contradicting the A statement. D is false. And both these options can be ruled out. Next, we will see about their equivalence. Murray and Mealy mission equivalence. If a problem can be solved by a mission of one type, it can also be solved by the other type. In this sense, the two types of transducers are possibly equivalent. So, B statement. Any given Murray mission has an equivalent Mealy mission is true. Any given Mealy mission has an equivalent Murray mission in C statement is also true. Option number 2, A, B and C only will be the right answer. Next question. Match list 1 with list 2 according to the input to the compiler phase that processes it. So let's see a diagram here. Usually we say lexical analysis is about token stream processing. We say syntax analyzer is about syntax tree processing. But here the input part is given in one side and the face is given in the other side. Now whatever is given above the box is the input part. This is the input to lexical phase. This is the input to syntax phase. This is the input to semantic phase. This is the input to intermediate code generator phase. So we'll go with the diagram order. Character stream is an input to lexical analyzer phase. So D will be mapping to 3. We have 3 options. Then we have token stream as the output from lexical analysis phase. So token stream becomes the input of syntax analyzer phase. So C will be mapping to 4. D3, C4. We will rule out the others. So after syntax analysis, we get a syntax tree here. This syntax tree in A will be an input to the semantic analyzer phase. So after semantic analyzer also we have a syntax tree here. But do we have intermediate code generator in the list 2 part? No, we don't have. We have only code generator part that is present here. So syntax tree will become an input to the semantic analyzer phase. So A will be mapping to 2. After that we have intermediate representation in B. So we have 2 intermediate representation here as input, one to mission independent code optimizer and one to code generator. So here the option is code generator. So we have to consider this part. So B will be mapping to 1. Option 2 will be the right answer. So we will also see another diagram. So this is the character stream and this is the token stream. This is the syntax tree. This is the intermediate representation and this is the target mission code. Next question. Arrange the following phases of a compiler as per their order of execution, start to end. We are starting with lexical analysis. So it starts with E. Then we have syntax analysis. It is B. Then we have semantic analysis. It is D. Then we have code optimization, which is C. So there are actually 2 phases of code optimization. One is for mission independent optimizer and another one is mission dependent optimizer. So after target code generation there is an optimization and before target code generation there is an optimization. So let's check the option EBD. It is given here and it goes with C next. So optimization is about mission independent optimization. So we'll mark C. Then comes target code generation, option A. So EBD CA. Option number 3 will be the right answer. So regarding the other EDB. So it is saying E means lexical to semantic. So this order is totally wrong. And starting with syntax analysis is also wrong. With this we are completing Unit 8 solutions. Let's solve Unit 9 Data Communication and Computer Networks questions. Hash functions are used to produce a message digest which are then encrypted with a private key to get which of the following options. We will directly get into the answer. It's digital signature. Actually this is the message and it is passed through a hash function and we get the message digest after that. In digital signature, the message is passed through an algorithm called a hash function and this produces the message digest. What happens after that is the digest then goes through the signing process using the sender's private key. In digital signature, the private and public keys of the sender are used. The sender uses a private key applied to a signing algorithm to sign the document. The receiver uses the public key of the sender applied to the verifying algorithm to verify the document. 2 algorithms are here. One is signing algorithm and the other one is verifying algorithm. That happens in the receiver side. So sender will sign it, receiver will verify it. How does the sender sign? Using the private key. How does the receiver verify? Using the public key. The private key and the public key belong to the sender. Usually in cryptography, the receiver's public and private key will be used. But in digital signature, the sender's private key and public key are used. So this is the depiction of the complete process that is happening. So using the hash function, they are forming the digest and it is signed and sent to the receiver. This hash function is used to produce the digest and they are checking whether it is the same. If it is the same, it is accepted. If not, it is discarded. Option number 2, digital signature will be the right answer. Next question. A multiplexer combines for 100 kbps channels using a time slot of 2 bits. What is the bit rate? This is actually asked from the reference book of networks. Time division multiplexing is a digital process that allows several connections to share high bandwidth of a link. In synchronous time division multiplexing, the data flow of each input connection is divided into units, where each input occupies one input time slot. Time slots are grouped into frames. Each input occupies one input time slot and the time slot are grouped into frames. A frame consists of one complete cycle of time slots with one slot dedicated to each sending device. In a system with n input lines, each frame has n slots, with each slot allocated to carrying data from a specific input line. So this is the diagram associated with this question. But what is the exact question is, a multiplexer combines 400 kbps channels, 1, 2, 3, 4. This is what the diagram is depicting. 4 channels are using a time slot of 2 bits. So how do you get 8 bits here? One slot is 2 bit. What about 4 slots? It is 8 bits. So this is how they have grouped it. They are asking for the bit rate. For that we have to find the frame rate. So frame rate is equal to, that is frame per second is equal to the channel's bandwidth 100 kbps divided by the time slot 2 bits. So how much is 100 divided by 2? It is 50 kbps. So kilobits per second it is given. So kbps. Once you convert this k into 1000, this becomes 50,000 bits per second. So this is the frame rate. We can say it is 50,000 frames per second or 50,000 bits per second. This diagram says frame duration. This is actually 1 divided by 50,000. That gives 20 microsecond and it is a calculation for frame duration. This count is available here, frames per second. This is the frame rate that we have found. From the frame rate, we have to calculate the bit rate. Every frame carries how many bits? So you have 4 divisions here. One time slot is of 2 bit. When you multiply 4 into 2, this will give 8 bit. Each frame carries 8 bits. So they say time slots are grouped into frames. So 4 time slots make one frame as per this diagram. So every slot is 2 bits and there are totally 4 slots. So 4 into 2 gives 8 bits. You have to understand how we get 8 bits here. Each frame carries 8 bits and the bit rate will be frame rate into number of bits per frame. So frame rate is 50,000 bits per second or the frames, and the number of bits per frame will be 8 because each frame is carrying 8 bits. Now just multiply 5 into 8, it is 40. Along with 40, you have to put 4 other zeros. 1, 2, 3, 4. Now converting this into kbps, only these 3 will be converted to kbps. So this is bits per second and this is 400 kbps, kilobits per second. So this 400 and This 10 to the power 3 is converted as kilo. Even if you don't convert and use the same thing, 50 kbps into you have 8, so 400 kbps will be the answer. So this is the answer for the question. Do you find 400 kbps in this option list? No, but option 3 was marked as the official answer. This is the bit rate. So I told there were many questions along with this statement. So one question was to find the frame duration, another question was to find the frame rate, and one more question was to find the bit rate. So everything they have calculated and placed here in the diagram. So the question mentions that a multiplexer combines if this 4 is not there. They have mentioned only about 100 kbps channel. If that 4 is not mentioned, you need not multiply this with 4. So this will not become 8 bits here. We can say each frame is going to carry only 2 bits. So in that case, bit rate will be frame rate into number of bits per frame. So frame rate is 50 kbps from this part into number of bits per frame is just 2 bits. This will end up with 50 into 200 kbps. So the bit rate will be 100 kbps. For this question, actually option 1 will be the right answer because they have not mentioned 4 explicitly. So let me explain in Tamil. Multiplexer combines 400 kbps channels என்றதா actual question. அந்த actual question கான calculation தான் இங்க நீங்க பார்த்தது. அதோட diagram தான் reference bookல இருந்து எடுத்தது. So அதோட final answer வந்து 400 kbps னு போட்டிருக்கு. ஆனா official answer வந்து option 3 னு கொடுத்திருக்காங்க. 40 kbps னு. But actual answer வந்து 400 kbps. அதுல எந்த சந்தேகமும் இல்ல. ஒருவேளை இந்த questionல அந்த 4 mention ஆகாம a multiplexer combines 100 kbps channels னே கொடுத்திருந்தாங்கன்னா அத 4 னு மென்ஷன் பண்ணாம கொடுத்திருந்தாங்கன்னா இந்த இடத்துல நம்ம 4 into 2 bit is equal to 8 bit னு மாத்துறோம்ல அந்த இடத்துல 8 bit னு போடாம அவங்க கொடுத்திருக்க டைம் ஸ்லாட் படி அத 2 bits னே வெச்சிருந்தோம்னா 50 into 8 னு போட்டுதானே 400 வந்தது இந்த இடத்துல 50 into 2 னே போட்டிருந்தீங்கன்னா 100 kbps னு ஆப்ஷன் 1 ஓட ஈக்குவேட் ஆயிருக்கும். When the 4 number is missing, the 2 bits will be staying as it is. So 50 into 2 will make 100, which is actually equivalent to option 1. In case if 400 kbps channels are mentioned, then the bit rate will be 50 kbps into 4 into 2 bits, which is equal to 400 kbps, which is not mentioned in any of the option. The official answer is option number 3, but it no way matches. That is, if only one channel is present, the answer will be 100 kbps. If there are 4 channels present, then it is 400 kbps. Next question. Which of the following is not a field in TCP header? So let's see the TCP header. Sequence number. It is present. Checksum. It is present. Fragmentation offset. This is actually available in IPv4 header. It is not a part of TCP header. Then we have window size. It is here. So we have source port, destination port, address. Then we have acknowledgement number, unreserved, header length, urgent pointer, options and padding. But you don't find fragmentation offset here. So option number 3 will be the right answer because they are asking which is not a field in TCP header. Next question. In bit stuffing, each frame begins and ends with a bit pattern in hexadecimal. So bit stuffing is a process of adding one extra zero whenever 5 consecutive ones follow a zero in the data, so that the receiver does not mistake the pattern for a flag. So what is the flag value? 0, 111, then we have 1110. This is in the form of hexadecimal. Hexadecimal's notation will be 0x. So whenever you want to represent hexadecimal, you will be representing in 0x format. So all the options are in 0x. They are preceded by 0x. Now we have to find the hexadecimal form of this binary code. So let's take the 8421. That is 2 power 0, 2 power 1, 2 power 2, 2 power 3. Just place the first 4 bits 0, triple 1. What it is? It is 7. What is triple 1, 0? 1, 1, 1, 0. 8 plus 4, 12. 12 plus 2, it is 14. In hexadecimal, we have to represent 10 by A, 11 by B, 12 by C, 13 by D, and 14 by E. Then 15 is represented as F. So 14 means you have to write it as E. So the first 4 bits is 7 and the last 4 bits is E. Since it is hexadecimal notation, you have to precede it by 0x. Option number 4 will be the right answer. Next question. Which of the following are example of CSMA channel sensing methods? CSMA is carrier sense multiple access. The chance of collision can be reduced if a station senses the medium before trying to use it. In order to avoid collision, they are saying the station has to sense the medium before using it. So there are 3 persistent methods, that is 3 channel sensing methods. The first one is one persistent method. The second one is non-persistent method. This can also be written as 0 persistent. Then the third one will be P persistent. So A 1 persistent, C P persistent and D non-persistent written as 0 persistent. Options A, C and D are included in option number 2. Option 2 will be the right answer. So 2 persistent is not a channel sensing method. In the one persistent method, after the station finds the line idle, it sends its frame immediately. In the non-persistent method, a station that has a frame to send senses the line. If the line is idle, it sends immediately. If the line is not idle, it waits a random amount of time and then senses the line again. In the P persistent method, if the channel has time slots with a slot duration equal to or greater than the maximum propagation time, it waits for a slot and then asks again if it is idle or busy. If it's idle, then it goes back again here. So if it's busy, use back off process as though collision occurred. But here, if the channel is busy, it again goes back and keeps sensing again and again. Only if it is idle, it gets into this process. Next question. The work done by UDP is. Choose the correct answer from the options. The user datagram protocol is what we call as UDP. It's a connectionless, unreliable transport protocol. UDP provides a connectionless service. This means each user datagram sent by UDP is an independent datagram. There is no relationship between the different user datagrams, even if they are coming from the same source process and going to the same destination program. They are saying every datagram is treated as an independent datagram. It means even if they are sent from the same source and even if they are traveling to the same destination, it does not care about it. It treats it as independent datagram. There is no connection establishment and no connection termination as it happens in transmission control protocol, what we call as TCP. This means that each datagram can travel on a different path. So only when there is a connection oriented service available, every datagram will be traveling in the same path. When it is connectionless, it can travel in any other path. So every datagram can take a different path and travel. Ultimately, they have to reach the destination. There is no flow control and hence no window mechanism. The receiver may overflow with incoming messages. Why there is no flow control? Because every datagram is taking its own route. It is not going to use the same path. So there is no flow control. B is not there. There is no error control mechanism except for the checksum part. The process that uses UDP cannot send a stream of data to UDP and expect UDP to chop them into different related user datagrams. It says it cannot fragment it. Instead, each request must be small enough to fit into one user datagram. Only those processes sending short messages should use UDP. So once they say there is no error control mechanism, there is no work for retransmission. And since every datagram is taking a different path, there is no possibility of congestion also. So A is also not there. A, B, C are not in the answer. Segments transmission means each user datagram is an independent datagram and the work of UDP is to send it from source to destination. It is a connectionless service and it is unreliable too. So option 3, D only will be the right answer. Sending the user datagram from source to destination, that is segment transmission or datagram transmission. Next question. Which of the following statements are not correct? From the options we can understand it is all about the routing algorithms. The routing algorithm is responsible for deciding which output line an incoming packet should be transmitted on. So we will see the routing protocols first. Intra-domain and inter-domain protocols are there. In intra-domain we have distance vector and link state, and in inter-domain we have path vector. And everything has a particular protocol here. We will just see the expansion. RIP is routing information protocol. It is a distance vector algorithm following protocol. Then we have OSPF, open shortest path first. This belongs to link state. Then we have BGP, border gateway protocol. This is a path vector routing algorithm. So first, OSPF is based on distance vector routing protocol. It is actually a link state protocol. So A is wrong. So the option must include A. So 3 and 4 are out of the race. Then we have both link state and distance vector routing are based on least cost goal. In distance vector routing, the least cost route between any two nodes is the route with the minimum distance. So it works for least cost goal. Distance vector routing is fine. So there are two other terms we will learn about it. Split horizon. Each node sends only part of its table through each interface. That is called split horizon. And there is a strategy called Poisson reverse strategy in distance vector routing. This can replace the distance with infinity. Infinity means we can say the node is not reachable. So it can replace the distance with infinity as a warning, stating that you can never reach that node. So this is called as Poisson reverse strategy. The two node instability can be avoided by using the split horizon strategy combined with Poisson reverse strategy. However, if the instability is between three nodes, stability cannot be guaranteed. Now we will get on to the D statement. The three node instability can be avoided using split horizon combined with Poisson reverse. If the instability is between three nodes, the stability cannot be guaranteed is the actual statement. The split horizon and Poisson reverse can be used for two node instability. D is also wrong. So we will rule out 2. Option number 1 will be the right answer. Now link state routing. If each node in the domain has the entire topology of the domain, the list of nodes and links, how they are connected including the type, cost and condition of the links, the node can use Dijkstra's algorithm to build a routing table. What is the use of Dijkstra's algorithm? To find the shortest path. So statement B, link state is also based on least cost goal. How do we confirm this? Based on Dijkstra's algorithm. And how did we confirm distance vector is using least cost goal? From this statement, the least cost route is the route with the minimum distance. So B is true statement. Both these algorithms are based on least cost goal. Then C, BGP4 is based on the path vector algorithm. Yes, it's a path vector algorithm. So C is also right. Next, RIP is based on link state algorithm. RIP is based on distance vector algorithm and not link state. So E is also wrong. This is how we are concluding A, D and E are the right answer but the wrong statements. So we learn about the path vector routing now. There is a speaker node in each autonomous system that acts on behalf of the entire autonomous system. The speaker node creates a routing table and advertises it to the speaker node in the neighboring autonomous system. Next question. Which of the following statements are correct? This question is based on line coding schemes. So we have unipolar, polar, bipolar, multi-level and multi-transition. In unipolar, we have NRZ, non-return to zero is NRZ. Then in polar, we have NRZ, RZ and biphase. In this biphase, we have Manchester and differential Manchester. So what is RZ? It is return to zero. So in bipolar, we have AMI and pseudo-ternary. In multi-level, we have 2BIQ, 8B60 and 4UPA M5. In multi-transition scheme, we have MLT3. So in NRZ, we have L and I. L is level and I is invert. Now we'll check the statements. NRZ is a unipolar scheme. It belongs to this, in which the positive voltage defines bit 1 and 0 voltage defines bit 0. A statement. NRZ is a bipolar scheme. It's wrong. In which the positive voltage defined bit is 0. No. If it is a unipolar scheme, then the positive voltage defines bit 1 and 0 voltage defines bit 0. So both these things are wrong. So A is wrong. We have to find correct statement. Rule out all A related options. You have the answer. Option 3 will be the right answer. We'll check the other statements. NRZL and NRZI both have an average signal rate of n/2 baud unit. So B is right. Then NRZL and NRZI both have a DC component problem. So the D statement, NRZL and NRZI both have DC component problems. It is true. The idea of RZ, transition at the middle of the bit, and the idea of NRZL are combined into Manchester scheme. So C is also right. The idea of RZ and NRZL are combined to Manchester scheme. Then the E statement. The minimum bandwidth of Manchester and differential Manchester is 2 times that of NRZ. What does E statement say? The minimum bandwidth of Manchester and differential Manchester is 3 times, which is actually wrong. It is actually 2 times that of NRZ. So E is also wrong. So once you rule out A and E, you will obviously end up with B, C and D only as the right answer. Next question, match list 1 with list 2. So what is monoalphabetic cipher? A character in the plain text is always changed to the same character in the cipher text. The relationship between characters in the plain text and cipher text is a 1-to-1 relationship, because every time I will replace a character by the same character. So it is 1-to-1 relationship. A will be mapping to 3. 3 and 4 are ruled out. In a polyalphabetic cipher, each occurrence of a character can have a different substitute. The relationship between a character in the plain text to a character in the cipher text is a 1-to-many relationship, because it is having different substitute every time. So polyalphabetic cipher will be mapping to 2. D2 and A3. Option 2 is also ruled out. Option number 1 will be the right answer. Now we will see DES, Data Encryption Standard. In Data Encryption Standard, we have a part called round key generator. This is a 64-bit key. And so we are mapping DES to 1, B to 1. Then we have cipher feedback and output feedback. CBF and OFB are stream ciphers. So after DES and AES in the reference book, you have a topic called modes of operation. Under that we have 4 types, and CBF and OFB, they are actually stream ciphers. They have the feedback mechanism. So C is mapping to 4. I kept telling reference book. So let me name the book. It is Behrooz Farrouzan's Data Communication and Networking book. Next question. Arrange the following steps in the correct order for a DHCP client to renew its IP lease with a DHCP server. DHCP is Dynamic Host Configuration Protocol. This has been devised to provide static and dynamic address allocation that can either be manual or automatic. So we have a set of points. The dynamic aspect is needed when a host moves from network to network or is connected and disconnected from a network. DHCP provides temporary IP addresses for a limited time. The addresses assigned from the pool are temporary addresses. The DHCP server issues a lease for a specific time. When the lease expires, the client must either stop using the IP address or renew the lease. The server has the option to agree or disagree with the renewal. If the server disagrees, the client stops using the address. So a temporary address is given to the client for a specific time. It's like issuing a lease by the server. Once the lease expires, the client should either stop using that particular IP address or the client should renew the lease. When the client renews the lease, the server has the option to either agree or disagree with the renewal. In case if it agrees, the client can continue using the IP address. If the server disagrees, the client must stop using the address. Based on this content, we are going to answer this. So first it starts with the client has to check the local lease timer and initiate renewal. So this is where the story is starting. C comes first. This is for initiating renewal by client. After initiating, what it has to do? DHCP client sends a DHCP request message. So it has to send a message. So obviously A comes in, send message. After receiving the message, the server has to acknowledge it. So DHCP server acknowledges the renewal with a DHCP acknowledgement message. So it is B. Acknowledge renewal. Who is doing this? Server. Then the DHCP server updates its lease database. So it has to make an update to the database stating that the lease has been renewed. So here server updates database. C, A, B, D. Option number 4 will be the right answer. To renew a lease, first it has to check the lease timer and then initiate renewal. Then it has to send a message to the server. The server will acknowledge it. After that, it is updating the lease database. Next question. Given below are two statements. In datagram networks, routers hold state information about connections. In virtual circuit network, each circuit requires router table space per connection. So let's see about these two networks. In datagram networks, connectionless service is offered. When they are offering connectionless service, how will the routers hold information about the connections? So they do not hold information. In that case, statement 1 is false. In virtual circuit network, connection oriented service is used. A path from the source router to the destination router must be established before any data packets can be sent. So they are saying it's a connection oriented service. So before sending any data packet, a path from the source to the destination should be established. Now we have a comparison table between datagram and virtual circuit networks. Regarding state information, the second column is datagram network. Routers do not hold state information about connection, so we have already marked it false. But here virtual circuit requires router table space per connection. So this requires the space per connection is absolutely true. Only based on this point they have asked these two statements. From this we can mark option number 4. Statement 1 is incorrect but statement 2 is correct as the right answer. So let's see an overall view. Circuit setup is not needed since it is connectionless. Here it is required because it is connection oriented. Addressing. Each packet contains a full source and destination address because it is connectionless service. Here it contains a short VC number stating it is going to travel in that particular path. In routing, each packet is routed independently. Here the virtual circuit is set up and all packets will follow the same route. Effect of router failures. None except for packets lost during the crash. Here all VCs that pass through the failed router are terminated. Quality of service is difficult and here it is easy because enough resources can be allocated in advance for each virtual circuit. Regarding congestion control, it is difficult here but here it is easy because if enough resources can be allocated in advance for each virtual circuit. So both quality of service and congestion control have the same reason here. With this we are completing Unit 9 questions. Let's solve Unit 10 Artificial Intelligence questions. What is the generic structure of multi-agent system? MAS. So it is given as multi-agent system. Here from this term we can understand that there are multiple agents involving in a system. So single agent with multiple objectives will not be the option. Multi-agents with a single objective. You cannot define the objective for multiple agents at a time. When there are multiple agents, each will have an objective, each will do the task that it has to do. Maybe they can communicate about their task with each other, but they cannot work towards a single objective. So they are asking in terms of generic structure. So this will also not be an option. And if you take the fourth option, multi-agent with two objectives, they are quantifying the number of objectives, which again will not be an answer. So multi-agents with diverse objectives, it means variety of objectives and communication abilities. As I said earlier, each may have a different objective and they can communicate with each other about it. Multi-agent system structure will be multi-agents with diverse objectives and communication abilities. Option 3 will be the right answer. Next question. A dash point of fuzzy set A is a point x that belongs to capital X at which mu A of x is equal to 0.5. So they have given a specific value here. A crossover point of a fuzzy set is a point at which mu value of A of x is equal to 0.5. So this is a direct statement question. Option number 3 will be the right answer. Crossover of A is equal to x for which mu A of x is equal to 0.5. This is how it will be given. Next question. In a genetic algorithm optimization problem, the fitness function is defined as f of x is equal to x square minus 4x plus 4. Given a population of 4 individuals with values of x 1.5, 2.0, 3.0 and 4.5. What is the fitness value of the individual that will be selected as the parent for reproduction in one generation? We have to calculate the fitness value using this fitness function. What is a fitness function? A fitness function value quantifies the optimality of a solution. The value is used to rank a particular solution against all other solutions. When you want to assign rank to a set of values, obviously the one with larger value will be assigned the first rank, and that will be the individual who will be selected as the parent for reproduction. Now let's get into the calculation. The first value of x is 1.5. So f of 1.5 is equal to 1.5 the whole square minus 1.5 into 4 plus 4. 1.5 into 1.5 will give 2.25 minus 1.5 into 4 will give 6.0 plus 4. 2.25 minus 2. So minus 6 plus 4 will give minus 2. This is equal to 0.25. The next value of x is 2.0. So let's take it as 2. 2 square minus 4 into 2 plus 4. 2 square is equal to 4. 4 into 2 it is 8 and then plus 4. 4 plus 4 will give you 8. 8 minus 8 will give you 0. Next we have f of 3. So instead of 3.0 I am just making it as 3. 3 square minus 4 into 3 plus 4. This is equal to 3 square is 9. 4 into 3 is 12 plus 4. 9 plus 4 is 13. 13 minus 12 will give you 1. Next value of x is 4.5. 4.5 the whole square minus 4.5 into 4 plus 4. This is equal to, we'll do a simple calculation here. I will take out 4.5 from this. So 4.5 into, now one more 4.5 is here, minus 4 is remaining here. This is actually easy for us to calculate. That's why I took, instead of multiplying 45 into 45 and adjusting the points, we can go with this option. So this will be 4.5 into, what is 4.5 minus 4? It is 0.5, then plus 4. So this will be 4.5 into 0.5 will give 2.25. Then this plus 4 will be here. So 2.25 plus 4 will give 6.25. Now you have 0.25, 0, 1, 6.25. Just arrange it in decreasing order. So the largest value is 6.25, then we have 1, then we have 0.25, then we have 0. So which fitness value of the individual ranks first? So option number 4, 6.25 will be the right answer. This is the fitness value of the individual who will be selected as the parent for reproduction in a generation. Next question. In a feed-forward neural network with the following specifications. So let's understand the structure of the neural network now. Input layer has 4 neurons. So let's take this as the input layer. 1, 2, 3, 4. Hidden layer has 3 neurons. This is the hidden layer. 1, 2, 3. Output layer has 2 neurons. Using the sigmoid activation function for given input values. So they have given the values of the input layer. So if this is going to be taken as x, then we can name this as x1, x2, x3 and x4. The values are given respectively 0.5, 0.8, 0.2 and 0.6, as well as the initial weights for the connections. So far we have solved problems like there will be a set of neurons here and again a neuron for the output. So eventually we will have one weight for each. Then the x values will be x1, x2 and x3, and here we will have w1, w2 and w3. What we will ultimately do is we will actually find the product of xi and wi and then sum them together. So I is equal to 1 to 3. We will multiply x1 into w1, x2 into w2, then x3 into w3 and add all these 3 together. So this will give the value of this particular neuron. You can see all these input layer neurons are connecting to a single neuron here. So this is the case of this example. Here also we will use the same function, summation of xi into wi, to calculate for a particular neuron. But here you have 4 neurons in input layer, 3 neurons in the hidden layer. Let's take hidden layer as H1, H2 and H3, and this is the output layer. Let's take it as Y1 and Y2. Now they have given W1, W2, W3 as input layer to hidden layer weights. So how will you do this? From x1, x2, x3 and x4, I have to connect to H1. This weight is given by W1. So you have 4 values, 0.1 for x1 to H1, for x2 to H1 you have 0.3, for x3 to H1 you have 0.5, for x4 to H1 you have 0.2. Then the next weight is x1 to H2, x2 to H2, x3 to H2 and x4 to H2. This is given by W2 array. 0.2 is for x1 to H2, 0.4 is for x2 to H2, 0.6 is for x3 to H2, 0.2 is for x4 to H2. Then W3 is given for x1 to H3, x2 to H3, x3 to H3 and x4 to H3. This is given by the array W3. 0.3 is for x1 to H3, 0.5 is for x2 to H3, 0.7 is for x3 to H3, 0.2 is for x4 to H3. This is how they are given from input layer to hidden layer weights. Now let's see the other weights. Hidden layer to output layer weights. How will you interpret this? So H1 to Y1, H2 to Y1 and H3 to Y1 is given in W4 array. So 0.4, 0.1 and 0.3 respectively from H1, H2 and H3. And again we have W5. So this will be H1 to Y2, H2 to Y2 and H3 to Y. This is given by W5 array 0.5, 0.2, 0.4 respectively from H1, H2 and H3 to Y2. So this is how you have to do. Now I have given you the overall structure. Let me explain this once in Tamil. நமக்கு 4 input layer neurons இருக்கு. ஸோ 4த்துக்குமே x வேல்யூ இந்த அரேலேருந்து எடுக்கணும். ஒரு x வேல்யூ வந்து ஹிடன் லேயரோட கனெக்ட் ஆகியிருக்கும். ஃபர்ஸ்ட் ஹிடன் நியூரானுக்கு நமக்கு 4 இடத்துலேருந்து வேல்யூஸ் வரணும். x1, x2, x3 and x4லேருந்து. ஸோ இந்த 4 வேல்யூவை தான் அவங்க W1ல கொடுத்துருக்காங்க. அடுத்தது H2க்கு நமக்கு 4 வேல்யூ வரணும். எங்கேருந்து வரணும்? x1லேருந்து x2லேருந்து x3லேருந்து x4லேருந்து வரணும். அது W2ல கொடுத்துருக்காங்க. அதே போல் H3க்கு போக வேண்டிய 4 வேல்யூவும் W3ல கொடுத்துருக்காங்க. இதே மாதிரியே நமக்கு 3 ஹிடன் லேயர் நியூரான்ஸ்லேருந்து 2 அவுட்புட் லேயருக்கு போகிற வெயிட்ஸ் கொடுத்துருக்காங்க. அப்போ Y1க்கு நமக்கு H1, H2, H3 3 நியூரான்லேருந்து வருது. அதை W4லையும், Y2க்கு H1, H2, H3லேருந்து 3 நியூரான் வருது. அதை W5லையும் கொடுத்துருக்காங்க. இதுக்கப்புறம் நம்ம எப்படி அதை காம்ப்யூட் பண்ணுறதுன்னு பார்ப்போம். ஸோ the question now is, what is the output of the output layer when the given input values are passed through neural network? Round the answer to 2 decimal places. So these are the values x1, x2, x3 and x4. I have placed the x array here. Then W1, W2, W3 I have placed in the respective column of x. So when I have to map x1 to W1, I will use 0.1, x2 to W1, I will use 0.3 and so on. So let's start working now. So this is the input layer neuron. Let's write the values. It is 0.5, 0.8, 0.2 and 0.6. Now we will have the hidden layer neurons. For H1, we have to take only W1 values. For H2, we have to take only W2 values, and for H3, you have to take only W3 values. X1 to H1 is given as 0.1. Then X2 to H1 is given as 0.3. Then X3 to H1 is given as 0.5. Then X4 to H1 is given as 0.2. We have to find the product of x and w respectively and then sum them together. So for H1, x1 into w1 first value plus x2 into w1's second value, then x3 into w1's third value plus x4 into w1's fourth value. So what is x1? 0.5. What is the respective W1 value? It is 0.1. Plus what is X2? It is 0.8. What is the W1 value we are taking here? It is 0.3. Plus what is X3? It is 0.2. What is the W1 value? It is 0.5. Plus what is X4 value? It is 0.6. The respective W1 value will be 0.2. What is 0.5 into 0.1? It is 0.05 plus 0.8 into 0.3 will give 0.24 plus 0.2 into 0.5 will give 0.10 plus 0.6 into 0.2 will give 0.12. When you add this, you will get a value of 0.51. So H1 will have a value of 0.51. Now we will calculate for H2. So X1 to H2, the value is 0.2. So we will calculate for H2 here. H2 is equal to 0.5 that belongs to X1 and W2's value will be 0.2 plus X2 to H2 is 0.4. So X value is 0.8 and the respective W value is 0.4 plus X3 to H2 is 0.6. X3's value will be 0.2 and the respective W2 value will be 0.6 plus x4 to h2 will have 0.2. So x4's value is 0.6 and the respective w value will be 0.2. 0.5 into 0.2 will give 0.10 plus 0.8 into 0.4 will give 0.32 plus 0.2 into 0.6 will give 0.12 plus and 0.6 into 0.2 will again give 0.12. This is equal to 0.66. So H2 has a value of 0.66. Now we will move on to the H3 neuron. X1 to H3 has a value 0.3. So we will calculate here. X1 is 0.5 and the respective W is 0.3 plus X2 to H3 will have 0.5 as the weight. So X value will be 0.8 and the respective weight will be 0.5 plus X3 to H3 will have a value of 0.7. We will multiply x3 0.2 and the respective weight 0.7 plus x4 to h3. It is 0.2. So 0.6 is for x4 and the respective weight is 0.2. 0.5 into 0.3 will give 0.15 plus 0.8 into 0.5 will give 0.40 plus 0.2 into 0.7 will give 0.14 plus 0.6 into 0.2 will give 0.12. When you sum up, you will get a value of 0.81. So H3 will have a value of 0.81. Now we have found the value of the neurons H1, H2 and H3 which are a part of the hidden layer. So X is a part of input layer. Now we have to do the same kind of calculation from hidden layer to output layer. So as I explained earlier, now this is going to be like your X value and you have to multiply it with the respective weights accordingly. So remember this formula, summation of Xi into Wi. Now this will be summation of Hi into Wi. So let's start. H1 to Y1 will have a value of 0.4. So y1 is equal to 0.51 into 0.4 plus h2 to y1 will have 0.1, 0.66 from h2 and the respective weight is 0.1. Then h3 to y1 will take the value 0.3 plus 0.81 belongs to h3 and 0.3 is the respective weight. 0.51 into 0.4 will give 0.204 plus 0.66 into 0.1 will give 0.066 plus 0.81 into 0.3 will give 0.243. When you add all this, you will end up with 0.513. So the value of y1 will be 0.513. Now we will compute for h1 and y2. So we are taking 0.5. So y2 is equal to h1's value is 0.51 and then we are multiplying it with the respective weight. Then h2 to y2, it takes the value 0.2 as weight. So 0.66 into 0.2 plus h3 to y2. This will take the value 0.4. So 0.81 from h3 into 0.4 as the respective weight. 0.51 into 0.5 will give 0.255 plus 0.66 into 0.2 will give 0.132. 0.81 into 0.4 will give 0.324. When you sum these three, you will get 0.711. So the value of y2 will be 0.711. So let's get into the question again. The input layer has 4 neurons, hidden layer has 3 neurons and output layer has 2 neurons. Using the sigmoid activation function for the given input values, the final value of y1 is 0.513 and y2 will be 711. Usually after the output layer there will be an activation function. You should have seen in the neural network structure. Now the activation function has to be used for both y1 as well as for y2. So sigmoid activation function is equal to 1 divided by 1 plus e power minus x. We can actually calculate this only using a calculator. So get the negation of x, then find e power minus x, then find 1 plus e power minus x, then divide. This is how you have to find it out. There is also an alternate formula you can use. It is e power x divided by e power x plus 1. So you have to find e power x first, add 1 to it, then you have to divide both these answers and find this. This is the usual function they used to say. Take the summation of weight into the input value. So we used to say x into w. So this activation function has to be applied on this particular value. This will give the output actually. Here we have 2 neurons in the output layer. So we have to calculate activation function for y1 as well as y2. The sigmoid activation function value for 0.513. This is actually y1's value. The value will be equating to 0.62. So this is S of y1. Then S of y2 is equal to 0.711. This value will be equating to 0.678, something like that. So we can approximately use 0.68. So once you use the value of E, you will have more number of numbers after the decimal point. That's why they have given round the answer to 2 decimal places. Option number 1, 0.62 and 0.68 will be the right answer. So this is for y1 and this is for y2. That's why they have given 2 answers here. This is how you have to solve a neural network problem, and this is how you have to find the output of the output layer. If they have not mentioned about sigmoid activation function, the problem will stop here. I want to add one more point here. I have seen few solutions where they have applied activation function in hidden layer as well. Sigmoid or logistic function should not be used in hidden layers as it makes the model more susceptible to problems during training. That problem will be called as vanishing gradient problem. This problem will occur when you train the neural network using backpropagation method. When you apply activation function in the output layer, the values of y1 and y2 are 0.62 and 0.68. What happens if activation is applied in the hidden layer as well as in the output layer? At that time also you will get 0.62 and 0.68. So if you want, I can even give you the values of H1, H2 and H3 after applying activation function. This is just for your reference. H1, when I apply sigma function on 0.51, I will get a value of 0.6248. For H2, when I apply sigmoid for 0.66, I get a value of 0.6592. And for H3, when I apply it on 0.81, I get a value of 0.6921. Now you have to use W4 with these values. So what is the output that you get for Y1 and Y2? Y1 you will get around 0.52347. Y2 you will get it around 0.72108. Now when you apply sigmoid activation function, you get the same result. But I'm just giving you the reason why I have not used activation function in the hidden layer. So if you take multiple neural networks books, sometimes the activation function would have been applied to the hidden layer. Sometimes you will have different activation function. One activation function for the hidden layer and another activation function for the output layer. You just understand the function of sigmoid activation function. It will take the input from the previous hidden layer and then squeezes the output between 0 and 1. So it is 0.62 and 0.68 in this case. When there are multiple hidden layers, it takes from the hidden layer that is next to the output layer. So that's why I have not used, and I am giving you an explanation for why I have not used it. Next question. Which of the following are commonly used parsing techniques in NLP, natural language processing, for syntactic analysis? So what are the parsing techniques in NLP? We have top-down early style parsing. Then we have bottom-up left corner parsing. So here option A, top-down parsing, can be taken. Then bottom-up parsing can also be taken. So early style parsing is also a technique. Since we find the name similar, we will also include option E. So what is statistical machine translation? SMT deals with automatically mapping sentences in one human language into another human language. So statistical machine translation will not be there in this parsing technique. And dependency parsing is also a parsing technique used in NLP. We will rule out only option D. So option D means 1 and 2 will be taken away. 4 will also be ruled out. In that case, we include A, B, C, E only as the answer. Option number 3 will be the right answer. Next question. In the content of alpha beta pruning in game trees, which of the following statements are correct regarding cutoff procedures? We have already learnt about alpha beta pruning in many previous year question papers. So using that knowledge, we will try to find out which statements are correct and which statements are wrong. So let's start with A. Alpha beta pruning can eliminate subtrees with certainty when the value of a node exceeds both the alpha and beta bonds. This is perfectly true. It means when the node exceeds those alpha and beta values, the entire subtree can be eliminated. Alpha beta pruning means you are removing something from searching the solution. So you are eliminating the subtree completely. The second statement, the primary purpose of alpha beta pruning is to save computation time by searching fewer nodes in the same tree. Yes, when you eliminate the subtree set completely, you obviously save the computation time by searching only fewer nodes in the same tree. So you take a game tree like this and you have lots of nodes like this here, and similarly you have lot of nodes like this. When you are going to eliminate this subtree completely, you have only fewer nodes to search. So in that case, we can say B is also true. The C statement, alpha beta pruning guarantees the optimal solution in all cases by exploring the entire game tree. This statement is actually contradicting A and B statements. And when we say alpha beta pruning, pruning means you are eliminating certain parts of the game tree. But here the statement is saying it is going to explore the entire game tree, which is totally wrong. So C is wrong. Once we find that C is wrong, 3 options will be ruled out at a time. Option 3 will emerge as the right answer for this question. Let's check D statement. Alpha and beta bonds are initialized to negative and positive infinity respectively at the root node. So this is also correct. Alpha will be initialized to negative value and beta will be initialized to positive infinity value. So D is perfectly right. So when this initialization happens at the root node, obviously there is a chance that the complete subtree can be eliminated. It can be pruned and only this subtree can be searched. So this says that you are going to search only fewer nodes and this saves computation time, and this opposes the idea of exploring the entire game tree. Next question, match list 1 with list 2. Let's take greedy best first search. It is incomplete even in a finite state space. So this is the statement that is going to help you in this match. A will be mapping to 2. We will rule out 3 and 4. Next is A star. A star usually runs out of space long before it runs out of time. The computation time is not the main drawback since it keeps all generated nodes in memory. So the main drawback here is space. Which option is actually correct for A star? Computation and space complexity is too light. I mean, they are the main concern for A star. So B is mapping to 4. From this we can say 2 is also ruled out. Though computation time is not the main drawback, they say before it runs out of time, it actually runs out of space. Then we have recursive best first search. So that is what is RBFS. The space complexity is linear in the depth of the deepest optimal solution. When we say something as O of n, we say this is linear. The space complexity is big O of D, where D is equal to depth of the deepest optimal solution. So when they say it is linear in the depth, it means it is big O of D. So C is mapping to 1. Then we have simplified memory bounded A star, that is SMA star. Simplified memory bounded A star is optimal if any optimal solution is reachable. Otherwise, it returns the best reachable solution. There is a case where if optimal solution is reachable, that algorithm is optimal. Otherwise, it does not end the algorithm without any result, but rather it returns the best reachable solution. So here we can say optimal if optimal solution is reachable, otherwise return the best reachable optimal solution. So whatever it is best reachable, that becomes the optimal solution. So D will be mapping to 3. Option number 1 will be the right answer. I have taken the statements that is going to support the list 2 part. I have not taken any other details because we have already discussed a lot about these algorithms in previous year question papers. Next question, match list 1 with list 2. We see B, D, M values here. Let's understand what are these. B is the branching factor, D is the depth of the shallowest solution, and M is the maximum depth of the search tree. Now we will see about the algorithms. Best first search is an instance of the general tree search or graph search algorithm in which a node is selected for expansion based on an evaluation function f of n. A star search expands nodes with minimal f of n value. So f of n is equal to g of n plus h of n. So they say from start node to a specific node and from specific node to the goal node. A star is complete and optimal provided that h of n is admissible for tree search or consistent for graph search. Then we will see about hill climbing. The hill climbing search algorithm. This is called the steepest ascent version. This is simply a loop that continually moves in the direction of increasing value, that is uphill. At each step, the current node is replaced by the best neighbor. That means the neighbor with the highest value or lowest heuristic h will be selected. So let's start matching. For best first search, B will be mapping to 1. It counts both the branching factor as well as the depth of the solution. So big O of B power D will be the answer for BFS. So regarding A star, they would have mentioned it as big O of B delta or big O of B power T. B will be the branching factor. Del symbol is actually the maximum absolute error. In best first search, we go with tree or graph search. So it is directly taking B power D. And here for A star search, we can map it to 4. The reason is it is the maximum depth of the search tree where we can use B power M. So instead of B power T, it is B power M. So we have two options matching here. We'll rule out 3 and 4. Now coming to hill climbing algorithm. At each step, the current node is replaced by the best neighbor. So how do we find the best neighbor? They say it's the neighbor with the highest value or lowest heuristic edge. It means by a single calculation, we will be able to find the best neighbor. So hill climbing will take the third option, big O of 1. A will be mapping to 3. Why do we map hill climbing to big O of 1 is because by calculating the heuristic h, we can find which has the lowest h value and we can pick up that neighbor as the best neighbor. It is actually a loop where you move in the direction of increasing value. So at each stage you have to pick the highest value and keep moving up the hill. Or you have to choose the lowest heuristic and just keep moving up the hill. So when I want to travel to a hill like this, I have to choose the best neighbor to move forward, then again the best neighbor to move forward. At a time I am going to choose only one. That's why we are mapping hill climbing to big O of 1. We will rule out option 2. Option 1 will be the right answer. Now depth first search. So if you are sure about depth first search complexity, then you can map D to 2. Next question. Arrange the following encoding strategies used in genetic algorithms in the correct sequence, starting from the initial step and ending with the final representation of solutions. What is encoding actually? The process of representing a solution in the form of a string that conveys necessary information is called encoding. First one is binary, representing a gene in terms of bits, that is in terms of zeros and ones. Then we have real value encoding, representing a gene in terms of values or symbols or string. In some other question paper, I have actually shown you the representation of binary encoding, real value encoding, integer encoding, then permutation encoding too. Then we have permutation encoding, otherwise called order encoding, representing a sequence of elements. This will be like 0, 1, 1, 0 in such representation. Then real value encoding will be in the form of decimal numbers. Then permutation will have 4, 5, 1, 2 and 3. So for the traveling salesman problem, this represents the cities that have to be visited. So this was one of the example I think I would have given in that video. So let's learn about gray coding. A gray code takes a binary sequence and shuffles it to form some new sequence with the adjacency property. A gray code representation seems to improve a mutation operator's chances of making incremental improvements. Usually a gray code is formed by just shifting only one bit. In a gray coded string, fewer mutations lead to a change this large. Even a single bit modification will make a big change. That is what they are trying to say. Real valued encoding is used when potential solutions contain continuous values like this that cannot be encoded easily with binary encoding. So we will choose real valued encoding for cases where binary encoding does not work. Binary encoding is like whether it is present or not, 0 or 1. But real value has continuous values. Encoding schemes where fitness depends on order, we say it is permutation encoding. As I said earlier, traveling salesman problem deals with the order of cities being visited in this example. When the fitness depends on value and order, we go with binary encoding, and when the fitness depends on value only, we go with real value. Actually, when you get into the genetic algorithm phase, you will come across three operators named selection, crossover and mutation. This permutation encoding is possible during crossover stage, and as we saw, this gray code representation will improve a mutation operator. We will start with permutation. Permutation encoding is about ordering. Think it is a solution and we will just find an ordering. So we will start with permutation. So we are starting with C. After getting an order, we are actually trying to shuffle to form new sequence with adjacency property. By shuffling, we are having more chance of making incremental improvements. So in that way, from permutation, we move to gray coding, which is option D. When we have gray coding, it is automatically a binary sequence. We go for binary encoding from gray coding. This is not encoding, this is just gray coding. With the permutation string, I am trying to find out the gray code. From the gray code, I am trying to do binary encoding. So this is A. When binary fails, we can go with real valued encoding strategy, where this is option B. Since the official answer is declared as option number 3, this is how we can perceive it. Next question. Arrange the following steps in the correct sequence for applying an unsupervised learning technique, such as k-means clustering is to a data set. So let's see the algorithm. First, we have to specify the number of clusters k to be assigned. Specify the number of clusters to partition the data into. D will appear first. So we are specifying the value of k. 2 and 3 will be ruled out. The next step, randomly initialize k centroids. The A statement, randomly initialize cluster centroids. So we have A in the next order. So this is initialize centroids of those k clusters. So we can rule out even option 4. From this, we can easily say option 1 will be the right answer. We'll just complete the steps. After initialization, we have a repeat until. So what is the next step? Assign each point to its closest centroid. This is the B point. Assign each data point to nearest cluster centroid. So we have B. Then compute the new centroid of each cluster. So update the cluster centroids based on the mean of data points assigned to each cluster. So they have given this as mean. So next comes step C. Here we are assigning points to centroid, and here we are computing new centroid. Then after that, repeat steps B and C until convergence criteria are met. So this is under a loop. So these two steps, B and C, assigning and computing, are to be repeated until convergence criteria are met. So repeat until the centroid positions do not change. Until they are changing, you need to compute it again and again. Once they do not change, you can stop the algorithm. That is what this repeat until says. So E will be the next step. It says repeat B and C till some criteria is met. So that criteria is the centroid positions do not change. The algorithmic steps of k-means clustering has been already asked in some other question paper, and if you want to know about other unsupervised techniques and supervised techniques, you can always refer to the machine learning series available in my channel. The series is available in Tamil language. Even if you don't understand Tamil, you can still follow the video because the content is in English. So option 1 will be the right answer. D, A, B, C, E is the correct order of the steps. With this, we are completing Unit 10 solutions. And with this, we are completing December 2023 Paper 2 solutions.